प्लीज अपना वीडियो ऑफ कर देंगे प्लीज, लाइव स्ट्रीम चल रही है। जब मीटिंग स्टार्ट हो देन उसके बाद वीडियो ऑन कीजिएगा।
हेलो, hello. Am I audible? Hello. 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 हेलो। हाँ, मैं नहीं सुन पा रहा, आपको वही प्रॉब्लम होता है। तो हाँ, चलो आशीष देख रहा है, 1 मिनट क्या करता है, इसमें कुछ कर सकते हैं। हाँ, ओके ओके।
क्या इशू है?
मेरा जा रहा है, उनका नहीं आ रहा है। वीडियो स्टॉप करूँ ना?
त्यांचं तुम्हाला आवाज येत नाहीये का? सर आप आवाज आ रही है सर आपको?
हाँ, अब आवाज आ रही है। हाँ हाँ, आवाज आ रही है अभी। Now it is perfect. Yeah.
हाँ अभी हम पोस्ट कर रहे हैं। हाँ एक सेकंड हाँ तुमने हैंड रेज करेगा नहीं तुम्हारा वाला अभी बनेगा वेरी गुड अच्छा वेरी गुड बड़ी चल बच्चों के लिए काम करता है ये हेड है WRD कॉलेज हेड डायरेक्टर अभी कर रहा है पहले भी क्या मैं तो सो गया था अभी यार मैं देख रहा हूँ 90 से लेके 90 बाद
आवाज आ रही है
कोई एक कमेटी तो आइडियली कुछ वर्क कर लूँ वैसे ओके
एक बार हमने लीडरशिप में अपनी मीटिंग में हो जाएगा
जमाने कहाँ चला गया
काफी हो गया वाईफाई एक्सेस कर काफी हो गया
वहाँ पर जाने के लिए जाना ज्वाइन करो कब करोगे जुलाई में तब तक पिक्चर क्लियर होगी कि पंडित जी को कोई साल मुझे अगर नहीं निकाले हैं ऐसे तो नहीं पंडित जी को इसको ही पता लगेगा इसको ही पता पंडित को फायदा होगा पंडित जी को फायदा होगा तो पता तो नहीं है वैसे तो बहुत स्कूल हाँ मुझे बताया मुझे आपसे नहीं बताया और नहीं जब करोगे तो अपना आप कुछ होगा वैसे नेपाल में तो वैसे ही बहुत ज्यादा रिलेशन है नहीं नहीं बहुत अच्छे पॉजिटिव वाइब्स है ये देखो ना 250 बच्चे तो इनिशियल बैच में 5 बैच में ट्रेन हुए थे 96 से नहीं यदि और सीनियर लोग हो ना वो किसी तरह से लोग आपस आ रहे हैं डिड नॉट फील अनकंफर्टेबल एट ऑल इट वाज वेरी वेरी वार्मिंग काइंड ऑफ आपने ऑर्गेनाइजेशन के बंदे से आपने ग्रुप कराई है ना ऑर्गेनाइजेशन के बंदे तो आपके सारा काम करेगा ऐसे सुनिए कि आप फोन करने वाले ऑर्गेनाइजेशन के बंदे क्रिटिकल ऑर्गेनाइजेशन के बंदे यहाँ तो फोन करो पर दूसरी जगह तो आप अहमदाबाद में उन्होंने करा सर्विस कैसे कर सकते आपको जानता कौन है मैं जानता हूँ नेटवर्क भी तो आपके पास नहीं है ऐसे ही आपको करना जो प्रेसिडेंट है ही हैपन टू बी ये बैचलर आई एमटेक थीसिस सुपरवाइजर एमआईटी
या देखेंगे जगह नहीं
से तो
नहीं आप रहने नहीं दिया आपके पास वहाँ पे कोई नहीं
Hello, hello. Am I audible? Morning to all of you. Welcome to the first national conference on glacial lake outburst floods and landslide lake outburst floods disasters in Himalayan region, which is jointly hosted by Bureau of Indian Standards and IIT Roorkee. So I welcome you all to this particular conference. And this particular conference is more special because this year we are celebrating 175th year of establishment of IIT Roorkee. At the same time, we are also celebrating 75th year of celebration establishment of Bureau of Indian Standards.
great
So that's a very big. So our program goes like this, which I have already shared with all the dignitaries, our panelists, as well as all the people who ever joined us through online as well as offline. So to welcome all the dignitaries, may I request Dr. Shri R. Bhanuprakash and Dushyant Prajapati, sir.
Happy morning, good morning, everybody. I privilege to welcome all of you to the National Seminar on Glacial Lake Outburst Floods and Landslide Lake Outburst Floods Disaster in Himalayan Regions. So today we have a very eminent speakers, esteemed professors, research scholars, and students with us. To all of them who were joined on the online and even on YouTube also, I welcome everybody to join this. And this incident, the Glacier Lake outdoor floods and man-made yellow incidents in the recent times have already raised an alarm for more such incidents in future. It is high time for us to act. National disaster management has already taken first step towards mitigation of disaster from GLOF. This is one most talked about subject. On this occasion, I would like to welcome the speakers for the day today. Professor C.S. Rosa, Department of Civil Engineering, College of Technology, Roorkee, Dr. Arun Kumar, Professor, Head of the Department of Civil Engineering, Roorkee, Dr. Anil V. Kulkarni, who has joined onsite from Indian Institute of Science, Dr. Ravindra Singh, NDNA, New Delhi, who has joined online, Dr. Sanjay Kumar Jain, sir, from National Institute of Hydrology, he is available physically, Dr. Tapas Ranjan Mata, NRSC, Hyderabad, Dr. Praveen Thakur, and Dr. Pratima Pandey, Indian Institute of Remote Sensing, Dehradun, and all other dignitaries. And I once again welcome all the speakers and the participants and wish them for a successful and full event. The whole day is with you, and the first half is for the national seminar, and the second half will be the brainstorming session, as we have already separated. We are connected through WebEx and as well as YouTube. Welcome all. Thank you.
Thank you so much, sir. So, may I now request Engineer Sanjay Pant, sir, who is Deputy Director or General of BIS, to kindly give his keynote speech about BIS. Sanjay Pant, sir.
Correct, Chetan. Sir. Access. Okay. Okay. Attending. Access. Attendee access. Connected.
Thank you. At the outset, there may be little bit disturbance because I'm away, so my apologies for the same. At the outset, I would like to congratulate first of all IIT Roorkee and my own team for organizing this important seminar, national seminar on glacial lake outburst floods, GLOFs, and landslides lake outburst floods, LLOFs, disasters in Himalayan region, and at the venue of IIT Roorkee. First of all, I would like to thank and welcome Professor CSP Ojha Sahab from Department of Civil Engineering, IIT Roorkee, who would be giving his introductory remarks and later would also monitor the brainstorming sessions and the panel discussion. Dr. Anil V. Kulkarni ji, Dr. from Indian Institute of Science, Dr. Ravinder Singh from NDMA, who was spearheading the entire GLOF and LLOF's entire documentation campaign from NDMA, where BIS was also a party. Dr. Sanjay Kumar Jain from National Institute of Hydrology, Dr. Tapas Ranjan Marthaji from National Remote Sensing Center, ISRO Hyderabad, and Dr. Praveen Thakur and Dr. Pratima Pandey from Indian Institute of Remote Sensing. I welcome all of you and all the participants. The seminar has triggered a lot of interest as the response that I have been receiving. Particularly, today's mantra is sustainability. In all development, India is on the path of rapid development, and this is equally good for true for the Himalayan region also, because we have a strong development program which has been launched by the government of India in the Himalayan region too. And in the process, when we see development, cannot be this is the only way to have development, that is sustainable development, and therefore it is very important that all facets of sustainable development are taken care of. To my mind, it comes that the mother of all sustainability understanding is safety, security, durability. Unless we have such structures coming up there, they are programmed to have ensure safety, security, rest aspects of sustainability, whether it is water efficiency or maybe energy efficiency, would not work. So the foremost is that the disaster resilience, and therefore in this context, I am very happy that BIS and IIT Roorkee have joined hands, and they are able to organize this event. This will not be the only event. There are going to be series of events. In fact, BIS has a MOU signed with the Indian Institute of Roorkee, and we have a standardization chair created at IIT Roorkee, and we'll have a series of initiatives and activities with IIT Roorkee, and similarly with other institutions also. And so that I take this opportunity to once again thank IIT Roorkee for joining hand with BIS as one of the first initiative after we joined and created the standardization chair at Roorkee. And I wish the event a grand success. Thank you so much.
Thank you so much, sir. So may I now request Arun Kumar, sir, to kindly tell us about the association of IIT Roorkee with BIS. So Arun Kumar, sir.
Okay. So, good morning, everybody, and Professor Parida, our Deputy Director, and Professor Ojha, and Mr. Sanjay Pant, DDG of BIS. And in fact, it was about in 2019 December when I walked in the office of Mr. Pant, and then we tried to revive that what BIS is doing and what IIT Roorkee is doing. In fact, IIT Roorkee is very much associated from the very beginning, since beginning of BIS activities. But somehow for the last few years, in last 2 decades, has been relatively low. But when we learned that BIS has gone into phenomenal changes in terms of organizational as well as their approach, and that has resulted into MOU with IIT Roorkee to carry out activities in different areas of our uniqueness. Like our uniqueness is not only civil engineering, earthquake engineering, and there are some other areas. Water sources is one of the very strong areas. I remember in 1982-83 there have been meeting in this room of BIS when our Professor Bharat Singh, Professor Chawla, and others professors used to be there. Many meetings used to happen in this very room, in this very building over there in 1982, 83, 84, 85. Many meetings used to be here. But nevertheless, IIT Roorkee is representing almost 9% of various committees. They have 15 divisions, and out of them, especially in water sources and sewage divisions, there are a large number of representations of IIT Roorkee's expertise. But at the same time, in the recent initiatives which has been taken by BIS and our leadership of institute, and where all departments now are getting activated, and like for pulp paper technologies and metallurgy, even our electronics, which were relatively low participation, but now it has increased quite high on that sense. And similarly, in the various other aspects of discipline of chemical engineering, others also will increase with this initiative. I would like to also mention that this is both sides. It's not only that BIS is coming out, but also we as a faculty and as a student now, you will be happy to learn that BIS is also open for the students, research scholars, because they are here for 3-4 years, 5 years, and in that they can also become the alternate member of the BIS if that happens to be there, and that is a very nice signal from the BIS side that our faculty and our research scholars can take part on this very actively. So with this note, I would like to say this first division. I also recollect this 9 years back. It was on 16th, 17th of June. So it's about almost 9th anniversary of our famous glacier of Kedarnath happened on 16th, 17th of June 2013. So it's almost now 9 years back. Today is 15th, so it's almost 9 years back when this the very topic of GLOF have happened, and that has brought a lot of notices, and that requires a lot of instrumentation place. And recently last year on 9th of February 2021, Chamoli happened. So these kind of things happening, but again, when it happens, a lot of activeness comes. But after 1 year, 2 years, when it comes to implementing, especially the instrumentation part, and that becomes somehow again back to the thing. So I would like to say the BIS, since it is coming up with the standards, and when the standard comes, let me tell you, all government wakes up very quickly when the standard comes. So the standard plays a very significant role in that sense. Standard means, okay, this is the standard. Otherwise, it becomes only a cup of, a paper of self. So with this, I like to say that congratulate our BIS with this initiative and our team led by Professor Goswami, and then Professor Oja and Professor Monti, and Professor Maheshwari, where now all departments are represented by some coordinator in this group. And till we have a chair, now since chair has been established, so chair advisement also has gone, I think, and then once chair comes, he will take care of this BIS partnership. So thank you very much.
Thank you, Professor Arun Kumar ji. Thank you so much.
Thank you, sir. So may I now request Professor CSP Ojha sir to kindly brief about this particular conference.
First of all, very good morning to everyone here, and Panji, who is also present online. In fact, our colleague Deputy Director, Professor Pariga, is here, and he will be soon joining as Director CRI. So I think with this good news, we hope that the IIF and IIT Roorkee will, take to greater heights. Professor Arun Kumar has been my senior since IIC days, and I'm very happy that he planned to coordinate this activity. It was also a great moment for me to meet the officers from BIS, and we really looked into what we are going to plan out of this conference. Friends from NIH, my colleagues from Department of Civil Engineering, WRDM, and Earthquake. So all are present here. So a very happy, and Professor Arya, team administration, IIT Roorkee is also here. So I think very good morning to all of you again. This region, the Uttarakhand, I think whenever we have some problem, at that time if we plan our activities, that's not a wiser state. And it's in this regard that the different faculty members and scientists in NIH, they have been working on the glaciers for a very long time. And each one works in his domain, and perhaps we don't have much interaction to see what they have done and how we can pool those knowledge together, right? So for this important event which we planned today, and of course we have the expertise from IIRS, Wadia Institute,
All these scientists are there. They have been working on these glaciers for a very long time. So certainly this conference is unique in the nature that it is going to pull everyone and try to really know that what kind of work they have been doing and how the knowledge which has been gained for several years can be accommodated while framing this code, right? So that's the ultimate goal of this. So when we are talking about glacier lake outburst floods, okay, or landslide lake outburst flood, these two are very important. And we know that several incidents have taken place in the past. And unless we have some code, because hydrology is a very complex subject, we cannot simply say that this is Bayes' law. For example, just to be on the lighter side, we say P into V is constant. If we say V is the volume of lake, then what is P? Is it precipitation or is it pressure? We have to really link together, right? So when we are talking about a lake having a larger volume, is it dangerous? Is it because of the larger precipitation or what? Similarly, when we talk about, I was just discussing with Thakurji from IIS, that what happens when you apply Charles' law in hydrology, does it work? P by T is constant. It does not work that way, right? So if temperature is more, can we say that precipitation is also more? There are many things, right? So we just cannot give simple analogy in terms of pressure or precipitation and existing physical laws, right? So hydrology is a complex subject. In fact, the trouble is that recently we are asked by DGRE to deal with a problem in Ladakh region. And I'm supposed to go there. The challenge is that the river itself is changing its course and nothing is known about how much flow is coming, how much debris is coming. So see the complications in any glacier dominated region. So we have to really figure out that how much this flow could be there, how much sediment concentration could be there, because unless we know these things, we cannot plan anything. Any engineering activity cannot be planned. So even for the safety of our army personnel, safety of our infrastructure, the knowledge of this is very vital. So it's not only confined to that a particular incident took place in Uttarakhand, and then we try to just focus our attention on that. It is much beyond that. So for the safety of our army personnel, so we have to really work into that. And what we are planning out of this event is that we'll come out with a code which will look into what kinds of problems are possible, and we should have some guidelines so that the better preparedness can be achieved, right? So that's the ultimate goal of this. So hope that experts who are participating today as a part of the panel discussion also will try to pull this knowledge and try to see that a meaningful document comes out of it. So that's the purpose of this conference, and I hope I've been able to give this clear message to all of you. Thank you very much. Thank you so much, sir. So the guest of honor for today's program is Professor Manoranjan Paridar. So Paridar sir is Deputy Director of IIT Roorkee, and as Oja sir already told, that very soon he is joining as Director of Central Road Research Institute, which is a lab of CSIR. So congratulations to you, sir. And he's an eminent scientist, and I have already shared his biodata as well as shared the biodata of all our dignitaries present in the dais with you all through the WhatsApp link, so you can go through their achievements. So may I request Paridar sir to kindly give his keynote speech.
Thank you, Professor Ajanta, for all the nice words, nice introduction. First of all, a very good morning to everyone. Specifically, I would like to extend a warm welcome to Sri Sanjay Pant, Deputy Director General BIS, Sri R. Bhanu Prakash, Director and Head WRD, my colleagues, Professor Arun Kumar, Professor CSP Oja. Then both, because this is a hybrid event, we have Dr. Anil Kulkarni from IISc, then Dr. Ravinder Singh from NDMA, Dr. Sanjay Jain from NIH, Dr. Tapas Ranjan, Dr. Praveen Thakur, Dr. Pratima Pandey, and physically we have like our scientists from NIH, my colleagues from different departments at IIT Roorkee. This is a subject where we have active participation from more than 4 departments, like it's HRAD, Department of Hydrology, Department of Civil Engineering, then Department of Earthquake Engineering, Department of Earth Sciences. So I'm very happy that the entire approach is multidisciplinary, including we have also Center for Disaster Mitigation and Management. So while the major focus of the MOU has been with respect to standardization, which is the mandate of BIS, but I am sure it also provides a lot of additional benefits. It has been possible to invite so many scientists, so many experts from different institutes in the country, and also different departments of IIT Roorkee, NIH. So that's how I'm sure like the deliberation is going to be extremely useful. Professor Ajanta mentioned that this is the event part of our 175-year celebration, which is going to culminate on 25th November 2022. And the like starting or initiation of interaction with BIS or focus on say development of different standards for BIS is definitely a welcome move. And I'm sure like with inputs of my colleagues from different departments, we'll be able to provide great inputs. In fact, this is the national seminar on Glacier Lake outburst floods and landslide lake outburst floods and disaster in Himalayan region. At IIT Roorkee, I will say that we have a great opportunity of working in Himalayas as a living laboratories, and we have very eminent institutions around us, be it say Wadia Institute, be it like Indian Institute of Remote Sensing and NIH. So we are really privileged that we have a lot of input from all these places. And I'm aware that some of our colleagues are working on the different aspects of these disasters. In fact, so they can definitely provide significant inputs. And we have Professor CSP Oza, who is going to moderate the entire activity. There is a panel discussion at the end of the day. Professor Oza is a fellow of Indian National Academy of Engineering and also Institute Chair Professor. He has a very rich experience, and I am sure his inputs will be very critical in the development of this particular standard. In fact, I'll say that I am not directly associated with BIS, but in the transport sector, I am very actively associated with Indian Roads Congress. Like we take a lot of pride in contributing towards development of new codes of practice. And while this deliberation goes on, we can definitely identify like in what way we define our academic research, sponsored research, and also it's a great opportunity to design, in fact, multi-institutional projects, right? I know many of our departments are already doing that. While we are working for the codes, then we can definitely in the process, we can think of creating or submitting new projects for different sponsoring agencies. So with those words, once again, I wish that this deliberation is going to be very successful. And Department of WRDM they have come forward. They are very active in hosting seminars, conferences, and developing these kind of collaborative activities. So once again, I extend a warm welcome to all the participants and wish this particular seminar a great success. Thank you.
Thank you, Professor Parida, and glad to see that you would be joining as director of CRRI. I'm away in Geneva, so I would have been personally with you, in this event. So I only take this opportunity to thank you. And I think like IIT Roorkee, we will have a deeper interaction with the CRRI. CRRI is part of BIS, so many committees, and we'll look forward to, I'll personally meet you and take your support in the process of standardization. Thank you so much, sir.
Thank you, Mr. Pal. Thank you.
Thank you, Professor Pal. So once again, good morning. Welcome to this session, the national seminar. So today we are having a national seminar, the Glacier Lake outburst floods and landslide lake outburst floods, disasters in Himalayan regions. So again, warm welcome to everyone. I would like to thank Professor Sanjay Panji, Deputy Director General, for gracing this occasion and providing his insightful comments on the GLOFs and LOF disasters over Himalayan regions. I'd like to very, very warmly welcome and thank Professor Manoranjan Parida. And I also wish you all the best, sir, for joining as the director of CRI New Delhi. So many congratulations. I would like to thank Professor CSP Ocha for gracing this occasion. And I'm sure like today's event is going to be very, very fruitful. because we'll be having discussions on the generation of boards for this kind of disasters over the regions. So the panel discussion would be going to be is going to be actually very insightful, and I welcome everyone to have like involvement in this particular occasion. I'd like to thank Professor Arun Kumarji for helping us throughout for arranging this session. So it was a very huge event and huge task, and in a short notice, with his support and all other support, we're very happy to organize this event. So thank you very much, sir. I'd like to also thank the officials from BIS, Bhanu Prakashji, Dushyant Prajapati, and Navdev Yadav for providing us a great support in arranging many things for the preparation of this event. I'd like to thank all the speakers like Praveen Thakurji, Professor Praveen Thakur, all the delegates who have come from NIH, from Department of Water Resources Development Management, from Earth Sciences, from Department of Hydrology. Thank you very much for coming to this occasion. I'm sure afterwards we'll be having the panel discussion, and all the discussions are going to be very fruitful for this, because this is a very important discussion of the day. I would like to thank all the speakers who will be delivering the talks, Professor Anil V. Kulkarni, Professor Ravinder Singh, Professor Sanjay Kumar Jain, Professor Dapa Sanjan Martha, and Professor Praveen Thakur. So thank you very much for coming to this occasion. I'd like to thank all the delegates and all the people who have come from IS and Wadia Institute also. You have been doing a wonderful work in this area. So thank you very much for coming again. So last but not the least, thank you everyone who have directly and indirectly provided us all the support for organizing this event. Looking forward to a wonderful day today. Thank you very much.
Thank you so much to all of you for joining us in this inauguration program. And with this, we have ended our inauguration program. So our BIS team, Bhanupakar sir, he want to welcome all, thank all the panelists in the dais for gracing this occasion. So Bhanupakar sir.
Sir,
आप आजाद दे दो अदर सभी का कंबाइंड आ जाओ इधर आप बोलते हैं आपके
कम
अर्जुन तो
Yes, sir.
सर हो जाओ तो सर होस्ट से तो होस्ट को तो
Thank you so much. And Europe Indian Standard stands for standardizing everything, and IIT Roorkee stands for setting out all the standards. And with that, we have completed our inauguration in right time by 10:30. And now we are going to start our first keynote lecture on GLOFs. And our first keynote lecture is by Dr. Anil V. Kulkarni, with a distinguished scientist at IIT Bangalore. So I think Anil V. Kulkarni needs no introduction. We are very proud to say that he is an alumnus of IIT Roorkee. He did his MTech from IIT Roorkee way back in 1978-79. Then he joined McMaster University, University for his MS. Then he did his PhD when he was working as scientist at SAC Ahmedabad, which stands for Space Application Center Ahmedabad. So after that, he joined IIT Bangalore as distinguished scientist at Division Center for Climate Change, and he has been contributing tremendously to the cause of studies on glacial lake outburst flood, glaciers, cryospheric sciences, and he's been awarded, and the list of awards is already shared with all of you. And he is also, he has trained many young people in the field of glaciology as well as 10 to 12 years through many programs, and out of which one of the main program is sponsored by DST, and he is continuously training people since last, I think, 10 to 12 years. And whoever is doing glaciology in the last 10, 15 years, maybe it would be wrong to say that almost all of them, or at least 90-95% of them, are trained by our Kulkarni sir through this training program. So, Kulkarni sir, I welcome you to kindly deliver your lecture on GLOF. Before you start your lecture, sir, so may I present a small video which is actually prepared by Kulkarni sir only and his team. So let me share the.
टीवी में आवाज में डाल, टीवी की आवाज में डाल दो, टीवी की आवाज में स्पीकर चेंज करके टीवी की आवाज में
Infrastructure and natural resources. Therefore, we have developed a model based on laminar flow method to determine the volume of space. This model is based on flow law, wherein the thickness of the glacier is determined by its surface velocity and surface slope. Once the glacier thickness is defined, the difference in glacier thickness and surface topography.
Video is not there, only audio we can see.
Topography
Video cannot be seen.
locations where the future lakes will be formed by locating the overlay lakes. Not just this, this model is also used to determine the future lake extent and
Video
its
is
historical data.
So we are checking.
So, in order to apply this model across the Himalaya and study glacier lakes, we have automated this model and we call it Glazing, which is short for increasing. The Himalayan region has the largest collection of glaciers outside the Alps, and due to the global warming, they are predominantly melting. When these glaciers retreat, they make way for the formation of glacial lakes. And over time, these lakes expand, and when they burst, they cause flooding in the downstreams. Such an event is known as glacial lake outburst flood, or in short, GLOF. GLOFs can cause huge damage to human settlement, infrastructure, and natural resources. Therefore, we have developed a model based on laminar flow method to determine the volume of lakes. This model is based on flow law, wherein the thickness of the glacier is determined by its surface velocity and surface slope. Once the glacier thickness is determined, the difference in glacier thickness and surface topography gives us the belt topography. From the belt topography, we can determine the locations where the future lakes will be formed by locating the overlay lakes. Not just this, this model is also used to determine the future lake extent and its volume using historical data. So, in order to apply this model across the Himalaya and study glacier lakes, we have automated this model and we call it HITHIN, which is short for Himalayan Glacier Thickness Method. The HITHIN tool is automated using Python scripting. Now we present a demo of the tool by applying in Deepika Glacier or Parvati Basin in Himachal Pradesh. All input data are required to be stored in a single folder, which will be selected as the workspace folder. For the present example, the data folder is selected as the workspace folder, which has all the inputs. The first folder is the boundary of the glacier as a shape file. The picture shows the boundary of the Deepika Glacier. The next input is the contour polygon for every 100-meter elevation band of the glacier. This is generated through GIS software using digital elevation models. Next is the flowline folder containing multiple flow lines drawn manually for the glacier, and each flow line is saved as a separate polyline. The moraine folder has the extent of the lateral moraines of the glacier. This is digitized manually till the mid-elevation region of the glacier. Next is the raster folder having the velocity raster and the DEM in their format. The DEM of the current region is extracted from the raster global DEM, and velocity is generated by using the pixel correlation of lines and image phase. Now, in order to
Voice is gone, I think. Voice is not there.
Participants. Inside the overhead folder, and once we go inside the overhead folder, the first one will be the glacier underscore bed, which is a raster file showing the glacier bed topography of the glacier. The next output will be the lake shape, which is a shapefile showing the aerial extent of the predicted lake, which may form in the future. And the final output is going to be the lake underscore extract, a raster file which shows the depth values of the lake at each pixel. So these values can be used to find the volume of the lake, which is being predicted by the model. Finally, we can check the lake underscore details .csv file, which provides all details of the predicted lake in a CSV sheet. And this includes the area of the lake, the maximum depth, the mean depth, and the volume of the lake. The information provided by this tool will be helpful for many simulations of our ground, performing hazard assessment, and to develop mitigation measures in the event of glacier lake outburst.
this work is carried out under the INRIT project initiated by MHRD. The project is also financed by MOAS, Ministry of Earth Science. We are also thankful to the Nature Center for Climate Change in the Ministry of Science for support.
Okay.
So now should I share your PPT or you want to share it from your end?
Yeah, maybe I can try to share it. Let me see if I can share this. Yeah. Can we share this?
Yes, sir. सर आप मतलब आप ही करेंगे क्या?
हाँ, I will share. हाँ, मैं करता हूँ. हो गया share?
Yes.
You are able to see it now?
You can see, sir.
Okay. So, shall we start? Am I audible now? Hello.
Yes, yes.
Yeah.
Yes, sir.
Okay.
Finish, please.
Thank you very much, Professor Ajanta, for your nice introduction. And it is indeed very wonderful to see my old friend and colleagues there in Roorkee, and definitely I'm missing this outing to Roorkee. So particularly Professor Oza Good morning to you. And it is long time after seeing you, and I hope I wish to meet you sometime. And then Dr. Pan, Dr. Parida, Arun Kumar, all of you. Good morning to all of you. So what I shall talk today is about glacial outburst floods, and of course floods caused because of the landslide, which is formation of lakes. Even though this particular seminar is about the Himalayan terrain, because title says that, but eventually Bureau of Indian Standards need not restrict to the only Himalayan terrain. Of course, glacial lake is a phenomenon of predominantly cryosphere region, and Himalaya has only cryosphere. But that does not mean there is no flash flood in other parts of India. And particularly if you see, due to change in climate change and recent flash flood occurring into the Western Ghats, particularly parts of Maharashtra, part of Karnataka, and also Kerala, it requires very detailed investigation to understand what it is causing and whether it is caused because of the temporary formation of lakes or not. I'm not sure there's enough investigation has gone into that, but there looks to me definitely some extent the formation of lake due to landslide and the land flash flood could be a pan-Indian phenomenon. Particularly the Western Ghats is definitely susceptible for that. So we need to look into when we are defining the standards, probably we need to look into the all regions of Himalaya, which might have different causes for landslide or flash flood. So I think we should keep that in mind while moving ahead into this. We just now we have seen a small presentation which talks about the work which we have done here at the Indian Institute of Science, but there are definitely partners in it. We need IIT Bombay, IIT Roorkee was also, Ajanta's work was significantly contributed into the completion of that project, and IIT Guwahati was also part of this. So this work was done in collaboration with three IITs and IISc. Probably in that sense, it is very unique work because some of the premier academic institutions of country collaborated to carry out that work. Um, we know that why glacial lakes are formed. I will not go into the details of this thing because how the depression gets formed into the Himalayas, and that depression, when glaciers start retreating, the ice vanishes from this depression and the ice is filled by water, and which is leading to the formation of the lakes. There could be numerous reasons why which these lakes can burst, either due to cloud burst, we have seen a couple of times, or there could be snow avalanches into that, there could be landslide, there could be a moraine melting, or there could be earthquake. There could be numerous reasons or causes for outburst of this flood, but definitely that moraine, which is temporarily holding the water and damming the water, has given away because of the various causes. There could be multiple causes, there could be single cause, whatever may be the peculiar case of that time. This is the work which is recently done. Probably more detail will come when in National Remote Sensing Center going to talk about that. But we already know that in glacier lakes inventory in the basin suggests that there are a large number of lakes which are forming. Some of them are could be glacial lakes, some of them may not be glacial lakes, but this is indeed a major area of concern for us that as climate is changing and as glaciers are retreating, we have large number of such lakes are forming, and this is one of the good inventory which is carried out by National Remote Sensing Center. And recently, 2021, this paper was published in Indian Society's Journal of Remote Sensing. In addition to that, one of the students of IIT's Roorkee, which is Asim's work, which also suggests that there are large number of glacier lakes in Alaknanda Basin as well. This work, which is done by Asim and published in 2020, suggests that numerous such lakes in Alaknanda Basin. And remember, one of the lake which has one of the region where lake was identified, which is from where this Nanda Devi glaciers are originating, one of those things. But of course, that lake has not really given away and caused that flood. But there are indeed numerous lakes in there, and there are large number of hydroponic plants are also there. We are quite aware of all these things. So we are also talk about my small clip of video that we have developed the hydrodynamic modeling. But that was particularly shallow water approximation to estimate the glacial depth of glacial ice, and from there invert it and get the uh, extent of potential where lakes can fall, as well as you can have a historical data. You can also calculate what is the depth of existing lakes also can be carried out by that. But in addition to that, in order to do the flood analysis, also there are hydrodynamic models are required to understand the flood, and there's a lot of work which is done in this direction. You can either use the commercially available software, or you can write your own code if you are resourceful enough, or you can modify the existing codes to do that. And essentially, we require input parameters like topography, bathymetry, frictional resistance, initial value of water level, boundary condition, rainfall, stream flow. So all these input parameters can be given, and it can provide you the travel time taken from place of origin to nearest human settlement. It can also tell you what will the velocity of water, how much depth it will give. And model can be simulated under different conditions of the rainfall. So this is a small clip, maybe it will work. So you can show here that this is the work which is done by using, is it running? Yeah, I think now it is in. So this is how you can simulate. This is the South Lonak Glacial Lake in Sikkim, and you can simulate that how much time it will take that flash flood to flow. You can also decide that how much water it will release. It is not necessary that the entire lake will be dew water. Some portion of lake can be dew water. So you can simulate. So there are a lot of techniques now are available, and tools which are available with us, which can tell us that. So this is another work which is done by Asim in 2021, which will tell you the flow path and velocity of this. So you can say how much distance the flash flood can travel. You can also carry out the hazard intensity mapping. That is also work where you can find out how much is the intensity, whether it is a low hazard, whether it is high hazard, and whether it is a medium hazard. That kind of work can be also done. There is also a lot of efforts are being done to mitigate and to create the early warning system. And I'm sure South Lonak Lake is one of the a lake where a lot of work is being done, and I'm sure some of the speakers later on will talk more detail on that. So some of the engineering intervention was done because the state government was very proactive, and all this idea was started by one of the paper which is published by ISRO, and then subsequently DST formulated a committee where I was a part of that, and we prepared certain measures to make sure that some engineering intervention, and the state government made an effort to have a siphoning system there. And now I think some other agencies from Switzerland is going to have early warning system. So this is one of the success story we can look into this aspect, and I'm sure there will be much more talk in that. In addition to that, the flash flood, which is going to happen into the mountains, particularly Himalayan terrain, not necessarily only because of the retreating glaciers and formation of moraine dam lakes, but it can also form because of the hanging glaciers and landslide. This is something which has happened precisely into the recent flash flood from Nanda Devi biosphere, where you can see here is that this is slightly different. This picture is taken in Spiti Basin, but you can see the cracks are being developed. You can see very nicely cracked. This is the hanging glaciers, and this photograph is in Spiti Basin. So entire that huge patch can come down, and along with that, it can also bring down significant amount of rocks and debris, as well as the portion of mountain can also it bring down, and that is precisely has happened in the Shiganga flood in 2021, where you have seen that. But you have seen this picture, many of you would have seen, and some other will talk about that. But what essentially you can do is him tool, which is developed and about which presentation you have seen, can help you to understand how much is the volume of ice stored into that hanging glacier. So here you can see that approximately when him tool was applied to the ice patch, which was fallen down, approximately 6.86 million cubic meter of ice was stored in it. And how much is it has come down, you can see that 25 million cubic meter of volume has come down. This is work of Pratibha's work, and I'm sure she will talk about that in her presentation. So I will not go into more details about that at this stage. So you can see that the amount of um, mass which has came down, out of that only 6 to 7 million cubic meter is only ice, and remaining is about 19, 18 to 19 million cubic meter is a rock. So you can see that this can accelerate and this process can change dynamics of flash flood. We also know that the moraines, depending upon the peculiar condition of the terrain, can, under heavy rainfall condition, can fall down and create a landslide. But remember, this landslide is high altitude morainic terrain, and that is probably has happened into the Kedarnath in 2013, and eventually leading towards the creation of small lake, which was led to the flash flood in Kedarnath. So some of you are quite aware of this, and this has caused a huge disaster in Kedarnath. In addition to that, there was also a disaster in 2005 in Himachal Pradesh, where what it is called the Paruchu Lake. This is still, in my opinion, not gone into the enough scientific investigation to understand what is the source of water in it. Essentially, because this disaster has happened in 2005, but if you look into the images of 2004, which is the previous year to that, this Paruchi Lake had a history of accumulation of water and then dewatering it, but it has never got a flash flood except in year 2005 when it has burst, it has crossed the flash flood. So if you really look because now we have modern tools for us to understand, which were not easily available in 2004. We have high resolution DEM and other data. You will realize the amount of water which is released by that flash flood, and the capacity of this lake to store water is a huge gap. There's a huge gap between these two, and we need to really understand what it is. So if you can really look into the overall scenarios of flash flood into the Himalayan terrain, so you have numerous conditions, but one of the conditions is that many of these changes are taking place in the high altitude cryosphere region where glaciers have retreated or glaciers are retreating, leaving behind the moraines, leaving behind the very loose material, and the geology and geography of that region is extremely dynamic and creating a environment by which it can have a flash flood. So we really look into all those issues in much more critically and differently. And I think this seminar had thoughtfully prepared. Some of the titles suggest that we are going to do a couple of those things. So with this, I would like to stop here, and thanks a lot for inviting me to share some of my ideas on this. So thank you very much. So,
Thank you so much, sir, for this wonderful lecture and ice-breaking about what exactly is happening in the field of glaciology as well as GLOF. And I'm sure that all our panelists as well as all the audience have benefited a lot. And we are looking forward to your participation in the panel discussion also, where we will be discussing about standardization. So thank you so much, sir. Thank you. So, I'm sorry, to unshare your presentation, so that we can move to the next presentation. फिर मैं चला गया यूएस यूनाइटेड नेशन चला गया थे अफगानिस्तान where someone go there it will not happen. Sure. Yeah, the consultant want to ask some question. Training कराए थे वहाँ से. Organic.
yes, yes.
So, आपको consultant want to ask you something.
Good morning, sir. I just as a curiosity, this was coming to my mind that the GLOF which is taking place, and if it is initiating the boulder movement, it can cause much more disaster. So I think what is your opinion that the level of the GLOF and the initiation of the boulders at that level. For example, if the heavy boulder starts moving along with the flash flood, that may cause much more damage as compared to simply if there is simple flood.
Yeah. When it comes to the cryosphere region, the disaster is not going to come only one way. It is because the material is extremely loose in a high altitude cryosphere region. So when the flood comes, the nature of moraine dam lake outburst is such that this loose material of moraine has to come, will come along with the water. So the classical idea about flood, which is in peninsular India and or Indo-Gangetic plain, where it is not associated with debris and mud, is simply not acceptable and not going to happen into the high altitude mountainous region, because whatever the thoughts we have put here is either it is outburst of moraine dam lake, which is a glacier lake, or you have a situation where the temporarily lakes are formed because of the landslide, and the landslide leads to the temporary lake formation and it bursts. So the huge mud flow or huge debris is an integral part of the flash flood, which is going to take into the cryospheric region. So we have to account for that. So all floods into the cryosphere region will have all those things, and you are absolutely right that this is a complicating the matter, and it is causing a more damages than if only water would have come. I agree with you. Yeah, is it clear, or you want some more elaboration?
Compared to the water flow only.
Yeah, I missed. Is there anything? Was there any comment?
Yeah, I was just mentioning that the debris flows is also equally important in such cases when we are considering the impact on the society or people.
Yes, absolutely. No issue on that. Correct.
Thank you, sir. Thank you.
There is one more query from Professor B.K. Maheshwari, sir, from Arctic Engineering Department.
Okay, sure.
Dr. Kulkarni, good morning.
Good morning.
Excellent, and though I'm not expert because I'm working related to seismic hazards, so I have two very small queries. One is because you said glacier flags. So if these are numbers are increasing, global warming or what we say climate change. And the second is you talk about multiple hazards. So how you place the intensity for particularly related to earthquakes? So how you deal with the earthquakes when it comes to the glacier lakes?
Yeah, can I answer now, or still there is a query? Yeah. Am I audible now?
Yes, sir.
Yeah. The idea is see that as the first part of your question is whether number of lakes are increasing due to in a recent past. The answer is yes. That is possibly because of as the climate is changing into the Himalayas, and you know the elevated warming is taking place into the Himalaya. That means, as compared to the peninsular India, Himalayan region is warming at much more faster rate, and because of that, glaciers are retreating. And since the glaciers are retreating, the depression which is caused because of the glacial movement is now exposed, is a divide of ice, and slowly the number of glacier lakes will increase. That is documented, well documented now, and there's a lot of literature on that. So it is there that is significantly improving. Now, quick question is how earthquake, and another part of your question is how earthquake can lead towards the flash flood, or how to accommodate that into the flash flood. It's a still open question because of we do not have any experience in India, even though you can say that Sikkim earthquake years back has taken place and South Lonak Lake has not actually busted, even though the epicenter of earthquake was not far away from that. So it is not necessary that all lake will burst because of the earthquake, but that could be one of the reasons for instability. And how to incorporate that into the in developing the stability model of the moraine, I think still we need to work on that. I think that is still area open for further investigation.
Thank you very much.
Thank you. Thank you.
Dr. Kulkarni, this is Shankaracharya.
Yes.
If you remember, I was in NHPC and
Yeah, I remember you very well. Yeah.
it was said that people had learned from you in the last 10, 12 years. So just a small correction. People like me who have worked for 97, 98 under you and learned about GLOF.
Okay. Thanks a lot for reminding it. Because,
Yeah. So you were in Space Application Center Ahmedabad, and we were working for the Glacier Lake identification of Dholi Ganga project.
absolutely.
At that time, the technology was not so much. Even the area we have calculated with pixel, if you remember correctly.
Correctly. I remember that. Thanks for reminding it, because that was probably the first study which carried out, and we have probably NHPC has got help to clear their projects and other thing, and we have done the GLOF modeling.
So by this conversation, I just want to put everyone in the record of that from where we have started and from where we have reached. My story is this. So you remember at that time we considered that this glacier, there was no volume calculation at that time in India. So NHPC referred this case to ETH Zurich, and they gave some volume equations from Alps. I'm happy that now in India, under leadership of BIS and any other agencies like IIT Roorkee, ISRO and NRSA, that we have come to this level. At that level, what we did, we identified the area, depth was assumed, somehow this is the volume. We did simply a channel routing that what will be the effect on the probable Dholi Ganga project. But now the things have improved. So many hydrodynamic models we have developed, and now we can do. So my simple question is, no need to go to ETS Zurich now, sir?
My opinion is very clear on this. We can definitely do it ourselves. and we have enough talent and skills within the country to do it.
They have moved much forward.
And we should definitely do it here, because we have done a lot. We have published, some of our students have published in top journals and we have clear understanding of the issue. So I'm sure
Thank you, sir. Thank you very much.
we can do it here in the country.
So this will be the last
Last
question.
question is from Sopramita Chaudhary. Yeah, Sopramita, please.
It is not a question, I just wanted to add to something. Good morning. And good morning, everybody else. I'm
Good morning.
Sopramita from Wadi Institute of Himalayan Geography. And sir asked about earthquakes and glacial lake outburst floods. But I just wanted to add something in context with the Northeast Himalaya. So in Northeast Himalaya, what happens is there is more of, higher elevated region in the entire basins than the, lower elevation. And out there, most of the glaciers are located in the Tibetan part. We may call it China or Tibet or whatever. So what happens is it's in the northern slope. And then when the the river comes down, it comes via all lowest deposits. So they are all loose sediments. And we know that the Northeast Himalayas, Northeast region is seismotechnically very active. So we have a lot of earthquakes there. So even a 2 magnitude earthquake shakes that region and the entire lowest deposit just falls and slumps down into the river. And then sometimes we hear, because I'm from Northeast, हम लोग खूब सुनते थे कि चाइना बहुत डैम बना रहा है तो पूरा पानी बहुत दिनों तक for 7 days 2 weeks or so there is muddy water flowing. Siam river कभी muddy हो जाता है, कभी ये river muddy हो जाता है, and we feel that China खूब डैम बना रहा है. But also it can be true that there are earthquakes, small magnitude earthquakes, and it shakes the lowest and it just falls. Maybe it forms a temporary lake for some time. But then this part are very far from the Indian terrain. So ultimately what we get is the muddy water rather than a outburst flood, But earthquake or glaciers and glacial lakes का ये भी एक role है. Thank you.
So we can go to the next presentation.
Yeah, thank you so much, sir. Kulkarni sir, we will be waiting for your interaction during your panel discussion. So,
Thank you.
May I request you to kindly unshare your presentation?
It is not unshared yet. Is it still shared, my presentation?
Yes, it still shares. Yeah, now it's gone. Yeah.
Okay.
Thank you so much, sir. So our next presentation is from Dr. Ravindra Singh from NDMA. Dr. Ravindra Singh is a very young scientist and he needs no introduction. He is extremely busy with all the different types of disasters happening in Himalaya as well as in other part of India also. And he is extremely efficient. Right at the point of time, he covers everything within the time frame. And he has got vast experience. He has traveled all around the Himalaya as well as non-Himalayan places also related to different disasters, whether it is landslide, whether it is glacier-related outburst floods, or any other disasters, whichever is happening. So we invited him to deliver one lecture on glacial lake outburst flood and landslide lake outburst flood, because NDMA recently developed one standardization on glacial lake outburst floods. We wanted him to be physically here present, but since he is busy with the Assam disaster which took place, the landslides which took place in Assam, so he couldn't come here in person, but he agreed to deliver this lecture from WebEx or online platform. So thank you so much, Navinder. So now the platform is yours. You can start your presentation.
Thank you, Dr. Ajanta Goswami ji. And good morning to all dignitaries and Professor Anil Kulkarni and the officials of the BIS and the other colleagues and the participants. So I'm just presenting this national program which NDMA is formulating under the 15th Finance Commission recommendation under the National Disaster Mitigation Fund and the State Disaster Mitigation Fund for the reducing the risk of the landslide and the GLOF in Indian Himalayan regions and other Himalayan terrains. So basically, recently our different parts of India, currently now Assam is affected by the flood and the landslide in different parts of the Assam. Even in the May month, they have affected by the landslide in the Dima Hasao district and Karbi Anglong And right now there is a landslide due to the due to bad urban planning policies in the Guwahati region, and they are under the deluge. So in NDMA, sir, we are formulating this national program as per the 15th Finance Commission recommendation. I hope everyone is able to see my presentation. I hope, okay, thank you. So, sir, as you all, most of the people knows that these are the map of the landslide affected regions in the Indian Himalayas and the northeastern Himalayas and the Western Ghats. So 12.6% of the areas are prone to landslide due to rainfall induced landslide and the earthquake induced landslides, and majority of these regions fall under the earthquake. And but apart from landslide, there are different other mountain hazards like snow avalanches, GLOF, flood, and flash flood and cloud burst, and the earthquakes are triggering these kind of events in our Indian Himalayan terrain. And these are the altitudinal or elevation map of the Indian Himalayan region. And basically, I'm just focusing what kind of hazards are existing in our Indian Himalayan regions. So we have categorized in under our national program landslides, these hazard into the landslide, and then snow avalanches, earthquake, forest fire, and GLOF as per the physiogeographic region of the Indian Himalaya and the northeastern Himalayas and the Western Ghat. Then from the initiative of NDMA and the Swiss Agency for Development and Cooperation, with their international expertise, we have developed this GLOF guideline with the help of our task force of experts. Mostly experts are here. Dr. Sanjay Jain was the leading institution who have helped us in preparation and compilation of this guideline. And we have prepared this guideline within a timeline of 1.5 years, because this is a very important and burning issues of creation of the many glacial and periglacial lakes and the enlargement of the existing glacial lakes. So we have released this guideline in the month of September 2020. And from this guideline, we have taken the initiative to roll out some kind of pilot project and the comprehensive project in India. So NDMA guideline specifically tells us about the threat of the climate change and the formation of new glacial lakes. Then Himalayan, we have chapterized our guideline into this form: Himalayan geoenvironment, then chapter on the hazard risk assessment, then awareness programs and preparedness, capacity building, and research and development, then regulations and enforcement, in which most of the one of the key action point, because BIS is the nodal for the generation of the codes and guidelines in India, and there are specific points for the BIS is mentioned in our guideline at page number 65, that BIS needs to develop a course in different aspects of the GLOF and ALOF in collaboration with the concerned ministries like Ministry of Jal Shakti and other institutions, and in collaboration. And implementation of this guideline, we have devised the action points into the different form. And there are also SOPs. If there is any GLOF and LALOF event happened in Himalayas, so what kind of procedure and action points to be taken by different stakeholder at the state level and the district level and by the army and NDRF and all. So we have devised this chapter into the actionable points. So please go through this guideline. It is available on our website also. Then, sir, I'm coming to our main topic, national program. So we have we are formulating this national program as a thrust points and the necessary points which should be in every program, like prioritization and strengthening of early warning system, preparedness, prevention, mitigation by leveraging science and technology, integrating space technology inputs into identification, monitoring, and mitigation mechanism, holistic landslide risk assessment, effective implementation of land use management, development of physical solution for landslide risk reduction and mitigation in phase-wise manner, bringing all stakeholders on board, and use of indigenous knowledge and the best practices with scientific knowledge to reduce the risk of landslide and GLOF. So these are one of the prime recommendation of the 15th Finance Commission, that we have to prepare our programs with the involving the local community and with the local interventions also, and some kind of scientific deliverables to be taken on board and to implement the scientific knowledge into the ground. So our objective of this program is to prevent the loss of life and property and economic losses, then strengthening of early warning system up to the last mile connectivity, strengthen scientific and technical capability in landslide risk reduction and other hazards at all level, empower the local community as a partner to reduce the and mitigate the risk. So our prime component, 5 major component in this program is landslide risk and vulnerability assessment, development and integration and dissemination of the landslide monitoring and early warning system, which is the DID, and mitigation of the landslide with the local intervention, community intervention through the village and Panchayati Raj institution, and awareness generation and capacity building, in which all the stakeholders from different part of the country will take part, and reducing the risk of the GLOF in Indian Himalayan region. So I'm just giving you the glimpse of a component. This is under formulation. These component are now under finalization with the, we are circulated this national program with different states and other stakeholder and institutions for comments. So after comments, we will incorporate their comments, and we are in planning to have a one national workshop in Delhi, so that other institutions and national and the technical institution will take part and suggest some good activities under this program. So under this program, we are creating the landslide inventory and database for cataloging of all events happening for landslide and activities, mass movement activities, develop a GIS-based slope information system, which will be coming into the public domain after its finalization, geo-investigation mapping for vulnerable existing infrastructure, then develop meso-scale maps for the high-risk areas. So we have to prioritize the sites and the districts. So after that, we will implement this landslide hazard risk and the vulnerability map into different states and the UTs through the collaboration with the different scientific institution also. So second component is development and integration of landslide monitoring and early warning system, use of latest science and technology and tools for early warning, and establishing radar technology and for the landslide monitoring and the landform deformation, and other satellite-based technology we will incorporate under this component. And we will also focus on the incorporation of artificial intelligence, Internet of Things, and machine learning for creation of the effective and reliable early warning alarms and the protocols. Then third component is mitigation of the landslide with local intervention at district, block, and village level. So these are totally based on the state level intervention, and the scientific community will take part in for capacity building of the villagers and the other institution at the state level for community-based slope stabilization by local intervention, biorestoration initiative for fragile landscape prone to landslide, strengthening the landslide risk aspects in the state building regulations and rules to improve the resilience of the built environment, identification and adoption of the site-specific structural mitigation measures. So there are so many landslide happening here and there, and road connectivity and some towns are also affecting and villages are affecting. So we have to prioritize our sites, and then this fourth subcomponent of this component third, the funding will be provided to the state for mitigation of the particular problematic landslide site. And apart from this, some bioengineering measures and the biorestoration measures will also be focused for construction and the drainage management correction will also be gone under this program. So fourth component is awareness generation and capacity building. Under this program, we are strengthening the training institution at the state level and district level, then strengthening of the Panchayati Raj institution and its members, then strengthening of community through sensitization program and other initiatives, then creation of knowledge management center, creation of one particular mountain hazard cell in the NDMA level. So this cell will be the knowledge partner and the networking center for between the different institutions in the country and outside country also. So creation of community and the village task force will also be the prime objective of this program, and the creation of skill development with the indigenous knowledge and method is also the part of this awareness generation and capacity building program. So apart from landslide, one of the main focus area of this program is reducing the risk of the GLOF in Indian Himalayan region. So because our IHR region are very affected by the GLOF from the Jammu and Kashmir, Ladakh, Himachal Pradesh, Uttarakhand, Sikkim, and the Arunachal Pradesh. Most of the glacial lakes are there here and there. So we have to prepare the database of these glacial lakes because many institutions are working in this field. NRSC is producing their atlases on this Ganga basin, Brahmaputra basin, and Indus basin. So we have to take on board all the stakeholder, even the other stakeholder working in the IISc Bangalore Research Center under the aegis and the guidance of Dr. Anil Kulkarni sir, and other institutions, IITs and other. And NIH will be the leading agency for one of the prime pilot project for reducing the GLOF risk in the Lonak and Shakuchu Lake. So here we are focusing the monitoring of the highly vulnerable glacial lakes, which is the one component of this. So first we have to prepare the database, then monitoring of the highly vulnerable glacial lake through the satellite images and other, then reducing the GLOF risk through the local intervention. If any intervention for mitigation also required, that will also come into this subcomponent. Then preparation of the contingency and emergency action plan to reduce the GLOF risk. And second main component in which SDC is providing their expertise through different Swiss experts for development of the early warning system, multi-hazard risk mapping, modeling, indigenous knowledge. So basically this pilot project will for the Lonak and Shakuchu Lake. As Anil Kulkarni sir rightly said that Lonak is very highly vulnerable, and from the Shakuchu Lake there are very high mountain cliff where the threat of avalanche and snow avalanche and rockfall is we are expecting like similarly like Chamoli event. So we have, that's why we are selecting this Shakuchu Lake in the North Sikkim. So we are going to send soon 2 expedition team in these 2 lakes after approving our national program by the Ministry of Home Affairs and other concerned financial institution. Then development and installation of monitoring and early warning system is the one of the prime important from the creation of early warning system, not from the lake side, but up to the community and the village side, river valleys, and up to the Tista Dam Hydro Corporation and other agencies we are taking on board under this program, so that we can generate a one last mile connectivity early warning system from the lake up to the village and up to the dam site, so that necessary actions during the crisis situation can be taken by the different agencies at the state, national, and the hydro dam corporation agencies. Then awareness generation, capacity building, and consortium of expert and institution also one of the part. Then mitigation measures for if any mitigation structural measures are required as per the site condition requirement, we will go for it for the Lonak and Shakuchu Lake. And best practices out of this pilot project will be rolled out in the different phase of this national program after the 5 years. And simultaneously during this implementation of this program will also some action will be taken on board. So again, I'm coming to the reducing off because these are the slides. I'm presenting most of the slides created by our eminent expert from Dr. Sanjay Jain and Irfan Rashid. So I'm sharing it. And these are the slides which we have covered under our national guideline on management of the GLOF. So identification of vulnerable lakes and classification of glacial lakes vulnerability On the basis of their vulnerability, high, moderate, and low will be classified, and near real-time monitoring solution to be creation of this for this GLOF and the glacial lakes. Then GLOF modeling and simulation will be the part of program, and awareness generation for the local community, awareness generation for which I already covered through exhibition, painting, and other competition. And GLOF early warning mock drill will also be conducted under this pilot project in Sikkim. Then preparedness, which focusing primarily on disaster preparedness for a structural component, non-structural component, will be the key mechanism for strengthening of GLOF risk reduction and mitigation in the state level and the other stakeholder and the scientific institution in the country. So we are rightly said, we have rightly discussed during the discussion by our participant with Dr. Anil Kulkarni that expertise in our country is not limiting. So therefore, we are taking on board all the stakeholder so that we will take necessary action for other lakes in the country after cataloging of all the and prioritization of the highly vulnerable glacial lakes. Then capacity building is one of the main important part of this pilot project. Then development and installation of instrument and early warning system. Then mitigation measures. These are the glimpse of the mitigation measure done in the Lonak earlier by the Sikkim government for siphoning of this lake. But as we heard through the Sikkim, this intervention is not so far working. So that's why we are again going for this expedition. And then after this expedition, we will plan our mitigation measures for this Lonak and Shakuchu lake. So regulation and enforcement, I already mentioned that this is covered under our guideline, which will also be the part of this pilot project. Then emergency action plan for the GLOF if any highly vulnerable glacial lakes are identified. So we have to create this kind of action plan in collaboration with the state disaster management authorities. So these are the glimpse of the Irfan Rashid, Dr. Irfan Rashid from the Kashmir University. He have shared these images of Drang Drung Glacier in which the lake size is also expanding from the many years. So these are the highly vulnerable glacial lakes in the Kashmir. And he have also published one of the important paper on this Gaya Glacier outburst of GLOF. So here are the images of the damages done by this outburst of the Gaya GLOF incident. And very recently in the last year, when we are preparing for our formation day in NDMA, that time we are heard that this incident happened in the Ladakh region, Leh region, in month of August, on the date of 18 August. So you can see, sorry, on the 24th August. So this is the Rumbak Glacial Lakes in the Leh district, which was outburst during that month. And this is our pilot project on Shakucho Lake and the Lonak. So these are the two glacial lakes in the highly high altitude and site in the northern Sikkim. And these are the confluences of the Lonak and Shakucho Lake from where different villages are there, Thangu village and Yathang and Talam and up to the Lachain, up to the Chungthang. There are so many villages. So we have to prepare their emergency action plan and the early warning system under this project. So project partner under this program is NDMA, SDMAs and DDMA and IDM. NIH will be the prime important partner for implementation of this project through in collaboration with different stakeholders. So we will have one important partner like ISRO NRSC on board for implementation of this project and sharing of their expertise. CWC also supporting this project. We already discussed this project in different forum, and DTRL, SASE, DRDO will also supporting this project. And international, from the international side, Swiss will take and their expertise. They will take their experts from different Swiss and other parts. So we have to implement this project. And now again, I am coming to our national program component. So the states which we have prioritized under the phase 1 are here. You can see the list of the 16 states and UTs. So we are selecting the Jammu and Kashmir and Ladakh under this project, because basically our national disaster mitigation fund, which are approved by the Ministry of Home Affairs and Ministry of Finance, is primarily focusing on the state disaster and the hazards. No, there are no funding mechanism for the UTs, but apart from this, we are taking Ladakh and Jammu and Kashmir here for providing the 100% of the central funding from NDMA. So in this program, we have to create this mountain hazard cell. So this mountain hazard cell will comprises of different experts, and the functioning of the mountain hazard cell are, you can see, consultations and the project proponent with the project proponent and other states and the other stakeholder, project appraisal, approval, and other their technical scientific queries should be sought out under this program. And the main maintaining of the database of the project, supporting states, and facilitation and implementation of various mitigation strategies, ensure sustainability of the various strategies and the program, then preparation of the technical reports on various mountain hazards. Then this national level implementation, we have to take all this initiative from the NDMA. We have to create this and establish this mountain hazard cell as per the request and the suggestion by the Ministry of Home Affairs and the project management unit. Then role of the PMUs also chalk out like overall implementation of the PMU in the NDMA, monitoring and coordination at the national level. The PMU will be equipped with different professionals and the pool of the experts from different institutions, and this will be headed by the project director and the deputy project director and specialist and other program coordinator for technical guidance and other members. Then state level implementation, there will be the STMA is implementing this program in collaboration with the NDMA. So there will be the one project appraisal committee. So SDMA will supervise and monitor all the approved project under the NDMF and SDMF funding. Then there will be one technical appraisal committee for giving overall technical guidance to the projects and other component of the this program. Then state PMU will be responsible for overall implementation and monitoring, and the state project coordinator will be appointed as a state nodal officer under this program. And then after at the district level, there is a one project implementation unit. So the grassroots action team will also be prepared, like the village task force, and the local community will take action through the initiatives of the Panchayati Raj institution. And NGOs will be taken on board for implementation of this kind of activity at the village level and the district level. So state and the UT, here you can see the total budget outlay, which is around 1,000 crore. So this will be decided soon in discussion with the MHA and other stakeholder during the workshops and other forum. Then there should be one appraisal and approval and implementation and monitoring through this TAC, PAC at the NDMA and SDMA. Then state executive committee, which we have already discussed, there should be this kind of mechanism we will follow for the appraisal, approval, and implementation and monitoring of this national program in India at the national level. So we thanks for all for patience listening. So now we can, if any queries, you can discuss with me, or if you can write to me through the email. Thank you. Hello. 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 Professor Dr. Ajanta. Hello. Hello. Yeah, Dr. Ajanta, I hope my presentation, or people have seen or I have lost the connection during discussion.
No, we have a virtual presentation. Could you hear me?
Yeah.
So, Dr. Rajendra, thank you so much for this wonderful presentation. And I believe that your presentation and your content would go to our panel discussion. And there are not many questions, I think, that our panelists as well as our audience want to ask you. But I reserve all of you to kindly discuss this question during panel discussion. Because just now, Bhanuprakash informed me that there is close to 150 participants in WebEx platform, around 110 participants in YouTube, some close to 50 participants who are there in offline mode or in the URM conference room as well as the seminar hall. So it's a huge participation, and if we go for all the questions, so it will take lots of time. So we want request all of you to kindly reserve your question during the panel discussion. So our next speaker is Dr. Sanjay Jain. And he is a scientist at the IIT Roorkee, and I think Dr. Sanjay Jain needs no introduction. Already Dr. Ravinder has told a lot about him and his work also. And I'm very proud to say that I am his PhD scholar. I did my PhD under him, and I'm still learning from him. I'm still associated with him. He has worked tremendously in the field of cryospheric science as well as glaciers and glacial lake outburst flood. So, sir, I request you to kindly give your presentation. He is here in offline mode. So, yes, sir, please.
Thank you very much. Some stuff is okay. Okay, thank you, Dr. Janta, and good morning to all present here in this hall. Good morning to all who are offline, online in this particular program. So I'm going to present Glacier Lake outburst flood studies which we have carried out at IIT Roorkee. My colleague Dr. A.K. Bhajan is here. So we both are working in this particular field, and most of the hydrodynamics modeling and all that is carried out by Dr. Mohan. So this presentation, the studies which we have carried out, I'll briefly present. Dr. Vidar has already spoken on the guidelines which have been declared by its So if we are talking about glacial lake outburst floods or glacial lakes, so already Dr. Kulkarni said in his presentation that there was a flood in 2013, and everybody knows that that was the first event or disaster which we have seen in the field of glacial lake outburst flood. Just after that, we published a paper, or we can say article in Science Reporter in August 2013. We visited that site also. You can see some of the photographs of that place, Chorabari Lake, which breached on that day in, just 9 years ago. So you can see that reaching point and the lake which has now there is no water. So this was the event, we can say that, which started thinking of this glacial lake outburst flood. But before that, we received two proposals from NHPC and TSDC in the year 2010. because they were having some of their hydropower projects. And for those projects, they wanted to know how much will be the glacial lake outburst flood if in case reaching of lake happens in that particular catchment of those particular hydropower projects. So then we started thinking on the GLOF modeling. We discussed, Dr. Lohani, myself, and then Director Mr. R.D. Singh. So we were not knowing anything about this particular glacial lakes and GLOF, etc. So he said that we are doing dam break model. And that is not natural lake, but this is also a artificial lake. The difference there was only that we were knowing the dimensions of that particular dam and all that. In case of lake, we were not knowing, like depth and volume, etc. And still there is limitation in knowing these volume and etc. So then we scanned some of the literature and we found a paper by Hagen. So we found some of the formulae and relationships which we had used. And we also found one or two reports on GLOF. So then in 2010, we started working on GLOF. So number of studies we have carried out that time project. And GLOF are very important for power projects. Like a number of hydroelectric projects are coming up in Himalayan region. Some of projects have glacial lakes in the catchment area. These lakes are increasing in size due to accumulation of glacial melt behind moraine dams. There is a strong possibility of breaching of moraine dams, resulting in GLOF. So for the safety of hydropower projects, we have to consider these GLOFs. So we have carried out a number of studies. Briefly, I project after this. Recently, we have carried out one project which is funded by DST under National Mission for Sustainable Himalayan Ecosystem, in which we have carried out 11 sub-projects. So one sub-project was glacial lakes and glacial lake outburst flood in Western Himalayan region. So we have considered Ganga Basin, Satluj Basin, Chenab Basin, and Vyas Basin under that project. So these basins you can see here. And in these basins, first we have to have the glaciers. So that glacier mapping we have done, because whenever we are talking about glacial lake outburst flood, we have to have glaciers as well as glacial lake inventory with us in that particular catchment. And then we have to identify the lakes which may be vulnerable on the basis of number of candidates. So we first mapped the glaciers in that particular those catchments, and you can see how these glaciers are changing over the years in these 4 basins. So the glaciers are rotating, we can see from the table which I have shown in the Then we have prepared the glacial lake inventory map of all these 4 basins. We have seen number of glacial lakes which are there in 1990, 2000, 2008, 2014, and then in 2019 also we have taken the area of the lakes which are vulnerable. So this is the inventory of the lakes and number of lakes in different basins in different years. I have just shown the table. Then we categorize all those lakes in these basins because we have to then define the lakes, whether it is a moraine dam lake, it is a glacier erosion lake, it is a ice dam lakes. So all the lakes in these 4 basins, then we have classified into different classes because we know that some of the lakes they are not vulnerable. So we have identified moraine dam lakes especially because one of maybe some of the moraine dam lakes may be the vulnerable lakes. So here we can see in Satluj Basin, we have found that 3 lakes are vulnerable. In Vyas, we have found that 2 lakes are vulnerable. In Chenab, we have found that 2 lakes are vulnerable. So in this project, we have identified the vulnerable lakes in these particular basins. And then we have carried out for each vulnerable lake, the glacial lake outburst flood model. So this is our next step. Once we have identified the vulnerable lake, then we have to go for hydrodynamic model. So there are a number of models which are available to carry out hydrodynamic model. Earlier we have used microdynamic and then HECRAS also we are using for a number of studies. So now HECRAS we have applied in these lakes. So one example I am just showing you here, that is for Satluj. So here if we see from 1990 to 2018, the glacial lake has almost doubled. So this is our first step or first criteria, just to see what are those lakes which are increasing in size, beside other criteria. The condition of mother glacier, the location of that lake. So all that criteria we have to see and then we have to adapt. So this is our first criteria, just to see how that lake is expanded. Then the other inputs which we have to have for GLOF modeling, they consist of the cross section. This is again limitation in this type of model, because in those areas it is very difficult to get the exact cross sections. So what we did, we have taken the help of existing DLs, and from those DL we have drawn the cross section. So we can see here the cross section at regular interval have been drawn in that particular basin. This is for the Satluj basin. And up to Rampur, we have then simulated the flood. So volume and depth, etc. You can see the Huggian formula which we have used. In the presentation by Dr. Kulkarni, he said that volume we can compute using one of the method. So if we can have that volume other than this formula, then it is very, because this is one of the limitations which we have seen. Other limitation, of course, of cross section is there, which we can get from DL, and if we get the good quality DL, then that can be over. So all that we have computed the volume and all that of that particular lake, and the modeling has been carried. So just downstream of the lake, how much is the peak flood? That has been computed, and the depth, and the velocity, and the time. So it is 20 seconds, 20 minutes, sorry. And then to the breeze, the settlement 1, settlement 2, the Rajput down. So we have computed at different distance how much will be the flood, what will be the maximum depth, velocity, and how much time it will take to reach that. That is again very important, so that we can take some of the actions in between that time to reach that flood up to that point. So at number of locations we have given in that report how much flood will be generated if in case that lake reaches. So this on Google Earth we have then overlaid this different locations just to show how much area will be inundated. Recently we received a request from SGVNL, Satluj Jal Vidyut Nigam Limited, that they are coming up with 6 projects in Chenab Basin. Upper Chenab Basin, the location just I have shown here. So they also wanted to know in case of there is any GLOF event, how much will be the flood at different power project sites. Beside design flood, they have to consider that. Okay, so we have then identified 2 lakes. Already we have identified in NMC project also. They are vulnerable, that is Kepang and Samudra Tapu. These are the 2 lakes which are vulnerable in Chenab Basin. So we have taken the biggest lake out of that. So this is the glacier map which has been prepared and the location of these 2 lakes. So you can see here that Chenab, this Kepang lake on the top and Samudra Tapu on the bottom side, and in different years how it is changing. On the right side, this picture I have taken from the atlas which has been produced by NRC on Indus Basin. So this is the Samudra Tapu lake, which is the bigger one out of these 2 that we have considered for glacial lake outburst flood model. So first, as I have said, that we have to generate the cross sections that has been generated for till the last project. These are the location of 6 projects, and then we have carried out the model. So one aspect which we have to consider when we are talking about the glacial lake outburst flood modeling is to image the 100-year return flood at different sites. We can run or simulate this model without this also, but like most of the companies, they said that we have to consider the 100-year return flood also, where we are running this model. So at different points, we have computed how much will be the adopted lateral inflow. They have given us the 100-year return flood at project site, and then how much we have to impinge at different sites according to area ratio that we have computed at we have taken the lateral inflow, which will be there because of that 100 millimeter flood. After that, at the project, at the lake side, what is the flood peak or flood hydrograph that has been shown in red, and what will be the value of flood peak at project site? Better I will show you in the table. So these are the 6 projects at different distance from that lake. The last one is such as HEP distance clock peak along with 100-year return flood. 100-year return flood at that particular point or project site, and then clock peak subtracting 100-year return flood. So that 1925 cumulative will be the flood at the first project site that has to be considered along with the design flood for that particular. And the water surface elevation and the time it will take to reach to that particular project site. So this study recently we have completed and shared with SGB. Then, because we started working about 10 years back, Dr. Mohani and myself, then number of students also approached us, whether MTech or PhD. So one PhD student from Department of Earth Science, Dr. Gyarmeet, he is in GSI GLK. So he did one study in Jalskar Basin in Kashmir, Himalaya, for 2 of the lakes which are vulnerable in that particular area. So just I will quickly go through these slides, which means we have carried out. So again, I will say that we have prepared the glacial lake inventory on the basis of the processing of the satellite data, then slope of that area, NDWI we have computed, and on the basis of that, then we have demarcated all the lakes in that particular area, and then we have seen these 2 lakes which are one, that is Dalung and Padam. So this is glacier recession and lake expansion in that Jalskar Basin. You can see here. So the green bar shows us the glacier. So we can see that they are retreating, and how that lake is increasing with that recession. So these 2 lakes, Dalung 0.32 square kilometer and Padam 0.41 square kilometer, that we have considered in this Jalskar Basin. Then the expansion, how this is happening using satellite data, better we can see here in different years from 1975 to 2015, how that lake have increased. These 2 lakes have increased. So in different years, we have demarcated the outline of 2 lakes, and we have found that these lakes have increased over the years. So Dalung and Padam lakes has increased by 0.37 square kilometer and 0.4 square kilometers between the years 1975 to 2015. Then the criteria which has been applied, just briefly I am showing you here. One, of course, is the increase in the size distance between lake and the mother glacier, every slope of glacier, slope of the downstream, top width of the dam, area of glacier, etc. So we can see that the weight have been given to all these index, and then we said that these 2 lakes are vulnerable lakes, and elevation of these lakes are around 5,000 meters. We have the pointer. Then, of course, again formula we have used in these computation of this, that is the depth, 10 meter we have considered, and the volume we have computed for these 2, 11.64 and 50.77 million meter cube. Then breach width, breach depth, etc. we have to compute, because how much will be the failure of that. So that flourish formula we have used, and we have computed what will be the breach width and breach depth. So all that we have considered when we have taken that into that across model. So breach depth has been taken as 10 meter, and development time is 30 minutes. Roughness coefficient we have to consider. For millimeter we are taking 0.04. So all those parameters we have taken, and on the basis of that, and then the cross sections you see on the right side, and on the left side you can see from lake to the side where we have computed the log value. So this is the cross sections, and then finally how much will be the log at that particular site. So at the lake side, at 35 kilometer downstream from the lake. So we can see here that at the lake side, it is 3,361 cubic, which attenuated to 1520 cubic in case of Talun Lake. And in case of Padam Lake, we are getting a flood peak of 1722 cubic. And time taken is 1 hour and about 40 minutes to reach that flood up to that point. Beside that, earlier to that, as I have said that TSDC and NHPC approached us for the studies. So we started working on this with Vishnu Payar in Uttarakhand and Twang in Arunachal, which has been given by NHPC. So number of projects we have carried out since that. This is the list of them. And just outcome of the modeling I will show you in some of the next slides. So Gangveli, Vishnu Payar, THDC has given, NHPC, Twang, Chamkarchu, and Kurigauri. SGVNL recently we have carried out for Chinab. GSW Hydro Energy that is working in Baspa Basin of Satluj. There we have done for their Sangla project. Recently again, UJVNL approached us for Maneri project. So there we have done. And one study we have carried out in Sikkim also. That is actually there were 3 projects they have taken up. So far that project, of course, they have not started yet, but it is a private company, Polyplex. So they have given us that of Tista Basin, that is in Lachu. So we have carried out these studies for them also. So NHPC, as I said, that they have given us a project in Bhutan also, because they were having some of the projects in Puri Gongri and Lachu. They are Chamkarchu. They are in Bhutan. So we have seen that one of the lake which is vulnerable there, most vulnerable, which we have found over our studies, is the Chukla Glacier. A number of studies has been carried out in this particular lake. So we can see here that there are a number of lakes in this particular basin. But one of the lakes you can visualize here, that is the biggest lake located in this particular basin. So what we did, we have taken the satellite data from Landsat, Aster, and other satellites, and then we have seen from 1990 to 2010 how this glacial lake is behaving over the years. So if you see here that this lake we have demarcated, and we have found that this lake has increased about 3 times over these years. So this is one of the lake in that particular basin, which is vulnerable, and then we have carried out a study for this particular lake. So I'm not going to present in detail the studies which we have carried out for NHPC and JSDC. These are some of the slides I'm just showing you here. So this is in Chamkarchu Basin, Chukda Glacier Lake, which is a very big lake. Volume you can see here, 54.18 million meter cube. Depth has been considered as 40 meter, and then cross sections, etc. And you can see also here the flood peak which we get at the project site is 5,000 cubic, about 500 cubic. So this is for Chamkarchu. Similarly, there are 2 lakes, that is, there are 2 projects in fact, that is Puri and Gongri, and 2 lakes we have found in the catchment. You can see on the satellite data. So at the elevation of about 4,690 meter. So again, the same approach we have applied, that is cross sections we have taken from the DM, and then we have computed the flood peak at the projection. So this is for the Puri Gongri Hydro Power Project. This is again Gongri Basin. Earlier it was Puri Basin. So all these 3 studies we have carried out for NHPC for their Bhutan. Then Lachu, they actually proposed 3 projects at 3 sites. So we have considered the lake which is vulnerable in that Sikkim Himalaya. Just now Dr. Mitra was saying that South Lunar. So it is not in that particular basin, but South Lunar is one of the lake which is vulnerable. And they are preparing a comprehensive project in which we are also involved. So the purpose of taking of that project is how we can mitigate, how we can handle that if we can avoid some kind of breaching of it. So that was it. So these Lachung hydro project we have carried out for Polyplex, a private company, which they were planning to have 3 projects in this particular basin. So we have computed the peak at those 3 sites. This is the Tuang hydroelectric project again of NHPC, through which we started in 2010 the GLOF status. Now, some of the things already Dr. Vinder has said that we have to have early warning system. So this warning system has been prepared, and you can see here, Dr. Lohani was involved in this particular preparation of EWS. So flood monitoring and command area, EWS, AWLR, that monitoring every 15 minutes. Then if it is yellow, we can say that it is alert. And if it is red, then we can say it is alarm. So if water level increases in a particular lake, color of water level data will turn here. And control room dissemination of information to all the stakeholders. If water level further increases, color of water level data will turn red. And alarms will be switched off, evacuation of people. So that steps we have to take to handle in case there is a breaching. All that have been included in the guidelines, which has been projected already by Dr. Vinder in 10 chapters. So this is one of the important aspects to handle GLOF. This already has been shown by Dr. Vinder, and as he said that Swiss agency, they are working in this Sikkim Himalaya and control reaching of Moraine Dam. This is one of the way of mitigation. If we can reduce the water which has already been accumulated in that particular lake through some means, then that is one of the mitigation measures. We can avoid the breaching of that lake. So, but it is a difficult task. We have to reach to that site, and then we have to have the construction of an outlet, pumping or siphoning of the water from the lake, tunneling through the moraine or under an ice dam. So that has been done already for that lake in South the Sikkim with the help of Swiss agency. So this again has been proposed in that comprehensive project. This is some part of that has been carried out. But in detail, how we can have the early warning system and how we can have these type of measures in those lakes, so that we can avoid reaching of those alerts. So the regulation and reinforcement is another type of chapter in that particular guideline, in which we have to regulate and reinforcement the laws, the bylaws or the rules which has been given in that. Another is the emergency action plan for Glacier that also we have given, and already in brief, I will say is projected. So first task is of course glacier lake identification and glacier lake outburst flood modeling, DEM river cross sections, reservoir and dam data, the flood of the dam, etc. Then GLOF modeling. So all that upper part that we have to do, and then emergency action plan, EAP. In case of dam break, dam break studies also, which our institute is carrying out, we are giving so possible emergency conditions and the responsibilities. So notification flow charts, watch condition notification flow chart, then failure condition notification flow chart, termination and follow-up responsibility, and listing of different suppliers and agencies for supply of necessary material at the time. Emergency. So all that emergency action plan we have to go. That has been covered in detail in those guidelines. Post disaster, how we can take some of the relief measures. What are the responsibilities of the local administration, ITBP, whatever authorities are there. Because people are not still aware about this type of disaster. So we have to have awareness program also. though after 2013 event, people came to know about this, that this type of event may also happen. So all that has been covered in that guideline, and we have to see that awareness and preparedness to handle this type of disaster should be good. If anything, Dr. Lohan want to add in this, he was involved in this preparation of this early warning system and emergency action plan.
During the discussion, we can.
Yeah, so if any discussion is there, then we can discuss more on these points, because number of template studies also we have carried out and emergency action plan happened. Then these are some of the publications which
बोला नहीं है नहीं पैनल डिस्कशन बोलेंगे पैनल डिस्कशन किस लिए है
So these are some of the publications which we have made in number of journals, natural hazard, and then this hydrology journal. Then in chapter also we have written. So these are some of the publications so far we have made. One publication we have made in Journal of Hydrology, that was in Janskar Basin. So these are some of the publications. Beside that, as I have said, we are involved in the guidance of MTech and PhD thesis. Dr. Lohani, I think you are guiding two PhD right now, and one is under my guidance. That work we are carrying out for Jhelum Basin, Kashmir University. So for Jhelum Basin also, now the same exercise we are doing, and the flood modeling is one of the component of that particular thesis. So this is the concluding remark. Due to extreme hazard potential of GLOF events, it is necessary to take into account GLOF while planning, designing, and constructing any infrastructure, especially water resources projects, as they are located on the path of glacial lake outburst flood field. The second is proper combination of floods due to precipitation and GLOF is required to be considered for the design flood estimation of various upcoming projects in the region. And particularly they are important if there is any lake in that particular catchment in which they are that project is coming up. So we have to be means that GLOF flood due to breaching of lake we have to consider. Thank you. So this is
Thank you so much, sir.
one or two questions. If you say we can take up now, and the rest we can discuss.
Yes, I think there is one question that someone was.
Sir, thank you very much for a very good presentation. And I could see that a lot of progress has been done, what we did in 97, 98 for the Dolly Ganga project. But one basic question again remains, and please take it very supportingly, because I am out for 10, 15 years in this, not working. Sir, you have used Huggles formula for volume. Okay. When we did the Dolly Ganga study, we took 3 or 4 equations, and this was one of them. So this was my question in the morning also, that lot of things had been done by NIH, Wadia, and other things. But why we are taking the equation which are applicable in Alps? Why can't we develop these equations for Himalayas? This is a very humble support.
Yeah, right, you are right, and actually I also say that this is one of the limitation. And number of equations are there. Recently, we have seen like it is one of the equation that Huggle formula, but there are other very popular equations as well. So they have developed for their Alps Himalaya, Alps region. If we have to develop similar kind of equation, then we have to do the exercise for different lakes in the Himalayan region. We have to have the volume and depth of those lakes, and then on the basis of that, because these relationships they have developed on the basis of the observation. In the morning, Dr. Kulkarni also said that volume we can estimate using some of the method which he has explained. But accuracy of the volume which we are getting through those methods is again a question mark. Going to that lake and measuring the volume is again a very difficult task. We tried once. We could reach up to the Mana, and above that we were going Rangwali is here. He was also a member of that team. But RB, they have not allowed us to go up to that lakeside.
It is very dangerous also.
It's very dangerous, one thing, very difficult. And because of these regions, it is again not possible to reach up to that side. So actual measurement only we can take if we reach up to that side. So there are certain
My humble request to IIT, Roorkee, NIH and all that please develop a volume equation for Himalayas. Don't carry over these Alps. This is.
We are just planning, we are already in the process of that. We
Yeah.
already thought to develop some.
For sure.
So we are trying to use some alternative methods.
Yes.
And I was also in discussion with Dr. Thakur that they have carried out some mathematic survey for.
I have seen
your
your presentation. I will request him to guide me.
And I have also some idea about.
Yeah, please develop.
So
Sir.
we
Please
are
develop.
planning for that. Yes, definitely will. Very near in New Year.
You must be collaborating with EC Mode. They have done a lot of work.
we have once actually approached for the same thing. And initially when he started working on GLOF, we also have taken their publication and we once visited also Nepal and we have taken their support in that. So that is very right that we have to go for certain kind of formulae which will give us the
Himalaya, yes.
etc. in Indian Himalaya. So that is required.
EC Mode is a good partner.
Can I add?
Can I intervene into this discussion if permitted?
Sure, sir.
Yeah, see, if you what Dr. Jain and you have pointed out is one of the difficulty is getting the depth observations after going there. So if you look into the South Lanark Lake, where the team of state DST and central DST has gone there and collected the observation of depth by using modern techniques. And that is later on used to develop the models where I was talking about of that. So there are definitely efforts in India to measure the depth. However, if you want to have a statistical um, uh, formula about which Sanjay was talking about, we required a large number of observations where we need to go to the field and do it. But that itself is a now outdated way of looking or estimating depth, like the way we using the scaling method to estimate volume of glaciers is itself is outdated method. Similarly, finding the volume of lake by scaling itself is outdated method. There are definitely better modeling tools are now available because the glacier lake monitoring has one advantage that we have historical satellite data when the lake was covered by ice, and therefore we have some other tools to do it. So I think all those modern development in field needs to be bring into the management practices of operational agencies like NDMA or any other thing. I think we should look more detail of that during our discussion. Thank you. Thank you very much.
Yeah, you are right that we have to go further in this direction so that we can have this type of relationship or formula for Himalayan region.
No, I am not. I am deadly against this formula because I don't agree with the scaling method at all, estimation of volume. Because I think that is still, it was 1980s and 90s science. It is not today's science. So we have to look beyond the scaling method.
We can, if we have advanced technology to estimate the volume, then definitely it is a better approach.
As a science, I'm saying, as operational, what you do is a different story. As a science, I always feel that we have to move on with the scaling method because what essentially formula you were talking about, nothing but the scaling method. So we have discarded that in glacier volume. Probably time has come to look into beyond that in lake volume also.
I think
This one point, when we are talking about the flood management aspect, nowadays we are using lot of drone technology. So, but if we can include that, I think that can really do the wonders, particularly in the management aspect.
You are right, but again, there will be limitation of drone in that particular zone.
Going and flying drone.
Yeah, I noticed that one, and I have seen the drones, even in the Himalayas, up in the very high ranges. And there also drones can go 2 kilometers, 3 kilometers.
No, that's right, but
But
because of the defense.
line of sight, that is an issue, but wherever we can think of that one, that is a really nice one. And particularly even for the DEM also. That
Yeah,
you can
that's right.
have a more defined DEM of that area if the line of sight is clear.
Really getting the permission, they are going in those difficult areas. These are some of the issues.
That is administrative part of that. If we are talking about the basic tower, then those things can be managed. But as far as technology, is concerned, because nowadays lot of people are using the drone in the flood management, particularly in plains. They are doing low.
Hello. So myself, Dr. Vijay Kumar from
True.
Actually, as sir is talking about the drone, so and sir is saying that there are some limitations. We also see that yes, we also go on Glacier, but there are certain limitations. Even in this Saturday, I'm going back to Asburana after 20 days. What as we did, we were at the point, there was a glacier, they said just move down.
But this type of problems are
We
there.
had some instruments and they said you are not allowed to use. So those are the particular limitations with the instrumentation.
They have also faced the similar.
Glacier also not even allowed to use.
In most of the areas under army.
That is
Over there, yeah.
We have taken permission from the local administration, even then they have not allowed.
You see, when we are talking about the BIS and this standard formation, actually in that the technology is there, we should mention that technology, right? I mean, these are the other things that administratively, whether we are allowed or not allowed, whether it is a confidential area or something like that. But as far as the technology is concerned, technology is there and we should be, being the technocrat, we should mention that this is available and we should use that.
That should be there, but that limitation or restriction.
Okay, I think Sanjay.
Thank you so much. Thank you, Sanjay sir, for this wonderful presentation. And we are lots of great. Sir, please. So, our BIS team, they want to honor you. If something is there for you.
First presentation physically.
Thank you so much, sir. And yeah, it was a wonderful presentation. And whatever came out during the discussion, like regarding the drone technology as well as regarding volume area scaling or any other topic, we all will discuss this issue. This will be the issue to be discussed during the panel discussion. So thank you so much. We are not taking any further question. So our next speaker is Dr. Tapas and then Martha from NRSC. He's scientist at NRSC and he has done extensive work on landslides as well as glacial lake outburst flood, landslide lake outburst flood. He was a part of the team of NDMA that was constituted to study the rainy village and that particular disaster which took place on 7th February 2020. So Tapas sir, yeah, the platform is yours, so you can start your presentation. Thank you, sir.
Thank you, Professor Ajanta. I hope I am audible and visible. Can you confirm, please?
Yes, sir, you are both audible as well as visible also.
Yeah. Thank you. Thanks IIT Roorkee-BIS for giving this opportunity to present the work done at NRSC. And distinguished panelists, I could see many experts and the attendees also. Very good afternoon to all of you. And today I'm going to take you about the work done at NRSC Hyderabad on landslide and glacial lake particularly in my presentation. Yeah, so as you can see, let me briefly tell you about the landslide scenario in India, that's important to know to work further on the landslide related lakes. Majority of our country, particularly the 18 states in North India and Southern Peninsula, covering around 12.6% India's landmass, is prone to landslide. Unfortunately, we are number one in the world in terms of fatal landslides. More than 10,000 people, it was a database compiled by us a couple of years back. They lost their lives due to landslide disaster. And Government of India, as you know, has designated NRSC as the nodal agency to rapidly respond to landslide disaster in our country. Similarly, Geological Survey of India is a nodal agency in our country for overall landslide management and mapping. So there are, I could list down three major national initiatives in the landslide front. Already one has been highlighted by Dr. Ravinder Singh. That means the landslide risk management strategy that has been developed at NDMA. And NRSC in 2000, they have done a national project on landslide hazard zonation mapping on 1:25K scale. That was multi-organization across like IIT Roorkee, our own IIRS Dehradun, then CBRI, and there are many other organizations also are involved in that. And recently, Geological Survey of India, they have been doing the 1:50K susceptibility mapping, and major parts of our country has been covered. So I could see in landslide front, of course, there are a lot of academics, they are working on this domain, but on the national scenario, these are the three major works done in India. Let me give you a overall our national picture how the landslides are distributed. In one of our recent works, we have divided India into three landslide provinces. They are mainly in the northwest Himalayan province like Kashmir, Ladakh, Himachal, and Uttarakhand. Then we have northeast Himalayan province consisting of 8 northeastern states. Then peninsular India, particularly the areas in the Western Ghats. We don't have much landslide lakes in the Western Ghats given the terrain and the lithology like we have in the northwest Himalayas and in the northeast Himalayas. If you look at the table on the left side, you can see the database which NRSC has compiled based on the satellite data analysis, something like 76,000 landslides we have now since last 20 years. And the state-wide distribution is also listed over here. And the numbers are increasing over years, not in hundreds, but in thousands. So that's a thing we need to pay attention to. But why they are increasing? What are the drivers of landslides? I could say that it's precisely because of high rainfall. That's what we could see recently in Assam, and of course last year in Kerala and in Maharashtra. There is also a long-term climatic change. There's a study done by Binit Kumar et al. In Wadia Institute. They have shown that in the Nanda Devi area, the glacier melting is happening quite rapidly. At the same time, we have less precipitation, that means snowfall is decreasing, and the temperature is increasing. So these are the ideal recipe for kind of large landslides to occur in the higher Himalayan sequence. This figure which we have worked on the Kerala landslides published in Current Science, it says that in 2018, there is roughly 100% deviation in the rainfall. So that led to 5,000 or more landslides in Kerala and Karnataka and Tamil Nadu. So these are the climatic extremes. We have never seen such kind of landslides before, and it's happening now because of high rainfall and less snowfall and glacial retreat. Of course, we know that our Himalaya is a young mountain. It's rising. We have tectonic plate boundary active faults. Rock types are very fragile. On top of that, we have some developmental activities which is bound to happen, but then we have to bear the cost of that also. We did an exercise to find out the district-wise exposure ranking of the landslides. So more or less, we have around 147 hilly districts in India which are prone to landslides, and Uttarakhand, of course, you can see in this figure. This work was published last year in Landslide Journal, and the Rudraprayag district in Uttarakhand is highly prone to landslide. And in the current context, if you can look at this Northeast India and Assam, this yellow color polygon corresponds to Dima Hasao. So Assam, we have roughly 8 to 9 districts that are prone to landslide. Dima Hasao stands #1. And we have seen this year lots of landslide, more than 5,000 landslides we have mapped in Dima Hasao. So this is how we can have a strategy to understand, to mitigate landslide disaster. So why? Because in the context of Glacier Lake, you must be thinking, why to know these kind of things? Unlike Glacier Lake, where the positions are well known, because we have been monitoring for let's say 20 years or 30 years like that, the landslide lakes, they are very rapid and they are very unknown. They will occur only when there is a suitable condition, and that can be found out by susceptibility or hazard zonation mapping. So that's why we need to know also the susceptibility potential of our country. And you can see over here the distribution northwest Himalaya. We have lots of landslides basically. Roughly 1,006 square kilometers of landslide area we have mapped in RSC. And then Northeast Himalaya and the Western Ghats, more or less similar kind of landslide area, but the numbers are varying. This is the old database compiled in 2018, and the numbers have increased now. In terms of the geology, you can see the greater Himalayan sequence and the lesser Himalayan sequence. They are more prone to landslides in our country. So I'm trying to give, because you, the faculty, the researchers, they have done work in the specific area, they have brought out nice results. But in a pan-India, this is kind of study we have done because we have the our national database on the landslide. We could find out like what is the amount of rainfall required to trigger landslide. So overall, you can say that the amount of rainfall required in the Western Ghats to trigger landslide is less compared to the amount of rainfall required in the Himalayan region. And the kind of control of slope, the kind of control of land use, you can browse through this paper, you will get detail of that. So this is what in the national perspective. And lots of landslide products are available in public domain in our ISRO's geo portal, which is called as Bhuban. We have the susceptibility map we have prepared with a lot of collaboration across organization that is available. We have a mobile app which we have developed that is also available. You can use that data and collect the ground information like location and photographs, different attributes. We have the landslide early warning system which is running. Basically, it is across the some selective routes, not across all the states and districts. So every day we are using the rainfall forecast, and we are giving the early warning for landslides 3 days in advance. So you can refer to that. The landslide inventory, you can see this sample example over here, the Arunachal Pradesh, how the landslides they are distributed, and a lot of parameters of each landslides are also available. So this kind of database are available in public domain. Those who want to do researches, I believe the BI standard, the BI's organization will be enriched by this kind of information while they will work out as a standard for landslide lake outburst flood. This is kind of rapid response we have provided because at ISRO we run a disaster management support program wherein we work near real-time mode and provide support to the state disaster management, national disaster management, line departments, and many organizations. So these are the response we have done: 13 Kedarnath disaster, and then Rishiganga, Kerala, Raigad, etc. With this is overview of the landslide kind of disaster in India. Let me go straight to the topic, that is the landslide dam lakes. As you can see in this slide, we have roughly some 5 types of landslide lakes, type 1 to type 5, and the illustration is self-explanatory. And you can see the type 2. Type 2 is, as per our experience at NRSC, type 2 is landslide lakes are quite frequent in the Himalayas. But now the question is flooding. The irony is that we are now seeing floods without a landslide lake also. So that's what we have seen. I'll be covering few things. If we have the landslide lake, then we can estimate the area, volume, and then we can do hydrological simulation, and we can do a risk assessment to that. But without a landslide lake, how to do? That's a new challenge. I mean, to the scientific community, to the BIS, and to the scientists like us, we need to find new ways how to deal with that. Of course, there are certain things which we are working out, but then we need to have some more confirmatory results to tell something on that. Okay, so for landslide lake, what we need is a landslide volume information. In the sense, how much the damming has happened across the channel. We need to know that. The best way is to find out the digital elevation model. This work we have done in 2011 and published in IEEE. So you can see that we have that time, fortunately, Cartosat 1 mission was there. So we have a multi-temporal stereoscopic satellite data. So we could generate the DEM before the landslide event and after the landslide event, and we did a cotton field analysis that gave us the landslide volume. This case study is in the Chamoli district in Uttarakhand. You can see over here. The point I want to make here, because it's a BI standard discussion. So when you do a cut and fill analysis using a pre and post failure DEM, one has to be careful about the pre-DEM. Normally what happens, we have SRTM DEM or ALAS DEM or Copernicus DEM or Kato DEM. So they are basically the surface models. You can see here, before the landslide happened, there are a lot of tree cover over here. So you need to devegetate the DEM. That means you need to convert the DSM to DTM. So then only you can do the cut and fill. Otherwise, your volume estimation, your simulation will go wrong. So this kind of analysis we have done, and we found the landslide volume was around 500,000 cubic meter. This is what kind of a critical information for LOF analysis. This is another case study which we have done in the Jhanskar Himalaya in December 2014, I believe. There was a large landslide which happened across Fuktal River, and we have, as you know, ISRO have a lot of satellite images, and as per the disaster management program, we have continuously monitored this event. There was a special team constituted by NDMA for continuously monitoring. The fact is that you can see here, this was the winter time, and provided the blockage happened because of the landslide, and the water started accumulating, and because of low temperature and high altitude, something around 3,800 meters, the lake started freezing, and the length of lake was almost 17 kilometers. Though it is a remote area, but there are few infrastructures, few settlements in the downstream. So we have been continuously monitoring this event. And the challenge here was that how to find out the landslide volume. Every time we don't have a pre-landslide DEM and the post-landslide DEM. So here we have applied an innovative technique, and by geomorphologically reconstructing the landslide surface, you can see the top view and the upstream view and the downstream view. So we have reconstructed geomorphologically based on our expertise and based on the pre-disaster data, and we found out the landslide dam height, and then that became the post DEM, and we had already a Cartosat 1 pre-DEM. So we did a cut and fill analysis because that time we didn't have any post stereoscopic mission. This is a challenge, and we can do this only because this is a steep gorge. The accumulation zone has not spread to the lower slope areas. It was all lying over in that valley. So that gave us an opportunity to prove our new technique. And this work was also published in the Landslide Journal in 2017. You can see here the source rock is basically shale and limestone, and the dip of the limestone and the slope, they are parallel, the perfect recipe for landslide to occur. And we have shown that the event happened in 2 episodes. So that led to formation of the first lobe and the second lobe, and that led to the blockage. So by continuous monitoring with the CWC and NDMA and GSI, there was some manual intervention to remove the blockage also. But then in the month of March onwards, the snow started melting, and the overtoppling happened actually. It was not a entire breach, the slope breach, and the piping was also happening. So slowly the water could flow downstream, and there was no major damage, though some kind of agricultural land in the downstream they were affected. Here we could found the 2.7 million cubic meter is the volume of the debris. Now, this kind of information highlights the role of digital elevation model. So right now we don't have Cartosat 1, but there are future missions of ISRO coming up. They are approved, but they are, we will having new stereoscope mission, so that can be used. Of course, you have drone, that can be flown over this area, but it's slightly difficult given the kind of inhospitable terrain, this kind of terrain. Then another case study, what happened in 2014, is the Sankosi River, which is a tributary to the Kosi River, which flows through Bihar state. There was a dam which was formed across the Sankosi River, and we could continuously monitor that dam. You can see a multi-temporal satellite image on the 5th August, and then we have over 9th August, then we have 17th August, and you can see in the image there is a overtoppling on the right side of the lake. That's because there was a manual intervention by the government of Nepal. They slowly removed the debris and allowed the water to overtopple. And from the right side to the 17th September, it is almost emptied or near emptied, and the water is overflowing in the central part of the landslide dam. So you can see these are all type 2 kind of landslide dam, which I have mentioned before, and they all happen because of rock slide or rock fall. So that's kind of thing which is happening in the higher Himalayas or greater Himalayas. The kind of rock fall there, they are creating a lot of landslide lakes. And in this case, the lake length was something like 2.3 or 1 point something, to around 2 kilometers, something like that. So this is what a monitoring of landslide dam lake could lead to slow releasing of water. And this was, of course, approachable by road, but there are many places where one cannot go, like I have shown you Zanskar. Then monitoring becomes one key parameter to do a risk analysis in the downstream part. Another case study for landslide lake is basically 2016. We have in Sikkim, there was another big rock slide across the Kanaka River in near Mangan in North Sikkim district. And that led to, you can see the pre-image over here, the Kanaka River is flowing, and the river is blocked over here because of a rock slide. But then slowly it was removed, and the overtoppling happened, and there was no flash floods in the downstream. So far, a landslide lake burst kind of things, not very common to our knowledge. It was slowly overtoppling, and then water is getting released without much damage to the downstream until unless the Chamoli came. That I will touch upon on my subsequent slides. Yeah, so now here is a disaster which has been studied in much detail and across country also. I was reading one recent article by Professor Pradhan from Earth Science Department of IIT Roorkee. This is, of course, our own work which I am showing. And he has said that more than 20 papers have come out of these disasters. So you can see this is the source area and how the flow has propagated. And this is where we have the NTPC Tapovan Bishnugad hydroelectric dam was there. So what happened is basically, here is the source area, and this is because there was a large rock slide. And the rock slide is basically a wedge type failure, typical wedge where you have schistose planes and the joint planes crisscrossing, and that led to the failure. But the bad part is that over that failured rock mass, there was a hanging glacier. So when this happened, the glacial mass, you can see the sketch I have taken from another paper, where you can say that how much thickness of ice was lying over the rock mass. So when it slided down, it was almost a uniform steep slope, and it crash landed over here. It crash landed over here, and then the flow went downstream, and it blocked the Rishiganga river over here. The lake was formed, and then subsequently downstream, the Hydel dam was damaged. But then initially, there were a lot of theories coming, what happened, there may be some lakes, but absolutely there was no lake at all. Then from where the water has come. That's the kind of theory which all the scientists now investigating. Some results have come. One result says that, you can see here, we have done this multi-temporal satellite images from 2015, 16, 18, and you can see the scarp, there was an existing scarp, but that was widening because of the high temperature, the melting and the freezing and thawing action, and the lesser amount of snowfall which is happening over that area. That culminated in kind of the morning disaster on 7th February 2021. This is kind of landslide volume which we have estimated almost 2.9 million cubic meter. That's kind of volume India has never witnessed before. This is first time in India. And this is one of the top 5 or 6 rock slides which have happened across the globe also. And the size of landslide is enormous. The crown length is almost more than half kilometer. So this kind of gigantic disaster is very difficult to visualize. And of course, nobody can go to that area on ground. And these pictures you are seeing, these are taken by us in a heli sortie. And Professor Ajanta and myself, we are in the same Indian Air Force helicopter, and we have taken all these pictures to understand the foliation pattern, the joint pattern you can see over here, and what is the cause of failure over that area. A lot of crevices are still there, and you can see the mass which is, I am just hovering my cursor over here. This is a crevassed hanging glacier. This has subsequently failed also. So this much part has failed. That means this hanging glacier has already failed. It didn't do any havoc downstream because it was a small mass and it was all accommodated within the valley, unlike the previous event of February 21. But then subsequently in near future also, some part of overhang is still there which may fail in future. So the authorities need to take care of that. Of course, we are doing some kind of work. We're in touch with this NTPC team, NDMA, but more kind of surveillance need to be done by the ground authorities or dam authorities. This is what happened within the tunnel where lots of work, unfortunately, they lost their life, and the entire tunnel is choked with mud and water. So it couldn't be opened up timely. And this is what the debris flow mark you can see, the debris flow mark where the flow height has reached because of the Chamboli disaster. Fortunately, we have the planet scope image. We could see the movement of the debris front. You can see on 7th February at 10 hour 31 minute 51 second, the debris flow has reached over here. It has not reached the Tapovan Hydel Dam. So the question is about the early warning, what is the latency, and lots of things need to be discussed. And this is what zoom view, you can see the before image, the rainy village and the after village, kind of a monstrous, they call as a Himalayan tsunami that was moving within the valley of Dhauliganga. That could be captured by this Planet One satellite image. And down below you can see the dust clouds. When the flow moves, a lot of entrainment happens. That means the soft sediments and the soil material lying on the valley side, they are all eroded. So that's because we have a lot of dust cloud also seen here. This work also we have published in the Landslide Journal last year. This is the close-up view of what happened. This is what around another image around 10 hours, 31 minutes, 51 seconds. And this is a 58 minutes. That means roughly after 27 minutes, another image was there. So you can see in both the images, the dust cloud very clearly. That means the rock failure, the rock fall which was happening, it was happening for a period of, let's say, some time, maybe 30 minutes like that. And that all amount which once transcended here, I was telling you, that led to generation of lot of kinetic energy, and the frictional heat translated into the kinetic energy, and that melted instantaneously all the pulverized ice which has fallen almost kind of a 2000 meter. And that mass started moving downstream. And the glacier meltwater, the crust glacier meltwater started moving downstream. There was no lake formation also, even for a few minutes. That also we have found out based on certain kind of some markings on the valley walls. There were no formation of lake and accumulation of water over that area. So it was all instantaneous. This is what we have reconstructed the event sequence based on the our geomorphological reconstruction using satellite data. We can say that it happened around 10 hours, and there are few studies done by geophysics team also across various organizations. They said that the seismic data was also useful to find out the exact timing of that event. And you can see from around 10 hours to 10 hours 58 minutes, this event continued. And in between that, all the things happened. The flow moving and it is going inside the tunnel and then damaging the Tapovan Dam. In fact, the flow has gone almost 50 kilometers downstream from the source area. This is a very long distance which have traveled without a lake formation. That's the criticality we need to address. Other than we should think beyond landslide lake for flash floods now. And you can see some close-up of those source area. This is a Pleiades data, the French satellite data. You can see headscarp and how the foliation planes are dipping, how the joint planes are dipping, and the inset shows the pre-failure image before it happened. You can see a lot of cracks and crevasses. It's indicating that the joint plane is slowly opening up. We can monitor that. There are different techniques. It's a remote area, so satellite remote sensing is very useful using INSAR, using pixel offset. But then we have a large task in our hand. How much area we can monitor? So that kind of information we need to take to our future analysis, how to monitor this kind of opening of cracks. This you can see is a kind of debris which is deposited on the Rontigard Valley. You can see this is a half-meter satellite image giving you a lot of details about the slumping, the cracks on the debris which is deposited. Some amount of water is also accumulated in the upstream side, and the downstream side some amount of water is flowing. That means there is a piping happening also. So we wanted to find out what is the stability of this landslide dam. So as per the international studies done, there are a lot of index available. Some of them are like morphological obstruction index, then hydromorphological dam stability index. So that takes care of the dam height, the catchment area. So we found out the MOI and SDSI, both they are giving you unstable condition. So this dam has to, a small landslide dam has to breach. There are two dams actually formed. This is on the Rontigard, there is a small dam, and there is another dam. Okay, this is about the damage of the Tapovan image. This is before disaster image, this is after disaster image. You can see amount of debris deposited in the dam and its infrastructure. This is another image, another lake which is called as Rishiganga Lake. That was also formed on the Rishi-Ganga river. But this lake is also breached in the last monsoon. It's no more existing in that area. And we did one simulation of that Rishi-Ganga lake, if it breached totally, how much time it needs to reach Tapovan, by doing some approximation about the depth of the lake and the height of the landslide debris dam. Of course, the lake volume was not available, but later on, there are a lot of studies done by Indian Navy, and the lake volume was available to us. The flood hydrograph shows that the peak discharge will be around roughly 600 cubic meter per second. This is kind of peak discharge which we can expect at the Tapovan hydel site. So this kind of simulation of the landslide lake outburst flood has been done by NRSC. And this is another case study similar to, it has gone to notice of a few researchers, I believe. This has happened in Arunachal Pradesh. Last year, there were news that the Kameng River in Arunachal Pradesh, a lot of fish died. And the debris has come from the top side, but they didn't know where it has come. So you can see the image. This is the pre-disaster image, and this is the post-disaster image. So the lot of debris lying over this area, they are typically similar to kind of debris which you have seen in the Dhauliganga Valley, the gray mud kind of thing, that indicating that they are sourced from the glacial moraine areas. But was there any glacial lake? No, there was no glacial lake. There was no landslide lake. From where it has come? Then the theory is again kind of instantaneous rock avalanche followed by ice avalanche. Then crossing happened, and then all melted water flowed downstream, and they have flown almost, I think, something like 10 kilometers downstream, and it is very clearly seen. The imprints of the debris flow and the flow height is very clearly seen in satellite image. And this is the source area which we could narrow down, and we are working on a new article on that. We could narrow down, this is the source area where probably the glacier has collapsed, and that led to instantaneous melting, and that led to flooding downstream in Arunachal Pradesh. So this kind of thing which I was telling you, that flooding happening without any landslide lake. So we need to consider these parameters in your BIS. This is one small example before I go to my GLOF topic. This is a debris flow which happens frequently in the Western Ghats. One need to take a note of that, though the topic is on the Himalayan areas, but this kind of things also needs to be addressed. They are very dangerous. I mean, this kind of case study in Idukki in 20 led to death of more than 70 people. They are all tea estate workers. So this kind of debris flow modeling we can do, and do kind of simulation, and what are the areas prone to landslide debris flow on the downstream part that can be brought out. Now I'll take a few minutes. Now coming to the glacial lakes. So NRSP under the NHP project has taken up a mammoth project of inventorying all the glacial lakes. So this kind of thing which we have done at NRSC is that different types of glacial lakes we have mapped. You can see this over here, like there are terminal and dammed glacial lake, lateral moraine glacial lake, Sork glacial lake.
Hello.
So these kind of different types of, yeah.
Ajanta here. I'm sorry to interrupt. We will have to wind up a little bit quickly because media team is here for media briefing. So I'm sorry.
Okay.
Yes, sir.
How much time do I have?
Sure, sir. You can.
No, already time is over. Just wait.
I was given time up to 1:10, I guess. So
1:10. We were given till 1:10, but actually the media person came here. So
okay. Now let me finish it. I'll not take much time. Okay.
Yes, sir. Yes, sir.
Yeah. So this kind of glacial lakes which we have inventorized, and three basins, the major basins of India. This was done under the NHP project, which NRSC has taken up with CWC. And we have covered up the Indus Basin, the Ganga Basin, and the Brahmaputra Basin. And We have been doing it for a long time. During 2009, we have done, then 2011 to 2025 also we have done. And this kind of a glacier lake database we have generated. You can see all the statistics of glacier lakes are available basin-wise and state-wise also, and the country-wise also, whatever glacier lakes we have. This is what NRSC has done for more than 10-hectare size of glacier lakes in 2009. I can say that this kind of a biodata of glacier lake has been extensively prepared by NRSC, and most researchers can work on that. They're really available on NRSC NHP portal, and I'll give you that link also. And this is kind of a glacier lake monitoring for South Lonak Lake across multi-temporal images we have done. You can see that in 2013, and a GLOF simulation also we have done for the South Lonak Lake, how the area has increased from 37 hectare to almost 102 and subsequently to 120 hectare. And since we didn't have a precise information about the glacial lake volume, we have taken different scenarios with the depth of 20 meter, 30 meter, 40 meter, and the peak flow were established. And this is kind of flooding. The simulation was done. How much area it will be flooded downstream? That was demarcated. And this is what recently, which NRSC has very successfully completed, a large database of glacial lakes in our country in 2021. A very small size lakes of more than 2.5 hectare was identified, roughly around 30,000 glacial lakes using research@2 list for image. They have been identified in our country. And this is kind of portal which NHP Bhuvan portal, where you can see basin-wise glacial lakes, then state-wise glacial lake, all kind of informations are available in this kind. Then you can prioritize the lakes for glacial lake outburst or risk analysis. The Indus River Basin Glacial Atlas, Ganga River Basin Atlas, they have been all released. The database is given to CWC, NDMA, and you can download this data also from this site, NRSC site also, and Bhuvan site also. So this kind of database are freely available. I think it's opening up a new way how the glacial lake outburst research can be done in our country, thanks to the NHP project of NRSC, and we have prepared a lot of details on that. So I'll summarize with that. We have now a reality is that more landslides are happening and more flood due to landslides are happening. That's a reality. It's because of the climate change, I can say. We need to establish a landslide field laboratory to do a cutting-edge research to understand the challenge of climate. We have to monitor large cracks, what happened exactly in Chamoli. That kind of things has to be done priorly for other areas. The Glacial Lake Atlas provided a unique opportunity to do a research in India, and we need a multi-institutional collaboration for LOF and GLOF research. So with this, I thank profusely our Deputy Director, who is Dr. B.V. Rao, who is spearheading this activity of Glacial Lake studies, and then Dr. Binod Kumar, and my colleagues over here, Raju Sir, Durga Rao, Simadri Rao, Nirmala, and Priyam. So without their support, I could not have made this presentation. With this, I come to an end. Thank you very much.
Thank you so much, sir. And yes, huge amount of database generated by NRSC and lots of work done by the NRSC. So we would look forward to your contribution as well as comments and advice for the standardization. And there is a little change in the program. So we will be ending this session here itself because media team is here for media briefing. So the presentation which was initially scheduled for Praveen Thakur as well as Pratima Pandey, it is shifted till afternoon, and we will start little early. We will start at 2 o'clock. Sir, which is sir. So we'll start little early. We will start at 2 o'clock, and then we will have presentation from Praveen Thakur as well as Pratima Pandey, who will be representing IIRS. So, and I know that there are lots of questions for Tapas sir and for NRSC team. So we are reserving all those questions till the panel discussion. And during panel discussion, we will have all those discussions, all those questions we can discuss. So thank you so much, sir, for this wonderful presentation.
Thank you, Ajanta.
Forward for your participation. Thank you so much.
Thank you.
I hope the video is audible to all of you. Apple sir, Kulkarni sir, Ravinder. The video is audible to you all.
Volume देना है।
Welcome to another chapter of BIS Talks. In a way, this is an extremely critical chapter since it talks about one of the basic survival needs of humanity. Modern societies need water for so many purposes for domestic, commercial, industrial, and agricultural usage. Our water resources can be widely segmented into two categories: surface water and groundwater. Their efficient management has emerged as a critical and immediate need for India. Uneven distribution of water poses a grave problem for our nation. That is where the Bureau of Indian Standards has been playing a critical role by setting standards to follow through its Water Resources Department. Let's first hear from Mr. R.K. Jain, who is also holding the post of Chairman CWC. He will acquaint us with the importance of setting standards in this domain.
Standardization is very important for not only bringing uniformity in the procedures, but also to have quality control. I congratulate BIS for striving hard in formulating the standards and covering almost all the aspects of the water resources. It is very important for any country to have its own standards, particularly in the field of water resources, depending upon local geography and other local conditions. Subject of water resources covers aspects like irrigation, drinking water, water for industrial use, planning and design of water resources projects, interstate issues, environmental issues, etc. Standards are needed for wholesome and organized development of any nation and also to resolve conflicts. There are 18 sectional committees in the Water Resources Division Council, WRDC in short. These committees are playing a vital role in this endeavor BIS. WRDC advises the new subject areas to be taken up for formulation of standards, keeping in view the national needs and priorities. It also advises on the matters relating to R&D needed for the establishment of the standards or their revision.
Let us hear from a senior BIS official on how standards are developed and the overall working of the technical committees.
The Water Resources Department has formulated over 450 standards. Over hundreds of experts put their heads together in this extensive consultative process of standard formulation, which is based on transparency, consensus building among stakeholders. The areas of work under Water Resources Department can be broadly categorized into surface water resources, groundwater investigation and management, river training works, and planning and management of water resources projects. Surface water resources is a big focus area. Within that, we work on dams and its appurtenances, such as spillways, weirs, gates, etc. We also work on reservoirs, lakes, and canals, instrumentation of hydraulic structures, and geological investigations. Another important category pertains to river training works, covering structures like embankments, groins, revetments, etc. Lastly, we deal with standards on management of water resources projects. Here we develop standards such as progress report and completion report of river valley projects. We also formulate safety codes in construction, operation, and maintenance of river valley projects. Beyond this, we also work on subjects such as estimating unit rate for civil works, etc.
Now that we know the functional aspects of how the technical committees operates, let's take a closer look at their areas of operation. Dams, barrages, and weirs are man-made barrier structures built across a stream or a river that stops and regulates the flow of water in controlled fashion. Indian standards ensure that dams built in India are safe, economical, and durable, and are fit and functional to serve the nation. Let's hear about this in detail from our expert.
Let's talk about the Indian standards for dams and canals in our country. IS 6512. This is one of the important standards which gives the design criteria for any solid gravity dam. Design analysis is a crucial part for any dam before its construction. We understand that this stability analysis takes into account the several critical load combinations. The standard gives 7 different load combinations for it. They are mainly the dead load, reservoir and tailwater loads, uplift pressure, earthquake forces, earth and silt pressure, ice pressure, wind pressure, wave pressure, and thermal loads. We have one more important standard, IS 11855. This is design and use of rubber seals for hydraulic gates. This standard gives the recommendations. The standard covers 6 different types of seals depending upon their shapes. They are namely angle-shaped seal, flat seal, music note seal, double caisson seals, double bulb seals, and corner seals. It also lays 6 important parameters to control the quality checks comprising of tensile and elongation test, shore hardness test, water absorption, weather impact test, and its materials. The standard also covers an important requirement of cladded seals. The cladded seals are fluorocarbon cladding is provided to reduce frictional forces. The standard also gives the test requirements of adhesion test.
Dams also need to have certain appurtenant structures to enable them to discharge their operational functions safely and effectively. A number of standards are in place to ensure this. For instance, this is a spillway. Spillways are passages for letting out waters safely when the reservoir overflows. IS 5186 and IS 6934 covers the design criteria for different types of spillways.
Dam as a structure is not alone. We have more standards on appurtenant structures. IS 11527 is a standard that deals with the structural design of energy dissipators for any the spillways. Energy dissipators are important structures to protect the erosion on the downstream part of any dam or spillways. The design of downstream protection works or energy dissipators below hydraulic structures occupy a vital place in the design and construction of dams, barrages, and outlets. The standard covers hydraulic jump type, silting basin, and bucket type energy dissipators below spillways and outlet works founded on rock. We see that in the standard, the structural design of floor sap consists of the following steps: determination of uplift forces, details of anchorages into bedrock, that is, diameter, number, and spacing of anchor bars, determination of the length of considering dislodgement of rock mass against uplift force, working out details of slab reinforcement. IS 15058. This is another standard on PVC water stops. These water stops are used at transverse contraction joints for use in masonry and concrete dams. The contraction joints in masonry and concrete dams provide passage through the dam, which, unless sealed, would permit the leakage from the reservoir to the downstream phase, and this could be harmful to the structure. To check this leakage, water stops are installed in the joints adjacent to the upstream phase. The standard takes care of the quality of this product and covers 12 different parameters to check the quality, right from its material, aging, weather impact, weight, water absorption, and its dimensions. The standard is BIS certifiable, and presently we are having 6 number of BIS license against this standard.
Water release from dams may also be controlled using gates and shutters. The Bureau of Indian Standards Code IS 13623 criteria for choice of gates and hoists provides the basic classification of gates. IS 5620 gives recommendations for structural design criteria for low-held slide gates. BIS has developed a vast array of Indian standards for planning, design, construction, and maintenance of various types of dams and their components. Before we move on to take on to the next category, let's take a brief look at some key standards within this area.
नमस्कार ये हमारे पाकिस्तान
नापा ठीक है, एक आध 2 मीटर से कोई बहुत फर्क नहीं पड़ रहा। सॉरी सॉरी।
Hello. I guess I am audible to all of you.
Yes. Yes, yes.
Hello. So PDF file दे दीजिएगा. So good afternoon to all of you. So we are starting with our rest of the presentation. So our next speaker is Dr. Praveen Thakur and Dr. Pratima Pandey, and they are representing IIRS, Indian Institute of Remote Sensing Data, which is a center of ISRO. Praveen Thakur has extensively worked on Glacier, Lake, and Glacier since last so many years. He has done his PhD from IIT Roorkee, and before that also he joined IIRS, and from there onwards he is working on Glacier as well as Glacier Lakes as well as on cryospheric sciences. Together we have done so many expeditions. We have been to Kedarnath also just after the disaster, do the final studies also. We are working on few projects together. Presently, Praveen Thakur is the head of department of water resource department of IIRS, and recently he won prestigious specialty award of IIRS. And before that, he has also won the Young Scientist Award of ISRO, specialty award of ISRS, and Young Scientist Award of ISRO. So congratulations to Praveen. And Praveen, yeah, the platform is yours. You can make your presentation. Thank you so much.
Thank you, Dr. Ajanta. So it's good to come back to our parent institute where we have studied. I can see some of my teachers, some of our colleagues, and also in the morning I could see some of our students who have studied at IRS. So continuing with the today's topic. So some of the slides will be overlap with the previous speakers because the lakes are same and the models are also same. Satellite data is also same. Screen sharing.
स्क्रीन शेयरिंग नहीं है तो उसमें शेयरिंग है
I hope the screen is visible. So continuing with this topic, so I'll be focusing how previously also, as we know, these glacial lakes and also the landslides which can occur anytime depending upon the topography and the precipitation events. So remote sensing is the tool which help us to map these kind of lakes and also continuously monitor them and to prioritize the lakes which are vulnerable for the breaching or vulnerable for the flooding and also mark their flood marks if the breach has already happened. So I will start with this one because although Kedarnath is in the field due to a lot of human casualty and it was a very heavy rainfall event for 3 days, and on 17th morning we had this big lake breach. But before that, we had a very significant event in the Parichu Lake, and satellite monitoring was done for continuously for 2005 by ISRO as well as for the NASA. But the 2000 event was the trigger point where it caused significant damage to the at that time we call Natwa Jhatri project. And later on, that event actually happened, and in the night time, in the Rampur, at the time we were in third year of the college. So more than 22 meter flood wave came in the middle of the night, and all the infrastructure of the project got washed away, including the human casualty. And this is a typical landslide lake, and the same lake was again 12 in 2005. But by the time the satellite images were more frequent, and it was monitored extensively by Government of India, by the Department of Space as well as the hydropower companies and Government of India. So this was the main trigger point to continuously monitor the glacier lakes, and in this case the landslide lakes. So this is why they are being formed. This is obviously due to the increasing air temperature. The area which is getting vacated by the glacier belt And if it is in the pro-glacier or the moraine, the frontal part, that becomes more dangerous, and it will be unconsolidated material, which will cause it is vulnerable for the breaching if there is a high enough water and other triggering factors. And most of these glaciers I have shown the retreating rate. So this is just an introductory slide. So these lakes which are at the end, we call them pro-glacier lakes and the moraine dam lake. And in Kedarnath, we have some lakes, something like what we call the block lake. One side it has pro-glacier, this one, and other one side it was blocked by the mountain. There are many lakes also, like in the Chukta lake, Dr. Jan has shown in the surrounding areas, there are a lot of salt lakes, which are glacier lakes, but not that much dangerous. These lakes are what we should monitor extensively. And the traditional method for mapping this is simply using the NDWI. So this is operational in nature. ISRO, NRC, all are doing this. And just to give the perspective of this one, so this is the field work Janta was mentioning. So after the 2013 breach, so this is the photograph taken from the lake side. So as you can see, the glacier has retreated, and it was a single glacier, which is now two parts. And this is the lateral medial moraine here. And this is all temple area has been constructed on the path area where the glacier was present. So this area, or even the breach will happen, the downstream area is also vulnerable for the erosion and also the sediment transport. So not just water hydrodynamic modeling. When we do this modeling, you have to consider the erodibility of the mass which is going to come and how that mixed flow we can simulate, because that will change the flow dynamics totally. And in this case, somebody has asked in the question, I think Dr. Kansal. So if the big boulders, the boulders half of size of this room, because initially the steam power is so high, slope is so high. So those also get transported depending upon the discharge and the slope. So this is the terrain what we are talking about. And this is just an example of how these glacier lakes look like. Sometimes these like A, B, and C, they are the lakes which is glacier has gone, and these are the ice dam lakes. So, and then we have this pro glacier lakes, which is the Moraine Dam lake. This is the Gepang lake, and then you have this landslide lake, which was found in the Brahmaputra river in the Tibetan part. So these are some of the examples. And this is that Vasudhara lake, where lot of supra glacial lakes are there, and they keep on combining and making a bigger lake. And most dangerous type is what we find in the Bhutan. We call them cascade of the lakes. So all the main glacier have retreated, the branches, so they are making the series of the lakes. So if the upstream lake breaches, it will cause breaching of the downstream lakes as well. So these are some of the factors. In Kedarnath, as we have discussed informally, so in Kedarnath we had this snow avalanche. The lake, which was one side mountain, one side moraine dam. So there was a heavy snowfall preceding that particular event, and then on the mountain side there was a huge avalanche, which was actually reported by Wadia also, and it is the photograph taken by the Uttarakhand police. So apart from the avalanche, the rock fall, sudden discharge in the water, and but I have observed personally the freeboard, the water level between the top of the moraine and the water level in the glacial lake. That is very important. So if there is a very less freeboard, that can be a cause of trigger. So when we think of in future for monitoring, one sensor can be at the lake, one in the downstream area. Then because it is unconsolidated material, apart from the loose rock, there can be some ice patches within the morainic material, which can suddenly cause the piping if there is a sudden increase in the discharge or distability to this particular dam. Then from the space point of view, the most important point what we have seen is the digital elevation model. So if you have the very good quality digital elevation model, all our downstream simulation scenario will depend upon this. And then in the morning, Dr. Kulkarni also suggested that this is a roughness criteria. So managed roughness, those coefficients will depend upon what kind of land use what we are having in the downstream. And then if you want to see the upstream area, how that lake is getting filled, you use the time series of the snow map. And then the regular monitoring and mapping in the monsoon season, mostly it will be clouds. So if there is a sudden heavy rainfall, then the synthetic aperture radar images will be helpful. And in NRC that the morning Dr. Tapas has shown, now in that water body information system, reset data is already there, including the Sentinel one. So both freely available foreign as well as the Indian data sets, optical and SR is there so that you don't miss the time period. Although the frequency will be 6 to 12 days, but if you have some critical lake, you can also use the Planet Labs to use that daily monitoring. Then high resolution images that have been shown for the pre and post events. River cross section, again, it is the function of the digital elevation model, because most of the lakes in the downstream, the water will be very small stream of the water will be coming. So for all this modeling purpose, the river cross section, the how much water a river can carry, that can be derived from the this DM. And these are the precipitation. And if you are putting some early warning system, most probably there won't be any mobile connection. So satellite-based communication will be the most important if you are using that for the early warning. And then you have this DGPS, you can use these to increase the accuracy of the elevation what you are driving. And then we combine this in hydrology field, all the data into our hydrological and hydrodynamic model, which show in the further slides. So this not covered. So this just the space perspective. ISRO has done with CWC under NSP, but now independently also Central Water Commission on the monthly pre-monsoon, post-monsoon regular mapping of the lakes is done, and email is sent to all the stakeholders, all the states, district commissioners, and those who are responsible. The database for entire Himalayan region is shown, and they identify certain area that if there is a change of within plus minus 5% more than that, that lake will be considered highly vulnerable, and more focus should be on that one. And this is the work that we did. Once you identify the lakes, there are multiple lakes, multiple types of lakes. So you have to classify them. So this is the work one of my PhD student did in 2017. So we identified a number of glacier lakes in using Cartosat 1 and LIS4 data, and also some the Google Earth images. And then these are the criteria what we have used from the published literature. So out of these lakes, which lakes are more vulnerable for the GLOF kind of phenomena, which are less vulnerable? So if you see the total using the analytical hierarchical process, you give the ranking. And this is the field photograph in 2014. We have gone there. And this is the Cascade Lake just upstream of the Khangbu. There is a RV post before the Guru Dongma. So this is actually now a hanging glacier. So this is a series of the lakes. But unfortunately, we have the eco sounder. We could not get the permission because in the Sikkim, due to the Buddhist, this one, you are not allowed to do the boat, take the boat. So we could not do the, despite having the eco sounder, we could not do the depth survey of this particular lake. But from the satellite data and Cartosat data, we could approximately identify this height of this particular dam using the stereo photogrammetry data. And finally, we gave this ranking to each of these parameters, and then all these lakes were identified. This is that Loner Lake, where Dr. Dan is also working with the NDMA for the detailed early warning. Then this is Guru Lake. The main Guru is less susceptibility, just upstream of that one is high susceptibility. And then you have this cascade of the lake, which is also under the high susceptibility. So this is the standard procedure, and now under NHP also Central Water Commission and NRC they have done for Indus and Ganga basin and identify the lakes which should be monitored more focused way as compared to the other lakes. Then the similar work we have done, because it is not just the Indian portion where lakes are the Ganga basin major part is in the Nepal. So in the Nepal, especially in this Kosi basin, there are large number of lakes where ICMOD has actually reported this. So using the Google Earth engine, we could map this. This is the Kosi basin. Although the distance between the Indian boundary where it enters India and the lakes is far, the discharge may not be that much significantly higher, but still the lakes are vulnerable in this particular area. So this is one example where this India Kasha Glacier, this is one sub lake, this is the main lake, which has shown the consistent retreat, and it has been proven in the literature that if the glacier is terminated by a moraine dam lake, it will have faster retreat rate as compared to the glacier, which is not terminating to a lake. So you can see here the all the glaciers, the time lapse of the multiple images of the land sites. So you can see the growth. And this lake has been actively monitored by ICMOD, Government of Nepal and UNDP. So they have established this early warning system where they are monitoring the lake water level as well as they are monitoring the downstream automatic water level recorders. So these are the statistics of increase in area of these lakes in the eastern Himalaya, Nepal portion. Then coming back to Indian Himalaya, so this is the Gepang Lake, which is the largest lake in this northwest Himalaya, and it is approximately 1 square kilometer by 2021. And 2017 again I tried to do this bathymetry survey, but unfortunately we lost the path and our boat could not go due to the logistic reasons. So this year again we are trying this, but what I want to emphasize here the freeboard is almost more than 15 meters. Although it is progressively increasing, looks like a typical Moran Dam look, very dangerous. And people have also published, and we have also done the hydrodynamic simulation that how much area is going to be inundated, and more than 10,000 cubic of discharge is coming, one of the scenarios. But one thing what government of Himachal has done here, if you see this particular stream coming from the right hand side of this lake, they have made a open spillway there. So it does not let the water to reach that particular freeboard. And there is a, after this Moran width is also very long. It's more than 50-60 meters. And in the bottom there is a piping also. So there are the 3 channels. One is the sideways, there is a channel. Then there is a man-made open spillway, which always keeps this water level to certain threshold. So these are the some of the, because the earlier experiments where we have done this piping and this what you call siphoning, that will not work in the winter because it will freeze. So this open channel spillway, in the future, if the still size is increasing, what you can do, you can increase the size of this open spillway so that you can maintain the free water board level. And then there are 2 lakes which my next speaker, Dr. Pratima, is also going to cover. We call them the camouflage lakes. So these lakes, what you see here, typical lakes, they are at 4,000 meters mostly. But these lakes are at 4,700 meters. So they are visible only for few months in a year. And rest of the time it will be frozen. And they have also shown more than 100% increase in area in last 10 years. So this is one lake which is in the Gangna basin. And it is also in a typical area. This is available for Sentinel-2, 8th October. This is for 19th September. So this has also shown consistent increase in the area which needs to be studied in detail. The second lake, it is also studied by Dr. Ajanta and is a PhD student. It is also a typical Moran Dam lake, but here it is more dangerous. There is a steep mountain, so which is vulnerable for the avalanche as well as for the rockfall in future. So this is in the Boriganga basin in the Milam. So this is also a lake which is situated at 4,800 meters, again visible only for a few times a year. Rest of the time it will be frozen. Then our practical experience, I have done 3 lake survey and our team has also done reservoir survey. We have won this handheld eco sounder, and this is the digital leveler with the bar-coded staff gauge for the river cross section. This is for the lake. So this we did in 2013 after the Kedarnath fieldwork. I went to Samudra Tapu Glacier and this Chandratal Lake. So it's man-made. You have to go to the boat, stop, take the GPS reading, and also take the sounding. So we have estimated depth of 29.5 meters for Chandratal, which is actually exactly matching with the published literature for this lake. So this lake survey we did in Samudra Tapu. So we found the depth of the Samudra Tapu lake to be 12 meters. And we have seen the water mark much higher than that. So in the literature, people say Samudra Tapu Glacier Lake is vulnerable, but actually it is not vulnerable. Although size is increasing, but its water level fluctuates during the monsoon and non-monsoon. This is a very open area. After the survey, our team actually rowed their boat from the lake outlet to the downstream area, 4 kilometers downstream, where our base camp was there. And if you use this traditional Google formula for the Samudra Tapu Lake, it will overestimate the volume by a factor of 3 to 4. If including Fujita's model also, it won't work there. So it is very important. And then there is a issue of the spectral reflectance versus depth. If it is the dark appearance is there, that means its depth is minimum 20 meter or higher. If it is shallow, it will be cyan color and it will be up to 10 to 12 meter only. So that is also one way of directly inferring the depth. Then the third one is the topographical modeling. Because you from the DM we know the side slopes of the DM, so that way we are planning in the future how we can improve the estimation by using the remote sensing data, ground observation, and topographical modeling to get the better estimate of the lake depth and the volume. Then this is one study we did with NIH Roorkee. So this is same Glacier Lake versus Dharatal. Although it does not fit into all the criteria which will define its glacier one level, but still because it has a lot of hydropower station that we did in 2016. And this is the same concept with the 100-year peak flood overlaid with the GLOF. So if the GLOF happens in the winter, your discharge will be minimum at the NTPC side. But if it happens during the monsoon, like in 2013, when the rivers were already flooded, so that is worst case scenario. In that case, discharge will be 3,500 and 1.5 to 2 hours after that. So all these scenarios were generated for different breach, and this is the 100-year plus log water depth at these hydropower flights. So this is the normal flood water depth, and this is, but these all criteria, again, we had to revisit after the 7th February 2021 Chimote, because whatever we have calculated for this lake, the flood wave are much higher, especially for the that NTPC project site in 2020.
Just 1 minute. Just go to the first slide before this. Yeah. So the Dhauliganga, it has increased means this size, because in 1998, 99, even 2000, when we were working, it was 0.14 square kilometers. And for 5 years, we have measured, means observed it. So it has not increased.
This is the we did in 2016. This is 2008. Now its area is much more. I think the Wadia team is here. They have recently visited. I think it is more than point, because they are super glacial lakes. They keep on connecting, keep on disassociating.
Actually, when we did it with Mr. Kulkarni, so it was 7 moraine lake, 1 diminishes, 6 was there, and the maximum size was 0.14 square kilometer.
0.14.
No, 2005, 2000. So just check it that really it is so much increased. It was 0.14 when I was working.
0.19 only. 2004, 0.19, 2008, 0.203.
It has increased.
Yeah, increased, but it is not that much vulnerable because they connect. The supraglacial connects with each other. The India Glacier, what I have shown earlier, it was a small patch of few disconnected supraglacial lakes. Later on, they connected. So this, I think, what you are.
Thakur, you are saying not much. It is 50% increase. 0.14 has become 0.203.
Then actually what happens now, what is happening in this league, sir is right. Their number.
No, I'm not saying sir is wrong.
Yeah, but the field conditions I can tell you. I have done twice field work in October and this year. What is happening in that system? Some lakes are draining out itself. Then some are connecting. So what will happen when you observe the satellite data? You will find that the lake area है उनमें. 2015-2017 में भी यही हुआ है कि आपको लगेगा कि इस लेक का एरिया अचानक से श्रिंक किया, अचानक से बढ़ गया. In these those 3 years, so you will find that what is happening. That is happening continuously.
So this what we are discussing. I gave example Samudra Tapu Lake, sir. So area wise, it will look same. The outer boundary, but in the monsoon, the water depth when the peak discharge from the glacier comes, is the water depth, because we have seen that water level, it will be double. It can be 20 meters, and inside that islands will not be visible. If you see
that freeboard, what you said, is very vulnerable.
Yeah, that is important, and because it is channel is open, there is no obstruction. It is not closed valley. So from that point of view, it is not that much vulnerable, because whatever water level rise is seasonal, it easily gets drained. So this is the Kedarnath event, and just before the disaster, there was a heavy snowfall, and it was almost up to the peak. And later on 15th to 17th, the avalanche came from this particular hillside. So that avalanche actually initiated the flood wave, and that breached that particular path. So this is the Ajanta, and our student is also here. So we did this full lake survey, DGPS survey, and this is we at the bottom of the lake. This is just the downstream area. And the main damage was in the Rampada. So the people were stuck on the 16th night. Actually, there was a heavy rainfall. The first flood wave came on 16th night. The second came on the 17th. And with the hydrodynamic model, Mike 11, we used the sediment transport model. So we could estimate the peak flow of 1100 cubic from the Kedarnath beach. And then this is the Badam Lake in the Jamshedpur Himalayas, which Dr. Jain has also shown. So for the 2-hour breach peak with the peak discharge of 2100, so we have this one project with the government of Ladakh. So we have to map all the flood hazard area, including the rainfall runoff, flash floods, and also the lake. So this we are using combination of both one-dimensional and the two-dimensional. And this monsoon season after Gipang survey, we are going for the this bathymetry survey of this Padam Lake. So earlier estimate of the empirical methods we will be improving by using our own bathymetric survey. And also we are procuring high resolution stereo data which can give us the digital elevation model of 5 meter or less to get the better inundation scenario in the downstream area. And this is the same the lake which has shown. There also we have generated. And then they big small airstrip in the downstream area. Jacket out. So one of the scenarios which shows the 20 meter depth breaching in 40 minutes, this entire area is under the flood. So we have to be careful that which scenario is sufficient, what volume we have taken. All will depend upon our initial condition, and we assume 50 to 75% of the lake will drain in case of the breach. So those kind of scenario will depend upon initial estimate of the lake volume, depth, and also the type of topographical data you have used for the hydrodynamic modeling. And then this was a unique phenomena which happened in Gangotri in 2017. So there is a Nila Pals here, so which was a this supraglacial lake here definitely forming, but with the retreat of the Gangotri glacier. Earlier, this is the entire area in maybe 100 years ago. This entire area was with the glacier. So as it is retreating, the water from the Gangotri glaciers like the Meru glacier, they are not obstructing any this one here water. So it is freely hitting the vacated area and it is hitting the moraine dam. So its structural strength is less. So in July 2017, there was a heavy precipitation event, and this precipitation most probably it is liquid precipitation, and it caused the breaching. And the earlier signatures for this one started to develop in winter of 2016. So you can see the initial breach has actually happened in November 2017. By the July, this full breach happened, and this is the satellite image few days after the breach. You can see the slurry of the water which is going, and water on the top of the debris is also seen. So we have done the first time the UAV survey, and in 2014 myself have gone and done the terrestrial laser scanner survey of the snout. So we could accurately estimate the change in the volume, and also we have done this debris flow modeling using the RAMS model. So actually the amount of debris which are eroded are more as compared to the deposition as per the DM analysis, mainly because they are getting transported. Our DM was from the Kato side, October. The event happened in July. So between October and July, the lot of mass got eroded in the downstream area. So this shows the importance of the time series of the satellite data, multi-time series digital elevation model, and also UAV in such a tough area. Although there was no casualty or damage because it is nobody is living. Golgotha is 4 kilometers downstream, so no damage was there. But these kind of hazards, as the glaciers are retreating, these slopes, vulnerable slopes, receive more of the liquid precipitation and accelerated snowmelt, so they become vulnerable for such kind of events. And this already Tappa has discussed. So in our hydrological simulation, when we did the initial back calculation that how much discharge was there by marking these flood water levels, so more than 10,000 cubic discharge was estimated. And in 2016 also, from the time series of the analysis, this hanging glacier actually broke off in 2016. And that signature is clearly seen in this time series, and in 2021 we know the full breach of the rock and ice mixture. So here again, the importance of the more frequent satellite data. So it is the more frequent satellite data, and at that time, our Dr. Kaswan, he activated the disaster charter. So that latest image, what we are seeing, which is being used by all the researchers, so that becomes freely available. So you can generate very high resolution topographical map to see what has happened in this particular way. Then in 2018, there was a huge rock slide in the Brahmaputra region. This is Yarlang Sangpo. So this is the this particular mountain here. Three. What's the name of it? Namchi Barwa. So there are also a lot of landslide, and its relief is this is 2,500. This is 7,000 meters within 8 kilometers. So this entire glacier, the mass gets deposited here, and it caused a lot of this landslide and blocked the path of the river. So although Government of India and Government of China has a sharing agreement between the monsoon season, that is June to September end, but in the October also they called Indian counterpart. They told the landslide has happened and you take care in the downstream area. So that is after the monsoon. So we did this brief simulation with the help of CWC and this one. So just before 6 hours before the breach, we could share this result with the CWC and the ministry here. And then there is a active monitoring program for the Brahmaputra region, which we are part of. Many agencies are there, which actively monitors such kind of landslides which can happen in the future. And in after Chamoli incidents, after 2018, Chinese government put the water level sensors at this particular point. But in April 2021, 2 months after the Chamoli incident, the same kind of Namchi Barwa, this particular hill, there was a big rock slide. So all their sensors were blocked, and this area was again blocked for 2 to 3 days. So there also, then again that automatically breach happened, and here discharge can be as high as 40,000 cubic. And the highest recorded discharge in human history, present human history, is from the tributary of this Parlong. That happened in year 2000. So that big landslide happened, and it remained there for 1 year, and then there was a breach. So 1 lakh cubic water was released from that particular reservoir, and it was heavy flooding in the Assam region. So these kind of landslide hazards are much more higher and much more unpredictable. Where although we know that these are geological formations, there is a high probability, but still there is a uncertainty. From the remote sensing, what we can do, we know the topography before this landslide occurs. So we can do the back calculation how much area or the volume is going to be there if there is a landslide in a particular point. And this is just to see in the natural system and man-made system. In 2018, Roorkee Dam opened for the first time all the gates. So this is the simulation we did with Sachinanand. I think he's here doing PhD. So we did this hydrodynamic simulation with the Aster, although DN quality is not that much good, but still we could simulate. And we sometimes get the false security that dam is there, nothing will happen. But in case of the heavy flooding, so if you open all the dam gates, all there is a breach. So these flooding can. So I will summarize this. So we need the combination of remote sensing and ground-based continuous monitoring of the critical glacial lakes, not all the lakes. Hydrodynamic modeling based on the for the flood inundation and the breach scenario, and good quality DTM and length, depth, and volume, which is the most important for generating all scenarios, and establishment of law for this landslide. I have kept in red because we don't know where the landslide will occur. So as soon as we know the location of the landslide, we can immediately calculate the volume and then training capacity building, which is also part of the NDMA manual. So with this, I complete my presentation.
Thank you so much, Praveen. So we are not going to take any questions now. I think we are going for the panel discussion. I'm sorry about that. And I request our next presenter, Pratibha Patil, that I will complete the presentation shortest possible time so that we can go for the panel discussion. Yes, before that, our BIS team, they want to thank Praveen Thakur. Yeah. So Pratima, you can share your presentation. Till the time she shares her presentation, let me introduce Pratima Pandey. Pratima Pandey is scientist at Indian Institute of Remote Sensing in Department of Geological Sciences. And she's actively working on glaciers, glacial lake, as well as cryospheric sciences from geological point of view. And yeah, the first paper on Chamoli disaster, the one which took place on 7th of February 2020. So that one, I think it was published by Pratima Pandey and her team, along with Prakash Johansson from IIRS, which was published in ISRS, which became one of the documents based on which many other papers came or many other studies also came. So Pratima, yeah, you can start your presentation, but please, our request is to finish it as soon as possible. Thank you so much. Pratima, we can't hear you. Pratima, we have requested you to unmute.
नंबर है क्या चलो क्या आवाज नहीं एजेंडा का है एजेंडा
सुनाई नहीं पड़ रहा प्रतिमा। हेलो हेलो, हाँ प्रतिमा, सुनाई नहीं पड़ रहा यार। म्यूट, तुम उसमें क्या हेडफोन लगा रही हो क्या तुम? अच्छा, वैसे ही तुम ना नहीं ले रहे। तुम लैपटॉप यूज कर रहे हो, क्या यूज कर रहे हो? किसमें? सिस्टम यूज कर रही हो, ओके। ड्यूरिंग पैनल डिस्कशन हमें सभी को जो है पैनल में लेके आना पड़ेगा।
You to unmute us.
प्रतिमा, आप प्रतिमा बोलो। स्पीकर से चलो ट्राई करो, ट्राई करो। आई थिंक प्रतिमा ने फिर से ज्वाइन किया उसमें, उनको पैनलिस्ट बनाना पड़ेगा। फोन से भी उसने ज्वाइन किया शायद। चलिए
आवाज को जा रही है बच्चे वहाँ कोई ज्वाइन किया
कर लेंगे।
देख लिया।
Deadline के साथ था। तो ये सारे प्रोफेसर का प्लान हो गया। वो मत करा जाता है। या बता दो ये सो और
श्रेष्ठा
Shrestha is from Sikkim. Yes, is Sikkim.
नाम प्रतिमा श्रेष्ठा।
Pratima Shrestha अलग है। हाँ प्रतिमा। नहीं हो पा रहा है। ठीक है। I think by that time सभी पैनलिस्ट को ऐड कर दें क्या?
He's already added. We are trying to add.
शायद वो उसमें है ना वो सभी नहीं कर पाएंगे।
ये कर सेपरेट कमेटी के लिए बोल रहे हैं। सेपरेट क्या? कितना
Yes, voice is there, sir.
Pratima, you are audible now.
Am I audible, sir?
Yes, you are audible. You can share your screen.
Okay, I'm so sorry for the delay, sir. I'll be very quick with my presentation.
No issue, but yeah, there is one request. Kindly try to wind up your presentation as short as possible. Anyway, sorry about that. We need to go for the panel discussion.
Not able to hear, sir, properly.
तुम ज्यादा बोलो मत, बहुत टाइम खराब होगा। तो एक तरफ से आवाज आ रही है, आने दो।
So, sir, visible?
Yes, visible.
Okay. Good afternoon, everyone. And I'm so sorry for this delay. It's always a little bit challenging to talk on a subject and a topic on which your peers have already talked so elaborately on. However, I'll try to do some justification with the subject. So today, I'll talk little about the glacial lake outburst flood under the changing climate scenario. So this GLOF on which today's workshop is based on basically is the direct glacier hazards, apart from other hazards like snow avalanche, ice avalanche, and the indirect being the more related with the water resources issues. So before going into GLOFs, let us see what is the situation in the Himalaya, the current situation observed from the same studies. You can see from this graph, which is reported by Sabins et al. In 2020. This shows the change of, can you see my cursor movement? Hello? Hello? Sir?
मत करें, सोच जाए सब। बोल कि आप बस बोल दीजिए अपना। Don't interact with us. नहीं तो फिर वो चक्कर पड़ेगा।
प्रतिमा सब बढ़िया है, तुम बोलते रहो।
कौन से बोल दो, कौन से?
So this is the situation of the temperature for Himalaya compared to the Indian landmass as given by Sabins et al. From IITM. We can see how the temperature rise is so much more in the over the Himalaya than the Indian landmass. And there is also one Himalaya facing one more issue, that is nowadays called as EWD, that is elevation dependent warming, where the rate of temperature change or the rise is more in the high altitude regions than in the lower altitude region, which is very evident from this graph given by Sabins et al. So how the glaciers are responding to this change in temperature? Most of the glaciers in Eastern Himalaya or Central Himalaya or the Western Himalaya are retreating and melting in response to this change in temperature, except for a few glaciers in Karakoram, Himalaya. These are some of the examples like Gangotri Glacier. This is the Bada Sheke Glacier, which has got fragmented also over the years. This is Parvati Glacier. This is one glacier known as Shumkalpa or Ralam Glacier in near Milam Valley, and the Samudra Tapu Glacier. And it has also been found that the glaciers which are terminating into lakes are more retreating faster than the lakes which than the glaciers which are land terminating. So this example again shown by Dr. Piketty in his slides. This is the Gepangad Glacier and showing how the lakes has increased from 1889 to 2021. So why I am talking about the retreat of glacier, because the rate of retreat of glacier or the melting of the glacier has directly or indirectly has the relation with the lake outburst flood because of the deglaciation or because of the destabilization. So it has also one more implication to the climate change, because when the lake is increasing and the glacier ice is decreasing, so the lake and ice ratio is changing, which is also affecting the albedo ratio, incoming versus the outgoing albedo ratio, which is again further implication to the warming. So what are the prerequisites for GLOFs study? The foremost prerequisite is the basic data generation, which is the glacial lake inventory and temporal monitoring of the lake. Then what are the lake types, where these lakes are located, what are the dam type, what is the permafrost condition, what is its relation with the mother glacier, and what is the condition of the moraines. Keeping this in mind, we have done the inventory of the Uttarakhand glaciers, Uttarakhand glacier lakes, where we have found about 1,353 glacier lakes covering an area of about 8 square kilometer. And we have classified the lakes also. Apart from doing the inventory, we have also done the glacier and glacier lake interaction study by utilizing some larger lakes of with the number 137 glacier lakes, and we have found in congruence with the this elevated temperature warming, our glaciers are also changing more in the higher Himalaya than compared to the lower parts of the Himalaya, and also the lakes are also like expanding in the upper part of Himalaya also. And there are about 24 lakes in the Uttarakhand, which has doubled of its size since 1994. 7 new lakes have formed, and few lakes were stagnant, which have not grown in the size because they were mostly the sub type of lakes. This is the example of the Niti Valley Lake. This lake size was in 1994, and this is the 2017, the area in the 2017. So very evidently it is showing that the lake area has changed over the years. So after doing the inventory of the glacial lakes, it is important to identify the identify the critical glacier lakes. Which are the lakes which are critical for causing GLOFs? So these are mostly the moraine dam lakes, and which are the stable lakes like the sub type of lakes. And again, what could be the parameters or what could be the triggering factor which can initiate the lakes? It could be extreme rainfall, or it could be rapid mass movement, either be landslide or avalanche. It could be triggered by earthquake also, or it could be triggered by permafrost melting or ice calving. And the mechanism can be either overtopping, which is overspilling, or could be piping failure also. So while doing the inventory of the glacier lakes in Uttarakhand, we have came across one lake near Mazar Top, which was mostly frozen throughout the years except for few months, like in the summer season. So we just called it camouflage lake. And when we have done the temporal analysis of the lake, we found that the lake is expanding with an alarming rate. Like from 1999 to 2000, the lake has expanded by 133% of its area in 1999. You can see this, the temporal change in the size of the lake. This lake is in Bilangna Basin. Again, the lake as shown from the planet datasheet between 2016 to 2020. We can see this lake from between October 2016 and October 2020. It has almost 200 meters has backrested the glacier. So for this particular glacier calving was the main reason for the expansion of the glacier lake. And why this lake is important? Because there are several hydropower electric projects located downstream of the Bilangna lake. We can see here the lake is located somewhere here, and there are several hydropower projects in the downstream areas. We have also tried to analyze the surrounding of the glacier lake. How what is the surrounding and how fragile is the surrounding of the glacier lake if it is susceptible for or vulnerable for GLOFs. So we found this is the lake. This is an old picture from Google Earth, because most of the time in Google Earth you'll find it frozen. These are the surrounding features you can see. These are basically the ice and water saturated debris, which are indicating that it is the surrounding is rich with the permafrost region. So they have very highly permafrost region areas, which are again we have analyzed through the temperature data, Moody's temperature data. We can see here, this is the biennial surface temperature data, where the lake is here somewhere, and it comes under the continuous permafrost region. And also we have done the avalanche susceptibility mapping and found that the lake comes under the surrounding of the lake comes under avalanching areas. So this lake was highly vulnerable for causing glacier lake outburst flood. And we have also carried out one modeling simulation using HRS and found that the downstream areas and the power plant projects are highly vulnerable if this lake is causing any disaster or failing, both under overtopping mechanism and under piping failure. So what could be the possible trigger for this lake? The mass movement into the lake could be one reason, because it has very fragile avalanching zone. Then extreme rainfall could be one of the reason, or morainic ice, since we have seen that the area is full with the permafrost. So the ice melting or the moraine melting can also be one of the trigger for failure of this lake. The other lake which we have found very vulnerable recently is the Kedarta lake. We can see this Kedarta lake. It is situated about 18 kilometers upstream of the Gangotri town. The town is here directly below the lake, this Kedarta lake. And recently we have seen this year only that the lake has increased from 0.11 square kilometer in 2018 to 0.19 square kilometer in 2019. So you can compare the change in the size of the lake in 2 years only. These are from the Landsat data. So though this lake is small and it is a little moraine dam lake, but the surrounding again for this lake is very fragile. As you can see, this lake is the little moraine dam lake. The raw glacier is coming from here. The moraines are ice-cored moraine. Again, the lake is situated just behind in the lateral side of a debris-covered glacier. This glacier, you can see, is again very fragile and showing lots of water in it, as seen from the supraglacial lakes. So, in case if monsoon is very erratic and some triggering factors are there, that time it is possible that this lake may overturn in the glacier, and it can, like with the water saturated and debris saturated here, can flow downstream areas and cause a flood-like situation in the Gangotri town. Again, this was the Safed Lake, which talked about by Dr. PKT, and it has also been simulated by Janta Sir's team. And this lake has been found to be expanded by 103% from 1994 to 2021. We can see it was the situation in 1994 and 2020. The lake has almost become more than double of its size, and also very vulnerable areas in terms of avalanche and all. So what could be the remedy? As Dr. Sanjay sir has also mentioned that the open cut could be one option and the tunnels could be the other option. but seeing the location of the most of the glacier lakes which are expanding very fast, like for example, this lake in Chamoli, we can see this is located at about 5,550 meter above sea level. We doubt how we can make any open cut or any tunnels or channels in such type of lake which are located so high in altitude. So coming to the mitigation, the GLOF hazard mitigation can be the hazard mitigation itself or the vulnerability mitigation. As GLOF hazard mitigation is little difficult, but the GLOF vulnerability mitigation can be easily, we can accomplish or we can just start. And the strategy could be like related with the GLOF strategy could be in 3 stages. In the stage 1, we can monitor the glacier and the hazard related analysis. In the stage 2, we can do the consequences related analysis. And in stage 3, we can do the economical analysis. So the strategy could be like a susceptibility assessment of the lake and the glacier also, because a glacier and glacier lake, we cannot like separate them from each other. Both are affecting each other. So we can start monitoring the and mapping of glacier as well as glacier lakes, do the assessment of permafrost, do their surrounding assessment, any mass movement study we should do, and we should also do the assessment of the dams. Also, we should generate the various worst cases scenarios for all the vulnerable lakes. And in the monitoring, we can do the real-time monitoring of precipitation temperature, and based on those, we can like alert the downstream people and the areas. So these are some of the vulnerable lakes which have found to be expanding very fast. This we already talked, Bilanga Lake. Then this again already published, Safed Lake. This is again one of the lake in Pithoragarh which have expanded by 94% of its area in 1994. And this is again the Chamoli Lake. So apart from this, the Kedartal also. So this is all from my side. Thank you so much. I just wanted to show you this slide of a red lake which is located in the Leh area near the Ladakh. Though it is not susceptible for any lake hazards, but then it is a unique of its kind. So thank you so much for listening to me. Thank you.
Thank you so much, Pratibha, for this wonderful presentation. So next we are moving to panel discussion. And during the panel discussion, I think all the presentations, whichever has been done, if anyone has any question, we can discuss. And yeah, I request Oza sir to kindly moderate the session. So we'll take just 2 to 3 minutes before we start. So we go panelists.
I will request Sri Bhanu Prakash ji from BIS to tell us the motives behind having this workshop, just for, the knowledge of Professor BBC. Yeah. Okay. Yeah.
So good afternoon, everybody. Maybe after lunch, we are starting this panel meeting. So we are happy to have with us Vijay P. Singh, who is from Texas A&M University. Correct, sir?
Yeah.
From Texas. See, consequent on global warming, thinning and rate of glaciers, Indian Himalayan region is getting more vulnerable. Formation of new glacial lakes and expansion of existing lakes in these regions are the cause of catastrophic flash floods in the valleys. Recently, NDMA has framed the guidelines, compendium and summary of policymakers for the management of glacial lake outburst floods, GLOFs, where it has been desired from BIS to frame national standards in this field so that consequences of such incidents can be controlled and its financial, environmental, and social impact can be reduced. So based on this we have put up a proposal to our Water Resources Council. Then the council has reviewed the proposal and considered. It was in June 2021. The council appraised the importance of the subject and its relevance in the present context because of various disasters which have occurred in the recent past. And then the council decided that formulation of national standards in this field is a requirement and formed an ad hoc panel which is constituted under the convenership of Chief Engineer, DSO, CWC, comprising of the following members. Number one is Central Water Commission, two is Geological Survey of India, three is NDMA, fourth is NHPC, fifth is IIT Roorkee, sixth is NIH Roorkee, DRDO, then Wadia Institute of Himalayan Geology, Dehradun. Then the council requested BIS to approach these members to constitute a panel for nomination of experts and work on the modalities to bring the standardization in this field and come with the subject proposal through this panel. So the council also requested BIS and the panel to review the necessity of framing a separate sectional committee under the council if required. So this is the reason we are having a panel meeting today. Sir, please take on.
So thank you, Bhanu Prakash. So I think in the last, I think he has also mentioned that if there is a need, a separate sectional committee can be also constituted, provided we have number of posts to be formulated. If they are in large numbers related to this topic, then we can go for a different sectional committee also. So that's the view of the BIS. So we'll deliberate on that at a later stage. But right now, I think if you are going for the development of the code, how should we proceed? What are the points to be considered in framing the code? So I think this is the main thing. The objective of this seminar is that after this seminar, we must work on the development of a code. Okay. So what should be the content of that, outline of that? So before we start discussing on that, I think some of the points were nicely covered by, I think, Thakur Sahab, and I saw that many things can be put in the code. But before going for that, I think I would request Professor Vivi Singh, just to say a few words on the important topic. And of course, we have framed certain other points also, so we will be deliberating on that. But I think, sir, few words.
I don't think I need this. Can all of you hear me?
Oh, okay.
It's such a small building.
People are online.
People are online. Oh, okay. Thank you. Okay.
Are we meeting me?
I'm not really quite familiar with what has been discussed, but since I have worked in the area of cryosphere, including snow, ice, and glacier, so I'll just share with you a sort of perspective of mine. First of all, glaciers essentially are a moving ice mass. So there is no such thing as a stationary ice wall. That's not what defines glacier. By definition, glaciers must move, but they move rather slowly. And also, regardless of what happens, the glaciers always undergo the metamorphosis of accretion and decay. On a long-term basis, what should happen is that on the whole, as the glaciers move, the glacial mass must remain pretty stable. Not necessarily on a year-to-year basis, but on a long-term basis, the glacial mass must remain stable. Now, the question is, what makes it unstable? Now, obviously, all of us know because of global warming and climate change, the glacial mass loss has been occurring. But at the same time, there are instances where certain glaciers are also increasing in their volume, their mass. So no, it is not true that all glaciers, and there are several million glaciers, and that all glaciers are losing their mass. Some are growing, but a large number of glaciers are essentially receding. And the point is, some of the glaciers, which are the lifeline of the critical river basins in the Indian subcontinent and also parts of China, unfortunately are having some issues that require serious consideration. The issues with respect to the mass of soil. But some of these glaciers essentially feed the Ganges, the Brahmaputra, and the Indus, plus a whole bunch of other small rivers. That's where really the problem is, and including Yamuna. So the question is, so there are two issues. First is, do we have enough data on a long-term basis to prepare a water budget of all these glaciers? And in India, and I cannot really speak with any level of authority whether or not we have the long-term data on glacial observation. I really do not know. My hunch is, based on what I've seen in the United States and certain European countries, that some glaciers have been monitored for a long time. Others have not been. Because this issue was not important maybe before the early part of the 60s. So that is when this climate signal started showing up its impact, which we are witnessing these days only too frequent. So if we plot actually the temperature data over a period of nearly 2,000 years, you find that in the last nearly 70 years, approximately 1964, 1965, particularly in our country, the temperature started going up. Now, of course, the temperature has always going up and going down, so it is not something really new. But the problem is the trend has been monotonically increasing, and that is what is defining what we term climate change or global warming. And of course, we are also witnessing that this year it has been unusually hot in the country. Now, of course, we complain that it has been unusually hot, and the complaint is entirely legitimate. But also in the United States, there has been the temperature. I was just talking to my daughter in Dallas. The temperature over there is almost close to what we have in Roorkee. So this phenomenon is happening all over. The temperature is rising. Now, of course, there are certain places where the temperature is not necessarily increasing that much. So I know even in the United States, the east of the Mississippi, you are familiar with the US geography, the temperature really is not going up. In some cases, it's going down a little. Now, of course, the increase in the decrease in the temperature is only a small amount. But this small amount makes a huge difference in the weather patterns, to the climate, and it has other far-reaching implications in other sectors that we are concerned with, particularly the agricultural sector, the energy sector, the industrial sector, the aviation sector. It pervades, the weather and the climate pervade the entire human civilization. It's part of our life. And so that is really very important. But the question, let's go back, the question is, what does this instability of glaciers actually do to us? The instability can be defined in many different ways. It's not just a matter of losing or the loss of glacial mass. Also,
Sir, your voice is not audible.
is it on? On. Maybe you think it's on. Yeah, can you not hear me? No. Maybe I'm by mistake. I'm not.
Oh, it is audible.
It's not audible.
It is audible.
Okay, thank you. Okay, thank you. I'm sorry if by mistake, maybe I might have partially covered the blue spot. In any event, okay. So coming back to the instability of a glacier is manifested in many different ways. First, of course, it can be a regular loss of water, but also it can be a sudden loss of water. That's where, this is what causes what we call as natural disaster. And that can basically break glacial lakes, and which in turn can culminate in flood disasters. And of course, this is what happened in flood disasters. And of course, the loss of life and the loss of landscape, and of course, the destruction of highways and so on. Now, can we prevent it? I'm not sure we can entirely prevent it, but we can manage it. So no natural process can be entirely controlled. And at the same time, I don't think we should even make an effort to control these natural processes entirely. What we have to do is two things. First, we have to manage, mitigate the harm of the detrimental effects of these natural disasters. And second, we have to learn how to live with it. Just like floods. The floods also have a benefit associated with their occurrence. The floods are a natural disaster. Yes, natural disasters, they become only because we do not know how to manage ourselves and how to manage others. So the question becomes not one of technology, one of management. So when it comes to the glaciers, as I said, the glaciers have been undergoing this change for millennia. So it's not something that is happening only recently. Recently, glaciers are losing their mass beyond capacity to be built. Because every year there is accretion. But the loss is a lot more than the accretion. That's where the problem is occurring. But can we really do anything to change that water balance? I'm not sure we can do it because we have no control over the nature. What we can do is, how can we take advantage of the loss of glacial mass, glacial instability? That's what we have to do. For example, on the other end, leave aside the glacier, look at drought. The droughts are occurring in the United States. 80% of Texas, which is almost as big as France, is suffering from a very serious drought. 80% of Texas. And California is undergoing a very severe drought. Much of Southwest is undergoing very severe drought. Southwest itself is almost twice as big as India is. So there are issues, but we are still not waking up. We are still not essentially learning from our mistakes. We are not learning how to efficiently use water. We are not learning how to manage our own affairs. Our appetite seems to be entirely insatiable. We cannot have an unmanageable appetite for everything. And this is where the problem is, and the United States is particularly notorious about it. If everybody in the world lived as much as the way every American lives, we will need 3 times as many resources available on the earth as we have, but the earth has only finite volume of finite amount of resources. So I think my suggestion is, I think it's a good idea to form a committee, but study, but start out with one recommendation, which I do not know whether this is already happening or not, but let's start making observations. Observations are the key to understanding science. Observations are key to making policy. Policy should not be made by sitting in ivory towers. Policy should be made based on what actually occurs on. That would be my very strong recommendation. And second, I think obviously we need science, we need technology. For example, if a glacier burst is likely to happen, I think we have enough knowledge in the country, whereby the meteorologists in association with geologists and engineers can easily predict ahead of time and provide forewarning to the public and the other authorities to take appropriate precautions so there is no loss of life. And at the same time, there should be a mechanism by which a priori measures can be undertaken before really the disaster happens. This is the only way one can minimize the impact of such a disaster. Now, of course, I've seen cases, Norway, I've seen cases in Sweden, where these things have occurred, but they have managed relatively well. And I've seen these things in the United States. Of course, the US does not have as many glaciers, but they do have long glaciers, but not as many glaciers as there are in Himalaya. For that matter, no country in the world has as many glaciers. But that does not mean they don't have, because in the US and Alaska alone, there are 100,000 glaciers. And these are very large glaciers. Alaska is as big as twice the size of France. So I'm talking about really a large number of glaciers, but certainly not Himalayas and millions of them. So we will have to learn how to prepare ourselves. Not now, but at least 50 years or 100 years down the road, so that if these disasters occurred, our generations will not accuse us for not having taken any precautions. In other words, we should not jeopardize their future. That would be something that we need to worry about. But I don't see the way things are happening that these disasters are going to reduce in their frequency, in their intensity, in their areal extent, and in their duration. These disasters are going to occur. Unfortunately, they are going to occur even more frequently. We are lucky if we don't have these disasters on a yearly basis. And these disasters basically are so many. They are almost all widely pervasive. And India is no exception by any means. We think we are doing bad, but I can assure you, even in the United States, things are really bad. And they don't really do as good a job as they think they are doing. Things are really bad, particularly when it comes to water. And of course, as they say, out of sight, out of mind, most of us don't see those glaciers. So we don't think that these things are. They are very. Anyway, I don't mean to take all your time. So with that, I think I'll just stop. But if there are any questions that I can help answer, or I can intervene once in a while, and we all discuss. This is your territory, and you should occupy the center stage. I'm on the periphery. So with that, thank you.
So thank you so much, sir. And within the panel discussion, we will need lots of your vision as well as your advice. So that's why Priya sir as well as Mujahid is proposed you to be here. So yeah, Mujahid sir.
So we can just, I think screen is not working. Yeah.
Yeah.
Yeah. Okay, that's fine.
बैटरी खत्म हो गया.
Okay.
Yeah.
Okay.
This is
No problem. So I think the very first thing that you wanted to discuss, you also emphasized the need for observation, right? So I think we also framed this one, and that's also good there. Yeah. Yeah.
I think that is good. And not only observe, also make it easily accessible. This is one of the major problems in our country. That even if we do a lot of observations, we don't make it
So the
easily.
first one is where should be observations only. Yeah. And how this inventory should be prepared, I think, yeah.
Yes, sir. To start with the discussion, there are certain questions which were raised during the presentation as well as deliberated previously also. The first thing is before we go towards blog, the first issue to map all the glacial lakes. Yes. And there are so many inventories like till now, Kulkarni sir has shown few inventories. He has developed many atlas. Pratima Pandey has also developed one for Uttarakhand. EC mode, and there are so many inventories. So first thing is standardization of inventory. How we are going to map the glacial lakes and how many numbers of glacial lake is how we are determining the number of glacial lake as well as areas are different in for the same lake in different inventories. So how to standardize that thing? That is the first thing. Second is error estimation in during glacial lake mapping. Then we are going for the vulnerability assessment. Whenever we are doing vulnerability assessment, which factors or which parameters we should consider, how we are doing the vulnerability assessment, whether we can standardize that thing, risk assessment also. So how we are doing risk assessment, or whether we can prepare grid-wise risk for the entire Himalaya, that which are the grids where risk is lying and where we need to focus for the glacial lake hazard assessment. And then we can go for the modeling part. So I think with these questions, we can start the panel discussion. And yes, sir.
So Kulkarni can say something?
Yeah, so we can start with Kulkarni, sir. We want to know your view. And at the same time, if you think that we can raise few more questions on which we can have certain discussion, then definitely we can.
Yeah, Professor Kulkarni, please.
Yeah, thank you, Professor Oza. Yeah, some of the questions which is raised by Ajanta, they are very important. And earlier also there are precedents to come with certain sort of resolution on this issue. Like the issue which he raised about there are numerous inventories of moraine dam lakes, and probably many of them inventories are done in different time. That means some of may be older, some may be new, some might be using different satellite data, some may be using different seasons. And because of all these reasons, there will be some variability in the number of lakes which are given, the areal extent of lake which is given, and maybe some misassessment about which glacier lake needs to be monitored more frequently. But this is a typical problem which we face in glacial inventory also, because if you look into the historically when we started inventory way back in 1980s, then we have different satellites, then different agencies, whether it is national or international agencies, have done the inventory. But now over a period of time, we are able to reconcile all the data and come up with a reasonable assessment about by combining the various data that how much is glacial extent in Himalayas, and there's a lot of scholarly discussion and conclusion has taken place. So there's a scope for us to look into that and say how much is glacier lakes are there and work on that issue by combining various inventories which are already done. But one of the difficult tasks for you is to say which methodology to monitor lakes should be used. And that is where difficulty comes, because the science is dynamic. And then you are going to get newer satellite, newer methods of doing it. The standardization can happen up to certain extent. Beyond that, we have to leave it to the science to progress, like what I was saying to you earlier, that how do we estimate the depth of lake, or depth of glaciers. So over a period of time, science have changed, the techniques have changed. So it may not be completely feasible for us to standardize all facets of this thing, but there is of course scope to standardize some of the facets of which we are going to do. So as Ajanta pointed out, like say how many, take the different inventories and find out how reconcile their figures and standardize, give a standard information to scientific community that these many lakes in this time frame are there. They are going to change with time. That does not mean there is no scope for further people to work on it because it is a dynamic in nature. It is keep on changing. So we knew that. There's also some way to look into, like in the morning, we have discussion about the depth. What is the volume of those lakes? Either we can go into the, because at IRS is trying to do what Dr. Thakur has said is here, he has gone into the field, collected some data. There could be further scope for us to work in how to improve the existing methods of volume estimation rather than relying only on the scaling method. There's a limit up to which we can standardize that procedure also, but there's some scope to say what are the best practices to do that as of now, based upon our current scientific understanding. When it comes to the vulnerability part, which is the next, that how it is going to burst, we can probably look into what are the facets we should look into that, whether this region can have avalanches, whether it can have ice fall, whether it can have landfall, all kinds of things. So there could be some sort of assessment protocol in order to do that. What are the aspects needs to be seen before we can declare this as a vulnerable lake? So that possibility is also there. To standardize or to say what kind of investigation we need to do. How to go about that investigation is slightly tricky part, standardizing this, because that comes into the realm of science where it is keep on changing dramatically over a period of time, because I am working in this field last 40 years and I know how in last 40 years how things are doing have changed so dramatically. What we used to do in the late 80s or late 70s, we may not do in that fashion. So codification of that will be quite demanding task. When it comes to the part which is related to the how much flash flood and routing of that, there is a definitely scope for us to do that. Whether depending upon what procedure we should adopt, there is a scope for us to codification. Then there's also further scope for us to codification when it comes to its influence on society. How we make a society aware of those things, how to assess the vulnerability. There is a standard way of doing it, and probably we have plenty of scope in codification of that facet about how it is going to affect the society. How, and there is also some way to look into like what early warning system, other thing, like what kind of instrumentation is required and some sort of codification in that part also, whether you want to have early warning system, whether you want to dewater the lake. So there is some way for us to look into those aspects. But one thing is there is it is going to be enormous task by any standard, and it is going to take some of the knowledge which is available as of now with us. We can directly dwell on it because there are a large number of group of people who have skills and understanding to do that. So we can do it. Some of the knowledge has to be developed while doing it also. So that will also needs to be incorporated into. So I think there's a plenty of scope for us to standardize the procedure. There's a plenty of scopes to leave it without standardization so that science can flourish and help us for future standardization of that. Because standardization does not mean on the basis of current knowledge, but we should have ample scope to allow it to standardize in future also, as knowledge and understanding keep on changing. So with these initial remarks, I would like to leave it. I don't know whether my remarks are helpful or not, but I will be available if there is a further discussion is required.
Professor Kulkarni, thank you very much. But I think there is some comment in the chat box, and the gentleman is Suhail Khan. He has posed this question that why selecting the peptide imagery which particular month and day should be used for area change detection? That's his question. So
I think that is one of the questions which we can,
Yes.
take into the.
That can go, we can deliberate on those issues and we can really, part of standardization, it could be part of that. So there are plenty of remote sensing experts in this group, and I'm sure we will have a detailed discussion when we start on codification of these issues.
Yes, sir.
Yeah, can I come in?
Yes.
Yeah.
Sir, would you like to say something?
Yeah, I'm Dorji, Chief Engineer, Central Water Commission.
Okay, okay.
Right.
Please.
I'm now coming. We have seen a very wonderful presentation from all the presenters. Few things I have noted. One is that Mr. Kulkarni highlighted the Parachu issue. I will come touch that. And Mr. Jain, in his key points, mentioned about the precipitation and the GLOF. If we'll take Glacier, we are having in the heights more than 5,000 and above meters. Right? Their habitations is almost, there's no habitation in those areas. Now, issue is there in one of the presentations, they have shown there's a rise in temperature. Rise in temperature means we are getting abnormal rainfall during winter also, as we got in Chamoli. Temperature was very high. There was a precipitation, first rain, then followed by snow. Now, having this rain on glacier, the density of the glacier will change. Here, my point is we are not mapping the density of each glacier. What is the health water content in the glaciers? We are talking about receding. Okay, fine. If you will talk again for receding, Mr. Chen was asking, telling the mother glacier. How far is the mother glacier from that lake? If it is connected, then definitely that will make a change in the physics of the glacier, because snow and water connection will definitely, the glacier will suck water and density will increase and slowly melting, and it will accelerate the point. Now coming to the Parachu issue, when this Parachu issue we got, first thing what Central Water Commission did is we placed two automatic round-the-clock monitoring system. One, because Parachu originate in Jammu and Kashmir, in Ladakh region, Parangla, and after flowing Indian territory, it goes into the Tibetan area, and from Tibetan again it comes at Lapsa in India, re-enter into Indian territory. What we did is Central Water Commission put two automatic water level recorder, one at Chumar, from where the river is entering into the Tibet, and one at Lapsa. The first one is to know what quantity of water is entering inside the Tibet, because lake was formed in 2004, breach happened in 2005. There, within that 1 year, we were able to know what quantity is flowing inside the Tibet and what we are getting at the border. These two has comparing these two data, we can see. Meantime, we were knowing around 70 kilometers the river is flowing inside the Tibet. So these are the good practices we have to see. Each disaster we got some good and some bad experiences. Those has to be placed in one place, recorded. Third one, second one is as related to this glacier lake monitoring. CWC, with the help of NRSA, already monitoring more than 490, more than around 500 glacier lake and water bodies in the different river basin. These are taken more than 10 hectare glacier lakes and water bodies. So here, basin-wise, lat long and the numbering of each basin, each glacier has been given by NRSC. So that is one information available with us that can be shared with the BIS also and the other institutes also. And we can see, because that is the one inventory we got with us, because we have did a lot of effort and NRSA and a lot of money, government money is already put in that. So from that, how to improve further there is one part. Second, my point is, if we can have some interaction with college of students to verify these glacier lakes. in their some academic programs, that will give us very good result, because through satellite we can see what is what is happening in that particular glacier lake, and by sending this college team, or we are sending some instrument with them, as we are Kulkarni ji was talking about the depth of, we got radar system now. This nowadays the ultrasonic wave, so many arrangements are there. We can give these students, some agency can provide this instrument, they can be trained in some lake in the cities, and they will be told to have this kind of mapping over there in the high altitude, and they will bring the result, and that can be seen. These is 2-3 points I wanted to highlight. Thank you.
Yes, nice, yes, yes.
Thank you very much. And this is my remarks related to the BPC's initiation. It was audible. So I think one of the major issues come related to disaster management. Talk about glacier, or we talk about landslide. So when we come to the disaster, so naturally our first objective is to that there is a hazard in the disaster. So we can the natural hazards we can control where we have the risk control. But then there are two parts which just now the speaker talks: vulnerability and risk. Normally risk is the hazard, the product of hazard and vulnerability. So vulnerability and risk is the where we can play some controlling part of it, managing part of it. As far hazard is concerned, we can have observed it, we can notice it, we can have inventories, like whether we have the landslide or glaciers. And not only that, because it is multi-hazard issue. So we need to think that what kind of hazards are helping or increasing the size of that, augmenting. So already landslide is there, but there could be then that precipitation part, rain, and then shaking also. So particularly in the Himalayan region, which is seismically very active, and seismically it is like the most of the Himalaya is seismic zone 5 and 4. So that also need to be considered. So there, that is part of the observation and inventory. Now coming to vulnerability parts, that will be coming from man-made also. Like once we are cutting the roads and other parts, so that man-made will be there, and that could be disaster, maybe in that case man-made disaster. So the issue is, of course, it is related to glacier or the lakes, but still we need to check what are the natural hazards and how they are adding to it. So that is my suggestion, that we need to consider the natural hazards also, observe that, and then we need to make the inventory, and then accordingly we can deal with the risk.
Natural. Yes, would you like to add something? Yes. Yes, please. Yes, please.
Hello, very good afternoon. If we look at the mineralogy, how we use for no, it is like it's a very common. We start with the mapping and then go for some kind of importance you attach to the lakes, then find out its volume, etc., and then go for the logging part and make some assessment about this. But the challenges that we see, if I see the challenges, when we start the first part of mapping, to me it looks it's easy. Easy in the sense because most of the things are based on the remote sensing data, and remote sensing data is a way of systematically getting all these data sets. The only challenge we have here is different scales, different resolution, different data sets. So that is one thing I think that experts can deliberate, and within some limits we can fix it. But then when we move to the next part is the assessment of the volume. I mean, it is the basic question what Professor Vijay Singh was pointing it out. Did we make any observation? No. All the equations are coming from Swiss or Switzerland. Have we validated? Okay, we have measured 1-2 glacier lakes, but then we have given a few values. But in the last couple of years, I don't think we have measured so many values and we have validated those constraints, whether it really gives the right value or not. So that's another challenge that we have. And I really would like to ask, how many of you really have gone to those elevations, 3,000 above? Very recently, hardly 10 days back, I was in there. It is very inhospitable. Looking at the Pangong Lake in 3 Idiots movie, it looks beautiful. But when you really go there, it's not that easy. You have oxygen problem, you have so many things. So making observation, is it easy? It's really easy. Going for bathymetric of any of these stable lakes, is it really feasible? So those challenges we have to see it. So that assessment of those parameters required in modeling is really important. And their relevance in Indian context is another challenge that we have. Then comes the hydrology part. We need to convert those volumes into a format that the model accepts. Basically, we have to convert it into a hydrogram. Then we have assumptions. We have so many things. So there also we have the errors and we have challenges. And moreover, when we reach to the final step, this is where I request this committee to really look into it. If the lakes are there, these lakes are moraine lakes, and if the slope is high, consider whether it will be debris flow or it will be a flood water flow, whether it will be Newtonian flow or non-Newtonian flow. Then what kind of software are we using for it? Is it address is sufficient for it? Does it account for all these things? Or do we need different tools at this stage? Because all the assessment, all the hard work that we have put in mapping, finding its vulnerability, and then assessing all these volume and other parameters, will be very useful if we can rightly consider all these flow types. So my submission to this committee is to consider all these points, because when we move on this, assessment part, the complexity and challenges increases. Thank you.
Thank you, sir. I think Kulkarni sir want to add something, and then we can go to other person.
Can I add something?
Sure, sir.
So since morning we are talking about how difficult it is to go to glacier lakes and take the observations of bathymetric observations. But we have to really think why it has not happened, because I am in doing this business for last 35 years. The nation which has the capacity to take scientific expedition to Antarctica, and the nation which has capacity to maintain huge bases on sea ice in glaciers, why we cannot measure some of the lake depth? That is essentially because we are looking at this issue with the kind of expertise available with individual scientists. We don't look at this issue is the expertise available with the nation. It means we really need to upgrade our approach of doing science in cryosphere. It means that we require the higher level of support system. That means if we required to go to those glaciers, we required good mountaineers. So hire some good mountaineers. In order to take them there, we might require helicopters, hire some helicopters. So do something which other successful program has done in Antarctica, whether India's program in Antarctica, whether they can hire big ship to go to Antarctica, hire helicopters to take scientists to the Antarctica base camp. Do something which is at bigger scale, which is required and which is a demand of this work, rather than saying that it takes 5 days to tracking and most of the engineer and scientists who sit in the lab will have a demanding time to go there. So we need to completely change approach, and definitely it is doable. And if you want good result, we need to look at this problem very differently. With this, thank you.
Yes, Professor Anuman, please. Yes.
So far, we are talking about the glacier lake outburst floods. I think one of the important points of the study in Serra is the landslide lake outburst floods, which I think to be at least two, I remember very well. One was in Roorkee and second basin, where the landslide lake outburst basin there, all the 70 feet of water rose entire Southern river. Many of the bridges, roads have been washed out. Similarly, one of them was.
The mic close to it, it's not audible.
No.
Use the mic properly, please.
Okay, so far we're talking about the glacier lake outburst floods. GLOF, I think it's the time when we talk about landslide lake outburst floods too. Because these are the ones which also quite vulnerable in terms of not which guidelines are not available. Whenever it happens, some farming spot or other big guidelines that you have to be. Let me just give an example of the cases which happen in people circulation, where the water routes require a big land. I mean, if I'm not wrong, more than 200 kilometers of land inside India. Where the 70 to 100 meters of water roads and many bridges and roads have been lost away. Similarly, one of the events happened in this place, 100 where artificially 100 feet of water and accumulated. Somehow it took off. So I think it is very required that we should have some parameters or some kind of procedure once it happens and what kind of things we should do. Because of course at that time they are running and could come, but every day, every hour is an important element. So this particular area I would like to say that our council should also take care of that with the experts who are involved in this and because landslide may happen naturally in many areas, especially when you have a lot of roads that are affected by road and being affected. This is not only one thing which may not happen, which is happening and it will keep on happening. So, and this kind of potential lakes will be there and problems will be there. So, this is high action. Thank you.
Thank you, sir. So now we have with us Devi Prasanna Kanungo online. Are you able to hear me? Devi Prasanna Kanungo.
Yes, sir. Yes, sir.
Please,
Yes,
please.
sir.
Yeah.
Yeah. Thank you very much for allowing me to speak something. I will give 3-4 points. One is if the 3 aspects. One is hazard, vulnerability, and risk. While looking into the hazard, we should also look into the hazard in the catchment, which is having the effect on the Himalayan river system, what we have observed on 7th February of 2021. That means we can have GLOF or LOF. Along with that, we have landslides at many places in that catchment, as well as we have snow avalanches in glaciated valley. So combining all these effects, the hazard scenario is multiplied to a greater extent when it comes to the Himalayan river system and affects the infrastructures on the downstream side. And while going to the modeling part of it, most of the things we are seeing the susceptibility of glacial susceptibility or modeling as a snow avalanche. But what we have observed in recent past that it can be a ice, snow, rock, debris combination. So the rheology of the whole material, combined material along with the water changes, and the frictional parameters along the valley also changes. So we have to incorporate all these multi-criteria system to look into the problem. And third point is I will give more emphasis on field-based measurements, though reaching to all those points will be difficult. So more emphasis on UAV-based monitoring. That can be a better approach, so that we have in temporal aspect we have some information to validate with the remote sensing information also. And in terms of vulnerability, actually we have 4 aspects. One is physical vulnerability. How vulnerable are our infrastructures? which are getting affected, like the powerhouse we got damaged. How vulnerable or what is the resistance capacity of that powerhouse? We have to take into account that the physical vulnerability, or other three aspects is environmental vulnerability, social and economic vulnerability. That will come later, but the physical vulnerability, then only we will be arriving at the risk assessment. Otherwise, many people mix up with hazard and vulnerability as the same thing, and they jump into the risk assessment. So vulnerability we have to understood, and we have to map what are the infrastructures is going to be affected if something happens in the catchment, and we have to assess the strength or resistance capability or capacity of those infrastructures, then moving towards the risk assessment. Thank you very much, sir.
Thank you, sir. So before we move to the next panelist, so I just want to tell one more thing that yesterday from last 1 week, Oja sir, then Anukumar sir, myself, Bhanu Prakash sir, then even Krishna sir, we are discussing about the modalities of our development standard. So I think it's not clear till now. The thing is, the first question is whether we need a new sectional committee which works on block, isn't it, Krishna sir? Yes. Or we want to club it with already existing committee, or we want a separate committee. This is first point on which we need to deliberate. Yeah. Second thing is, if there is one new sectional committee on GLOF or glacier related hazards or on glaciers, so the thing is that what are the sub things? Like for example, Kulkarni sir has briefed it, and Ojazar also told that it could be like one theme on which we need to deliberate is on glacier mapping or glacier lake mapping. So maybe as few people told that there are so many people working on, and NRC has already developed so much, why not all the people, whoever has contributed to development of glacial lake inventories, come up together to develop one standard so that we can use our data mutually. Otherwise, what NRC is developing, what I'm developing, if we put into same geospatial platform, maybe they are not matching. So one standardization for that thing. Second thing, maybe like for glacier velocity estimation. Like Saurabh Vijay, he is working with SAR. Praveen is working with SAR. He has developed a whole Himalaya. A few people are working on optical feature tracking also. So why not one standardization on velocity estimation, where all the people working on velocity come together and they standardize, so that even if a new research scholar is working on that particular theme, they will use at least the same standard. Standard is not that the same methodology, but there should be something should be same. Few parameters should be same, or what type of result we are expecting, it should be same. Similarly, one particular team can work on volume estimation. So why not we develop one particular team who talk about volume estimation, okay, who develops a standard in volume estimation. So like that, that's what we need to deliberate now. So yeah, next question, I think, Bhatia team, do you want to say something?
Actually, everybody is talking about the mapping and all. So before going to the mapping to the glacier lake, it is also better to map the cracks which are over the glaciers. Like we also go for the avalanche mapping and all. And there are a number of things are on the surface of the glacier. Because when we talk about the glacier lake failure, that can be the super glacier lake failure, that can be the flow glacier lake failure also. So when we classify the lakes, we should classify the periphery of that glacier lake, like ice lakes are there, there are snake patches on, there are some trees hanging over the surface of the glacier. So those cracks needs to be monitored, which are prone. Like in terms of Ronthi, especially in the reaction, it was same. The adoption was there, circulation of water is going on, freezing and fire is going on, a number of factors played a critical role, then that slab just broke off. So these are the factors that mentors have already told. We should come together in different aspects, but we should be united. But the problem is that everybody is willing to publish something before somebody else. So when we stop this race, maybe we will have some problem. No end, please. There's no end. Then the discussion will not be fruitful, sir.
I was with Disaster Mitigation and Management Center in 2006-2007. So in the light of that, there was a report which we brought out regarding policies, which was set to mitigate risk regarding glaciers and glacier lakes. So from 2006 to 2022, 16 years, we are today talking about standardization. So one thing that we feel which is, a challenge for us is a time frame. If we bring out standardization, are we going to take too much time to actually set the standards? We have to be fast, right? Then also, if supposing we are mapping the glaciers or glacial lakes, then it should not be confined to a political boundary because the basin does not understand a political boundary. So when you are fixing the standard, then I think you should consider a sense bound political boundary mapping because the lakes can be located on the other side of the country but affect on our side. Then also, regulation of tourists and non-natives in that area plus developmental activities. These are also something which we need to consider when we think about putting standardization in those areas. Then also northeast of India is a very different system. So when you're fixing standards, then are you considering different zones along with their subclimatic systems? Because when we saw that 4,000 years ago, when the Himalayan pack started, Northeast behaved in a very different way. There was almost like a 2,000 year of climate change in Western India, but then there was only 200 years of climate change in Northeast India. So how are the glaciers behaving that side? And plus, the glaciers are located mostly on the Tibetan side rather than the Indian side. They come down a long way, but then of course they carry sediments, and we have our hydropower systems, hydropower projects this side. So are they going to affect our projects as well, and also water supply? So I think this is all from my side.
I think this is very good. Yes, Yara. Professor Kulkarni would like to say something?
Yeah, I would like to pick up from where Ajanta has left. It is indeed a good idea to have a separate sectional committee, essentially because I feel fundamentally many of the issues which we are going to address in terms of science and in terms of standardizations are quite unique in nature, and therefore we have very unique scientific community to addressing this issue. So I think it is a good idea to start with a separate sectional committee, as well as the problems are in vast in nature, like starting point, which is already said by Dr. Ajanta, is a mapping of glacier lakes. That can be remote sensing community can look into that. Then the volume estimation, some of the issues we can look into that. Then there is a dam burst related issue, some communities. Then there is a hydrodynamic modeling related issues. Then there is a infrastructure interaction with community issues. So there are a whole sort of issue related to the risk, vulnerability, and hazards. We need to look into that. So I think we can have a subcommittees within that also, because there will be some expertise will be unique in nature, or some will be interfering with each other. So we need to critically look into that. And I'm sure, I think that is what comment I have to make as of now.
I think that's very good. So,
Sir, I think we should take it forward from here. We should
Yes.
have two separate committees because the genesis
Yes,
of
yes,
the
yes.
problem is entirely different.
very different. And I think the madam also told about
I fully
different
agree with
climatic
Professor.
subzones, and so I think there will be need for separate.
So I think we can resolve it
Yeah,
by
we can
the way
resolve,
that we
yes.
have to put, subcommittees or sectional committees, whatever
Yes,
you call it.
I think-
the BIS.
Yes, yes. That's very important, I think. Yeah.
This is from Maria. I want to add something.
ठीक है after Thakur Sahab. So okay, please speak, and then after that. Yeah, no problem, no problem. It's okay. He has given you permission.
We must focus on another aspect, it is the temperature rising in the Himalayan region. Because the West Valleys are the main source of moisture in the northwest Himalayan region. If the temperature rise of this region, then the solid precipitation will convert into liquid precipitation. So this will give instability to the glacier surface, and the lakes will more and more form in the coming days. So we must think about how we can control the rising temperature in the environment. As I have seen in every presentation that Himalayan region, the temperature of Himalayan region is rising rather than other region of the world. So we must think about this. How we can control the influence of greenhouse gases in the region. And there are the Himalayan glacier not by in the region, but Himalayan glacier is spread with very close to the population. And the population definitely are disturbing the microclimate of the place. So we have to also think about this. Okay, thank you.
That's very good. Yes, Praveen.
Thank you, sir, for giving the opportunity. So I just want to understand, as Rita has pointed out, some of the things that you want to standardize. So if that can be circulated to the expert or the people who are involved, that what will be nice. And the second one, when we, because this is the first time I have had this interaction with the BIS, in our graduate schools when we studied, so we had the standards for the construction, then for the meteorological observations. So what is the scope of the BIS? Because if we start standardizing the mapping of certain thing, so has it been done before? Because if you start standardizing the mapping of the glaciers and that also with the remote sensing data, then tomorrow you may have to standardize the mapping of the forest, standardization of the mapping of the agriculture area, standardization of the mapping of the water bodies. So we should define our scope. And then regarding this GLOF and LLOF, so this is, in my personal opinion, it is a subset of our dam break. One is the man-made, we know the construction, we know how that failure is there, and there are a lot of observations are there where actual dams have failed, and those empirical equations are there, and those are being part of, some are part of code, some are part of the literature. And this is a natural dam, unconsolidated material, and landslide, it is also a kind of natural when this is there. Dam glacier takes more process. So what we want to standardize here is the volume, the depth, and how it will breach, how the scenario that will be generated. So because we have to have this mathematical control over this. Otherwise, there are certain open questions in the science. I cannot standardize the glacier velocity estimation. It is an open science question. It varies with the season. It varies with the type. It varies with the location. So we have to see what is the scope of this standardization and up to what extent we can go. Otherwise, from the national perspective, when the Central Water Commission, I'm speaking from the government perspective, because they already have the base map, and when they do the monthly inventory, they do every month, and they take the base data and then they overlay with the latest image and the change and then circulate with the expert members. So that is one way of looking at. And then similarly with the vulnerability, is there precedence that we have identified certain codes that we have standardization for the vulnerability? Yeah.
So regarding the map, so mapping, when you do the mapping of any lakes in the Himalayan regions, that could be a kind of information available. And this would change with the time. Definitely, new may crop up, new lakes may crop up, कुछ बह जाएंगे, so they will get washed away. So now this is not a standard. This is not standardization. This is a information available to the country in form of, it could be a informative booklet kind of thing. But when you will decide through some methodology, I don't know that methodology, experts will decide it, but that methodology to say that this lake is vulnerable and this is not vulnerable. Now this will become a standard. So we will write in standard those things, so that even in future, if new lake comes up, so based on our guidelines, we will be able to say, okay, this is vulnerable, so we should take care of this lake in this way, otherwise in this way.
That is where the problem will come, because it is very subjective in nature. There are 12 parameters, and some parameters you need to measure in the field. So what I saw the three board, you cannot go to every lake But freeboard is very important. The slope, if you don't have the good quality digital elevation model, so what I am trying to suggest to define the scope of our work so that we not delve into such a broader science questions that we are not able to come to a particular formula. That is my.
This is the problem of entire water resource sector, actually. Because we deal with the 17th section, 20s, and we know that everywhere there is empirical formulas and everywhere the formulas are changing and now not fitting into the actual field.
It's basically hydrology. It starts with physics.
One of my cases that in Boulder reaches, the flow is being flow of rivers taken by Lacy's formula, and now there is a huge problem with the Lacy's formula. It is not applicable in Boulder reaches. Flow is not laminar there. So for the last so many years, we are fighting in the committee that let's make some other Gardes method or there will not be any.
Yeah, but we get different version of standards also.
Yes.
Sir, the second question you raised, sir, ki apart from that location, many things could be there which cannot be standardized. Now, maybe that in case of freeboard, then to start with, at least throughout the country, we need to have one system of, then we can be conservative at this stage of time and move ahead. Maybe after 5 years, we will be having some good data and we will be able to give some better formula also for that. So the standard is not fixed. It is changing. It can be changed every 6 months also. No issues with that. We can go with the amendment. We'll go with the revision. This is a continuous process of updating. So at least when we will start, we'll start, maybe we can start with conservative values and conservative guidelines, but so that we are safe, and in near future, till the time we are having more data and more research, we can be safer with those guidelines. And in future we will change, sir.
Standards are also dynamic.
Definitely, sir. Definitely. So Kulkarni sir said ki we should not restrict the science. Science is changing, new technologies and new methods of calculating the volume of the lake may come up. So we are not going to restrict it. These free guidelines. We write code of practice. Well, it means that this is the best practice available in the country, which everyone should adopt. But it never says that you cannot adopt anything other than this.
Measurement in rivers. There are
Yeah.
version and fourth version of to compute flow.
Yeah.
With the time, with the development, now you
That will be always there, that will be always there. I think
स्टैंडर्ड में हम तो स्टैंडर्ड का एक छोटा सा ड्रॉबैक है कि we need a standard practice. Sometimes a new technology come in and people are ready to adopt it. Okay, new method is there, we will implement it in the field and we will say कि result comes or not. But when we write in the standard, then we become a bit conservative and say कि okay, ठीक है, use कर रहे हैं, give us the data for success of this. ऐसा ना हो कि हम लिख दें और everyone start using it and then after 5 years we come to know कि नहीं तो it was not successful. It is crores are spent on that projects. So that is a serpent kind situation. We have to be, they are dependent on us and we are more dependent on them. So yeah, please.
Can I add something here?
Sir.
Yeah,
Yes,
if I understand correctly, we are not talking here of standardizing results, but we are probably talking here about the standardizing steps needs to be taken to arrive at those results.
Yes, sir.
Yes.
Sir.
And those steps, and there is a further standardization of those steps, how to do about those steps. And there maybe we are open up to certain extent that new technology comes, it can come into that. But if I want to say this lake is vulnerable, what are the things you should look for that? that is probably first level of standardization we should look before showing that it is vulnerable. So I think if that is, if I am correct, if my understanding is correct, if I am not correct, you can correct me, so.
Can I come in, sir? Perfectly, sir. From my side also, I feel because first is because Glacier Lake is dangerous for flood downstream area. So we have to identify whether this glacier is vulnerable or is it serious to us. It can lead to flash flood downstream area. For that, as I mentioned, if that glacier is, if it is increasing rapidly, we have to see one is, this is one parameter. If it is linked with the mother glacier, the lake, that is also like that. We have to see which are the parameters which are serious related to that glacier that has to be seen, and accordingly the glacier has to be taken up for study. Right now, regarding method, one is saying with velocity area method is quite common for the discharge measurement. Earlier, we used to have gauge with the help of only gauge post, physical. Now we got radar system. So technology can be put because method result is same. End of the day, what we are going to get is water level. Water level, how to measure with the radar system or gauge, that as per the time and the available or technology we can adopt. Thank you.
Thank you.
Thank you, Tubat.
hand raise करना है, Professor Jagannath.
In addition to the glacier lakes, there are also landslide lakes that are there. So is there any plans to also form committees or any subcommittee or a subcommittee within the overarching theme of the law that looks at the characteristics or the properties of the laws as well? Because altogether it's a different problem. And the reason I say this because the kind of instrumentation that you would require for mapping the GLOFs or the glacier, not the glacier lakes, are more or less the same instrumentation you can also use for the landslide. So my question is that how the landslide lakes fit with this whole framework of this.
So after hearing so many things, very important things, I have summarized few things. So I'm Swaraj Vijay, I'm a faculty in the civil department at IIT Roorkee. So if I would like to study glacier lakes, first of all, I would like to standard inventory of glacier lakes. And that includes not the annual maximum, I would say. Right? So because now we have some satellite remote sensing data that we can monitor lakes in the winter season as well. And so I think we should have an inventory where we have an annual minimum and maximum of these lakes. So they should be there because when I start something, that I should have like in the Himalayas, do we have standard products? When we say standardization, of course, all the steps are important, but there are some products which actually are important for everyone. So this is something I would really like to emphasize. Then, of course, second question, are there any lakes of high concern? Because we have some historical events that we can revisit. And, most of the people are emphasizing that glacier lake area, volume, surroundings, every glacier lake outburst flood leaves a signature in the surrounding. When we revisit those events, I think we can standardize, all those points, which should be informed to everyone. So when we just create a standardization, that we should have we should mention that we have an understanding that these are the variables that play a very important role in glacier lake outburst flood. And we have historical events in 2013, 2021, and of course 2005. So I think these are the things that should be standardized. What are the factors that we have clear understanding, and we should mention that. Any improvement in the methods, I think we have a number of papers, and our students also review these papers. When we create working groups, why not, if there is a new method proposed, why not our committee does a
validation and reproduce the same results. And then propose the committee, okay, look, now it has been 6 months. These are new methods which are implemented in years, and then we endorse this. Something that, that we also take science along with this. Of course, standardization is not being taken up for the open science question, as you said, and I think but there are several things which are already standardized in terms of steps and products. I think we should start with there, and afterward, I mean, this working group are scientists anyway. So why not we just keep on evaluating all the new methods which are proposed, and then we can always give you our feedback on that. So that is what I must.
Okay, Saurabh, thank you. I think Dr. Jagannath, I think from so.
Yeah, I would like to take 1 or 2 minutes. At the outset, I would like to thank all the learned presentations. I must thank, but I have a few observations. Number one, there are some gaps in the whole, the day's deliberation. Gap number one, International Lake Environment Committee under UNEP has been doing since decades in-depth analysis on the lakes management. Point number one. Point number two, as a innovative member of World Meteorological Organization, where we are looking at drought and floods, there are some nature-based solutions which are becoming very pronounced. In case of our glacier and Himalayan ecosystem, I think we are not alone, because now the new technological, especially satellite technology, has been able to give about 3 mm accuracy in the ocean level changes. That is what IPCC is all about. The science is already there. Science is already there, but we need not have to reinvent the wheel or think that we are alone. No, we should be actually working together. This is the second observation. The third and the most important, science is always changing, as somebody rightly pointed out, but we should not depend on technology, if you ask me. It should be more of science, and more of science, because it is science which is self-correcting, not technology. Technology is only a tool for us, whether it is space technology or otherwise. So I want to conclude by saying that this standardization should come only as a, interim inference, not to start with. So if we start with standardization, we will be getting into a trap. We need standard, no doubt, but standards should come at basic understanding of both global and local situations. So I want to just stop at this, and I want to thank for this great opportunity. Thank you very much.
Okay, thank you very much. Ishwar Das, please. Yes. Ishwar Das. Yeah.
Thank you, Dr. Ajanta. Actually, I was listening to this deliberation since morning. Only my observation as a BIS member, I just want to put forward that separate committee again, sectoral committee for this. We have not reached that stage. Like still, I feel we have in the mostly qualitative analysis stage with respect to all this, GLOF or LOF, what you call it, and especially in these, inaccessible areas, many of our observations are still qualitative. You see, when a standard is made, obviously, like many members I heard, they are telling, it will evolve. Obviously, that's why let it be a part of the present committee. Then when it reaches to a stage like we have reached to a certain level of standardization, then you can think of a kind of separate committee. That is for sure one thing. Second thing I just want to highlight in the process, you can have a like mapping of the lakes, then many people said the area, volume, all this will come part of it when you make a standard. But again, coming to the societal aspect, we need to have a kind of quantitative vulnerability, which in India, okay, globally it is there because risk is also quantified in many of these European and American countries' perspective. In India also risk is being estimated now recently last half a decade. So quantification of this vulnerability then risk, because it is the hazard and vulnerability multiplier getting the risk. Hazard still, there is a kind of scope to quantification, but I feel that vulnerability quantification is not yet addressed in India, which is still lacking. Maybe we can deliberate on that, how to quantify the vulnerability. Then a standardization in the better format can come. Yeah, that's my observation. Thank you.
Thank you. Thank you. Now, Dr. Lohani, please. Yes. Yeah.
Sir, as far as today's discussions are concerned, one thing that I want to say here, that when we go for the standardization, the important thing is that one part is the research, as all of us were telling that. So, specifically in the GLOF modeling, we myself and Jensen, Dr. Sanjay Jain, we are involved from last 15 years. We are working on the GLOF, and we have carried out a number of projects for the various hydropower projects. So now two things are there. One is the design flood estimation for the hydropower projects which are coming up in the Himalayan region. So whether we are going for the standardization for the design flood because of the GLOF, if it is coming. Another part is the if we are going for the flood hazard method, there are some urbanized areas there. So we have to develop some flood hazard map. So another, that is the final output what we need. So prior that, then is the modeling part, another part inventory is there. If there is no habitation, we don't have to say anything about the GLOF. Some impact is there, no population is affected, no hydropower is affected. So I don't think there is any effect of that. But if some glacial lake is there upstream of any hydropower scheme, or some upstream of some city or the villages there, so what will be the impact? Then the part comes that inventory of the glacial lake. So the inventory still, if we see 10-15 years back, inventories were not there. Now NRSC and Central Water Commission, they are continuously having the monitoring of the glacial lake. They are preparing the inventory. So one part of the inventory is there for the glacial lakes. Now comes the point that which one is the vulnerable lake. So a number of criteria are there to find out the vulnerable lake. So as some of our speakers they have mentioned from Vadia also, that few factors what we do consider, these are theoretical aspects, but do we have those aspects which are really taking place in the field itself? So we have to take consideration of all those aspects also. And then depending on the areas, whether the same factors are applicable to the glacial lakes which are falling in the Uttarakhand area or the northeastern area. So we have to prioritize or give weightage to different parameters accordingly. So we have to decide all those things. So some of these things, standardization, we can go for that. Then the another part comes when we go for the modeling and another part. So modeling, as Dr. Arya, he has also mentioned, there are certain things that right now we have a specific kinds of the tools which are basically modeling the clean water. Okay, so with those kinds of the model, we are right now running the carrying out the all modeling kinds of things. So do we require some other tools for that? So we have to finalize the tools also in the basically in the BIs also when we are going for the standardization. So these are some of the things we have to consider while we are going for the making any standardization for those things. So one part is the research will go on. We will go on, and then in future also we'll get the much better resolution data also. So right now what happens once we go for the modeling from the glacial lake up to the project site, normally what we do, we carry out the modeling through the cross section what we get from the DM, digital elevation model. So that depending on the resolution of the DM, if we get the more finer resolution of the DM, we'll be getting the more accurate cross sections. So all the modeling that depends on those things. So a number of things are there, but with the right now available technology and the data set, we can have certain standard and we can work on that.
Okay, sir. Thank you, sir. Thank you. Sir, next, sir.
Yes.
For taking, but I think most of the discussions have been done related to what has to be done, what are the research skills, what has to be done. So I just had, I'm working in the area of coastal flood management, flood management. So we have a very important discussing what flood hazard. I'm talking something related to the hydrodynamic part. So when we do something on modeling, we talk about what is the frequency of severity when the flood hazard comes. So for example, in the case of flood, we talk about the depth of water and the velocity of water. And if we multiply both of them, we identify the momentum. So in the case of glacial flood, as we know that it is not just water, but also some debris, storms and currents combined with that. So can we standardize some kind of hazard indicator, as we do in the case of normal flood, maybe coastal floods or floods, separate towards the severity to the assets or the public? Let's say the momentum of water is this much. How much severity it should have? If the momentum is less, how much severity it should have? So if you can create some kind of standardization for these particular hazard levels, I mean, I think that can be a very good indicator which can allow us that these are the areas where if the hazard is high, definitely the risk also is going to be high, because definitely these are the vulnerable areas. So just my suggestion that the hazard levels can be standardized.
Okay, okay. Thank you, Professor Monty. I think now we have Dr. Ravindra is there. Is there? No, I think he is left. Then Dr. Manas. Tapas. Dr. Tapas is there.
Yes, sir. Yeah.
Okay, please. Yeah.
Yeah. So basically, I was hearing to the deliberations. I have slightly of different opinion regarding the need of standards. So what I would like to say is that, I mean, we have heard about GLOF. So precisely, a lot of work has been done, part of a break analysis, because we know the locations and where are they. And similar things cannot be done for landslides because they are dynamic and it can happen any place. And the life of landslides, unlike glacial lakes, the life of landslide lakes are not very long. So, but the main question is, as I understand, we develop standards like we have standards before by BIS for landslide hazard zonation. So we develop standards when there are solutions plenty. I mean, there should not something go wrong, so that we should have standards in hand. And as I understand, like for GLOF, already prioritization has been done by CWC and NRSC. So CWC is actively monitoring. There are set of procedures, training happening over here at NRSC for under NHP for CWC officials. There is no third party to monitor glacial lakes. So my question is, are there any other party going there, or are we have plenty of solutions that we should develop a standard so that something should not go wrong? The same question is applicable to landslide also. And if we develop standard, that has to be definitely based on certain instruments. So instruments always vary from place to place, or observation instruments either from space or from the ground. So what we can do is that as we can develop some kind of with this climate change, how to monitor those vulnerable areas either for landslide or glacial lakes. So kind of a continuous monitoring like interferometry is a new technique which is developed. It is now slowly used quite a great detail over India compared to the European and American countries. So this kind of things are evolving. I mean, as a science, it has to be open. We have developed a BI standards from landslide hazard zonation, and it is no more being used by because we have now more advanced techniques like deep learning and statistical techniques. So over a period of time, it become obsolete. So my submission is that we need to also deliberate the need of standards by BIS for this GLOF and LOF. Thank you.
Yes. Okay. Acha, okay, Professor Maheshwari will be the last one of the day. Yeah. Okay. Yeah. Quick remarks. Maybe. Exam schedule. Okay.
So there are a lot of debates going on related to this system.
Exam mein jana
A little bit I'm the two committees of BIS. One is the CD 39, which is an obstruction committee, and another is CD 49.
ये बात भी शेयर नहीं है 5:30 6:30
So though these are the older committees, but that is always increasing. So the standardized, the methodology can be standardized. Whatever the data available, rather than say the instrumentation another part and technique, that keep changing. In my view, just I want to summarize. We need a standardization. We need to decide what is the scope, and the scope I think it would be related to methodology and what are the parameters which need to be gathered from the field and then further methodology for analysis. Now coming to these two committees, I think because of glacier lake and landslide lake is a different aspect. Particularly landslide triggering parameters are different than what we have in the glacier. So certainly we require two different committees or two subcommittees. That is my remark or some. Thank you very much.
Okay, thank you. So, Professor Diasaria.
So my quick request to the committee member here is that I have used standards as students also, and I found them very easy to apply, to use, and to get, whatever it was required, be it a project or be in my student life. So whatever this committee does, we keep it as simple as possible, as we can use as a student, research scholar, or scientist. This is the only request I have. Do not add too much of complexity so that, only experts can use it. So this is the only request I have.
Okay, so I think we begin this session with the introductory remark of Professor Singh, and I would like him to say a few words in the last, right?
I'll just make in 30 seconds. First, I think it will be a lot better in order for the committee to prepare a report that each one of you sends whatever you think should be incorporated in the committee report to Professor Oz. Each one of you.
Yeah.
And also take no more than a week. Don't sit on it, otherwise you will tend to forget. Second, there are a lot of terms that all of us are using which are not universally defined. So before you start setting up a standard, for example, I give you a very specific example from a scientific perspective. How do we define risk? Risk, statistically speaking, is nothing but the product of the probability occurrence multiplied by damage. How do you define hazard? Hazard is nothing but the ratio of the probability density function divided by the survival function. Is that the way you define hazard? That's the way I define hazard. That's the way the science defines it. So you be very careful as to the terms that you are going to be using. Define them in a very unambiguous way. That's all I would say. Thank you.
Thank you. And you'll be pleased to know that Professor Singh is here with us for, I think, 9 months. So if you can send your views in 1 week's time, after he has agreed to provide all the help. So I think we'll come out with a better, course, right?
Yes.
Okay, so that's what the goal is. So in the last, I think I would like to thank all my colleagues, particularly Ajanta and Mohanty, and then officials from BIS, for making this event successful one. And I'm also grateful to all of you that you really made it successful. So I hope that we all work together for a wonderful code, which can really help for the benefit of our country. Thank you very much. Right. Thanks. Right.
So on behalf of Bureau of Indian Standards, I thank you all for joining this program since morning and having a brainstorming session. We hope that all of you will respond within a week's time and send a page of your views to the, Mr. Oja sir, so that we can go ahead with the next level of this one. Probably what I would feel is we need to have standardization. There is no second go in this. But during the standardization process, what are the subjects, what are the topics we have to see? Mathematical model is required. Data is available already. This monitoring is going on since 2005 onwards. Monitoring is going on, and even records are available up to 2020-21. So based on this, at least we should start with the guidelines. We should start with the guidelines, then go ahead. And if calls for, then definitely we have to go for a sectional committee. So this is what I feel. Anyway, it is open to all of you. Today is 15th. Maybe by end of by 25th, we will be expecting inputs from all of you.
Yes.
Anyway, thank you very much. Thank you.
Yes. Okay then. Bye everybody. Right.